today, what we're going to be covering is the Gen 4 stuff. Some of you guys are still on the Gen 3 stuff, which is fine. Nothing wrong with that at all, right? But the majority of it is going to be looking at this stuff here. Okay, so we're going to be going over all this fun stuff right here. So just to kind of go over a quick background, I think the majority of you guys are 4. I know some of you guys are 3, right? So if I get raise of hands with a 4, how many I got here with a 4 right now? Right there. Other guys are 3. Other guys are just learning. You're pretty much 4. You're pretty much 4. So yeah, but you still have your 3 somewhere, I think, though, somewhere, you know. So anyways, yeah. So we're gonna basically get into the software. So what this is gonna be is this is gonna be a high level overview of the stuff. Unfortunately, I can't go as as far down as I want to with everything, but hopefully you guys are going to get the high level overview of how we actually adjust stuff and make parameter changes, and when you see stuff, what to actually do. Okay. But as far as architecture of how everything goes, if you guys haven't seen it before, for those haven't, this is the 4. It's not a 3. A lot of guys get confused that unfortunately it says a 4, but they don't know the difference between a 3 and a 4. Okay, so the box is built to actually go and interface with the 3. You take the 3 out, you put this in its place. Okay, so a couple things about the box. If you actually look at those flyers in front of you, the box has a built-in gyro and G meter. Okay, so a lot of guys will talk about things as far as auxiliary modules that you have to get, but basically the box is built to house a bunch of stuff inside it. Okay, so G meter, gyro, all built in. What's nice, obviously, about the G meter is it tells acceleration rate. The gyro tells your side to side. So with the side to side stuff, if the car is getting squirrely, we'll get into the custom programming. But if the car takes a big hard right to the turn, or turn hard right or hard left, you can pop the chute out, right? Because it's swinging left or right. It's all built inside of the box. Okay. The box also features 2 cores, so that you got an engine side running and you got a data logger side running. Okay, so that's how everything is split up. So we're not trying to always, nail down one processor, do everything. Okay, so box was built in mind to keep all that stuff separate. Okay, also too, with the big bands, I know that some of you guys are using this, and this is where you guys have the extra O2 sensors and everything, right, that you're looking at. And again, we're still the only one that pretty much do it, but we've got Ethernet as our CAN bus. Okay, so for an ECU that's under $2,000 to have CAN bus be Ethernet, that's pretty freaking cool. Okay, so we're still pretty much the only one on the market that does that today for under $2,000. And again, for under $2,000, whether it's 600 or 6,000 horsepower, this guy will do it. Okay, so just remember that. The boxes can come with race pack connectors and Dakota digital connectors and anything you basically want over here. We're open CAN bus for all you guys that want to get into CAN bus type stuff. We can talk about that later, but basically we're not locked down. We're all open CAN. Okay, so any type of auxiliary devices you want to run, PDMs, touchscreen dashes, whatever you guys want to use, we're open. You guys can use anything with that. Okay, so just real quick here, I'm not going to put anybody on the spot here at all, but like, what are you guys looking to learn here as far as me talking up here? Because I'm not going to talk all day, and whatever you guys are looking to kind of touch on, I'd like to know that. So Bob, can I start with you real quick? What are you looking to learn about today? Okay. Okay. Right. Okay. 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 Yeah, we got a lot of acronyms in this damn box. A lot of like, what does SR2 mean? And what does ETM mean? Right. So we'll go over all that stuff. It's acronym heavy, but it's just part of the deal. You know what I'm saying? Don, how about you? What do you got? Okay. Data logger.
Basic stuff to see.
Yes. Okay. Got it. Makes sense. You know? Yeah. Okay. That's cool. Okay. Chip.
There are 4, of course.
Right.
But trying to get like a real, give me a reason why I need to get out of my 3.
Sure. Sure.
And it's very obvious from all the things that I've seen you put up on YouTube and whatnot.
Right.
But just might need that little push over the edge.
Sure. Got it. Okay. Got it. Okay. You? Yeah. Okay. All right. Dan, how about you? Oh, by the way, real quick. So we got Dan here. So what we're also going to be talking about today is I thought it would be cool to bring him in. Dan is a in-cylinder pressure control specialist, if you would. Okay, Dan does the voodoo magic of in-cylinder pressure monitoring, spark control. So I figured that a little bit later today we could have him talk a little bit about how they work and what they do, because I've seen it firsthand in person. I've seen it remotely, but when I saw it in firsthand with him, I said that is just the coolest thing ever. So to be able to literally take a motor that you hear just pissed off and then just sounds like that perfect little bell ringing when it's just happy after a couple pulls, that was pretty cool. So he's very talented in that respect. So, but yeah, it's really cool. Awesome. Thanks for coming. I appreciate it. Tom and just to kind of pick on Tom and Russ there for a little bit there. They actually just picked up a Wally last weekend. They run the Gen 4 system with the big bands, 8-channel closed loop control. It's really cool because we're still the only box as of now that actually is closed loop per cylinder. So you literally have every fuel injector in closed loop per cylinder. And the only reason why we can do this is because the Ethernet, when you're talking 100 megabits as your CAN bus, it just doesn't care at 12,000 RPM. It can do it in real time and still get it done. So yeah, you got to slow it down. You got to slow it down. So there's some AFR settings that we'll get into it on how to adjust how fast in closed loop it does correct. But you're right. When you go to 8-channel and you've got that one fuel injector with that 102, you've got to slow it down because it'll be too fast. Yeah, it can't take off on you. So you can use that basically in any application, even on methanol if you want. It just can't be turbo boosted. So you can actually be closed loop in any combination for the most part, just can't be methanol turbo. And methanol supercharged because you can only use an NTK sensor. So this only works with the Bosch sensors, okay? But it is still a really cool technology that nobody has. And again, for the price, you just can't really touch it either, okay? So there's going to be some things throughout what I'm talking about. Oh, I forgot Brian. Brian, go ahead. Brian, what are you here for, Brian? He's lying. He answered. Yeah, he's on tech support too. Don't listen to this guy. Trust me. Yeah, there are a lot of Brians around this. It's amazing. We talk. It's just incredible how many. Yeah. Yeah, well, he'll be taking tech calls here shortly, though. Yeah. Right. All right. So a couple things when I'm talking here is I'm gonna say if you're taking notes, cool. If you're not, just kind of pounding your brain. And this is gonna be one of them here. One of the most I wouldn't say problems, but sometimes guys have connection issues talking to the box. And because this is Ethernet, okay, Windows don't like us. Okay, Windows can be a pain in the butt sometimes because it doesn't know what this connection is, and it's going to basically lock you out, and you're going to try to go online, and it's going to say no connection. You're going to come over here to your devices tab, and it's covered up by these guys, but it's going to say you can't connect. Okay, so to fix that, all you have to do is if you go in your control panel, if you don't know how to do that, just type control. Okay, and you're going to go in your control panel, and you go system security right here, and Windows Defender Firewall, and then you're going to have turn Windows Defender Firewall off or on, okay? Just turn it off for both the public and the private. So I've got these turned off here, okay? And when you do that, all of a sudden, magically, everything works, okay? So Windows will kick in, and you know what? It doesn't know what you're connecting to. It's trying to keep you safe. It's just doing its job. But turn it off, and then for the most part, you'll have no problem connecting to your box every time, okay?
Can you turn that back one after that?
Absolutely, absolutely. Yeah, it's just that when you're working, yeah, it's when if you have a computer dedicated to this, just keep it off, right? But if you need to go back online, you want to have it on, you know what I'm saying? Put that back on. But it's just the most common connection issue that we have because we don't have serial USB connectors. That's all out the window for us. You may have a USB Ethernet adapter, but you know, to us, the USB connector is old technology now. Sorry, Gen 3 guys. Sorry, you know what I'm saying? But yes.
So is this being recorded so they can go back on YouTube and
Yeah.
So just so you guys know.
Yeah, the whole day is going to be recorded. So yeah, if you actually look up there, we're going to be recording all this stuff. So the back of your guys' head will be up here for infamy, just so you know. So yes. Right. Just a heads up with that. Okay. But yeah, that's one of the most common things when you fire up the software. If you guys are at the points where you don't even know how to fire up the software, get with me. I can help you with install, configuration, all type of stuff. But that's the most common thing is the connection over Ethernet because there is no other way to connect to this guy, especially guys that go to 3 to the 4. It's like, hey, how do I connect with this guy? My USB cable. It's like, you just don't. There's no more USB. It's all gone. unless you have to have a USB to Ethernet, which is totally fine, but there's no more serial. What's neat about this is because it's true Ethernet, I've got some customers in Southern California. I'll go out in my rental car and we'll go down to the sand dunes. And because we're just straight up Ethernet, they'll be out 3, 4, 5 miles away. And I'm tuning from my car in the air conditioning, and they're out just bombing around the desert. And they've got extended range Wi-Fi because, you know, the router just thinks it's just Wi-Fi, right? So you literally have, you know, F1 technology right here, literally in this box, and it just doesn't care where you are. Okay. So just remember that. Okay. And yes, at the drag strip, you can sit in the stands, and we've done it before. Hit record and watch the car going down. I'm just saying if you want to, okay, if you wanted to do that, okay. Yes, you can get extended range routers to put them in the car, and they got some high amplification, and you can go out very far, especially like where we are out there where there's nothing around you. I mean, the signal just goes for so long. Okay. So, but again, the router doesn't care what you're plugging into. This is just a computer that it's talking to. So the router don't care. Okay. So anything you guys want to do with it, you guys can work on the Ethernet side of things. Okay. So any questions about that? Does that make sense? It's all Ethernet now. No more serial, no nothing like that at all anymore. Just so you know too, when you go from the 3 to a 4, we made it really easy. The only thing that you actually do on the engine side is actually cut off the O2 sensor. We give you a new Bosch 4.9. That's it. So literally the engine side is done. There may be some stuff on the secondary side. It may have to move around a little bit, but the 3 to a 4 literally takes about 10 minutes to do. It's that quick. And for our customers that need a calibration, because there is no magic convert a Gen 3 to Gen 4 calibration. If we have to do it, which is totally fine. We do it all the time, and we'll give you that cal. So for something like you, we just get the cal, switch it around, and get it back to you. That's how that works. Okay. All right. So connection issues, that's pretty much it. When you guys log into the software for the first time, everything that you guys are going to be able to look at is going to be in these menus over here. Okay. So system, fuel, startup. If you have any basic fuel injection knowledge, then this will be somewhat familiar. If not, depending on how the box is optioned, because we keep the price down for a guy. If he doesn't need all the traction control and boost control and stuff, he gets a cheaper box. Okay. If you have more options, you know, it's the sticker that we've always done. The back will tell you what it came with originally. Okay. And those options will be available, right? If a guy got a box without traction control, he's not going to have the SR2 shown because he doesn't have it on his box, right? If he didn't get the boost controller for CO2, it's not going to be shown because he didn't get it on the box. If somebody wants to get something down the road, I'm sure you guys remember having to send the boxes back in the day. If you guys did that, there's no more of that. If you want to activate something, just give us a call. We open up the option. It's $150. We email you a file. You put it on the card, turn the key, and it's done. Okay. So no more having to send the box back to actually activate anything for us. Okay. There are a few things if you want to add, like the NTK sensor for alcohol. If you want to do transmission control, there's a couple things that have to come back, but for the most part, it's all just done. Just flip a switch and just turn stuff on. Okay. So when you guys come into the software and you're connected to the box for the first time, if you don't have a cal, if you need a cal, you let us know. We can help you out. On the website, there are cals you can download based on whatever your combination is. Okay. But if we're just going to dive into this right now, and we're going to start going here basically into these certain sections. Okay. And again, this is going to be high level overview as far as what we're getting into. If there's certain stuff that I think we should dig into more, I'll definitely get into it, but I can't go into depth of all this stuff for obvious reasons. Okay. Only got so much time here, but the first one, the most basic one, is firing order. You'd be amazed how often this is messed up on new starts and just firing up combos for the first time. Okay. It's incredible. So firing order is very simple. We're still the only manufacturer to where we can do sequential fuel without having a cam sensor. Okay. And the way that means, or what I mean by that, is if you have a car that's distributor based with a points output and MSD box, the way that the fuel injection harness is wired, you can actually add or subtract fuel without a cam sensor. Okay. So if you guys just want to run a box, you guys can actually still do individual fuel without a cam sensor. Still the only one that does that. Everybody else, you need a cam sensor to do that. Okay. Because it just follows this firing order based on what you plug in, and the fuel just goes because of the wiring harness that we have plugged in. Okay. But if you're coil on plug, you got to have this correct. You got to have a cam sensor, all that good stuff, or else it ain't going to want to fire off. Okay. So distributor cars, points output, again, no cam necessary. Anything coil on plug, we got to have it. Coil on their plug, whatever you want to call it. Okay. So make sure this is right. Yes.
On the coil on plug, you have a cam sensor, but once the engine starts, it ignores the cam sensor. So if the cam sensor breaks at that point, you're going to complete your run. Then
Correct. Exactly. So a fun quick little story is Sean Fink out in Wyoming went to the NHRA race. There was a special NHRA race out at God, what was the track that was just closed out there in Colorado? I'm forgetting. Brandemere. I'm thinking Brandon. Yeah, Brandemere. So one that we were racing out there. Long story short, he goes and makes a pass. It was actually the winning pass. He came back to the pits. The car wouldn't fire up again. Car wouldn't fire up again. So we'll get into one of the biggest things is, but down here in the bottom, okay, this little guy right here is probably one of the most important little indicators in the system. When the car is cranking over, if that doesn't go green, it's basically flipping you off because it doesn't see something it needs to fire up. Okay. So his car engine was coil on plug and it wouldn't fire up. So the first thing he knows, I want to check sync, which is exactly right. He was cranking it. That wasn't going green. So, okay, it's not going to fire up because it doesn't know. He had engine RPM, but he had no green light there. So he knew something was wrong. Cam sensor, the cam magnet actually flown out at some point. He made his pass. Everything ran great, made a rip, no issues at all. No problems, came back and it wouldn't fire up. And his little magnet flown out. And actually, it flew out. Actually, it went in the perfect spot. You can't believe it. Like literally right below in this little spot in the water pump. He pulled it out, and there it was. So you can make it up. But engine never faltered at all because as soon as it fires up, it locks in and it's done. Okay. So that's what Brian was talking about. As soon as it fires up, it says, "I'm done with you. You're out of here." That's basically it. Doesn't matter. If you have a cam, we use it and we toss it. Yeah, that's it. Yes, it just syncs up and goes. Now, for the Gen 3 guys that have it, you know that cam crank advance value, that number that John likes to have at a certain range, the Gen 3 used it all the time. It was always looking at the cam to crank, okay? We don't have that anymore. We just, as soon as it locks in, it just kicks it out, okay? So, and we don't have an option as of now. If you don't have that and you have coil and plug, it won't restart. So you've got to get that fixed, okay? You've got to get that going, okay? There is no way to fire the car up without actually having that sensor in place if that's how it's being used, okay? So I've had guys that on their MSD cam sensors, they've lost power, they're cranking, no sync. Well, again, it's if they don't have the cam, it ain't gonna go, okay? So that's good. That's a good question, Brian. Okay, what's that? Well, it's usually somebody's fault, you know, so. All right, so firing order, that's pretty basic, okay? Over here in this injector opening time curve, every manufacturer is going to have what they call dead times or injector offset times. That's what this table is. All this is, guys, in all reality is, we're going to get in the VCalc, is basically an adder, okay, based on if the battery's low or high. So you'll see over there 8 volts, okay? It's going to add 1.47 milliseconds if you're at 8 volts. You're at 8 volts, probably not going to run anyways, okay? If you're at 21 volts of battery voltage, which this ECU can take, it's only going to add 0.53 milliseconds. So when the whole VE calculation is made and it says, okay, VE number or VE calculation gives me this much fuel, this is just an adder on top of that calculation for the pulse width, okay? That's all this is. In our world, it's not really that important. Some manufacturers, you got to have that rider for some reason. It just doesn't work right, okay? This is just simply a table that we use to add on based on the battery voltage, okay? The overall VE calc is said, okay, I have this much fuel going in. I'm going to add this number on top of it, okay? So that's all this table is. So don't sweat it. If your number, the reason how you'll know these numbers are really skewed is that if you guys go into the fuel table here, okay, and if these numbers, okay, this is the VE fuel table right here, okay? These numbers are catastrophic, you know, 100 to 150s, 200s, okay? You probably got something wrong with that value. Because again, that gross pulse width number right there, okay, see where it says 4.1 milliseconds bouncing around, okay? That gross pulse width, just think of that as like the jet on your carburetor, okay? That's your jet that's just opening and closing, you know, and in small size to big size. So as you're going down the racetrack, that'll be 10, 11, 20 milliseconds, okay? And all that is the actual ECU tugging on the fuel injector, all right? So if you have to have huge numbers in there, that injector offset table may be too low, okay? If you have numbers in here that are incredibly small, that injector offset table may be too high. And maybe having, you know, too much injector pulse width based on battery. So that's just stuff that we'll get into a little more when we get into the VE side of things, okay? So ball mesh efficiency is basically what 99% of most users are going to run. If you don't want to run a map sensor or care about anti-manifold pressure, we'll get into it. That's where you actually use alpha N. You just look at throttle position and RPM. Okay, that's all they use. That's the only two methods that we use in the box right now. Okay. All right, so pressure and sensor configuration. This is an important one. Okay, so this is where you're going to set up the size map sensor you have. If obviously you got a 1 bar, you're going to choose 1 bar. Now, just so you guys know, these are BigStuff map sensors. So if you guys get them from us, where it says 1 bar, 2 bar, that's our stuff. Okay. If you guys want to run a custom one, you can come down here to where it says custom, and then you can populate any map sensor that you guys want to use. Okay. So if you get a plug, if you get a BigStuff one, just plug it in, choose it, and you're done. Okay. If you get one from Low Dollar, Motion, wherever you're going to pick up another sensor from, this is where you actually plug in those numbers. Okay. And this is KPA. Okay. So you have to make sure that you enter the minimax voltage and you enter in based off KPA. Okay. That makes sense. Okay. KPA and PSI, just based two different ways of measuring it. In our box, in our world, everything's KPA. We do everything KPA, and then we just show you what it is in PSI. Okay. That's why you have to enter this in KPA, because that's how the foundational, that's how the pressure is calculated based off KPA. Okay. Right. So other ones here, guys, it's all just base stuff: fuel pressure, oil pressure, turbo back pressure. Now, these are just factory names for us. Okay. You guys can put anything you want on these. All right. These are just standard, just 0 to 5 volt inputs. All right. It doesn't matter what it is. It can be track temp. It can be anything. Anything that's 0 to 5 can go. Just because it says fuel pressure, you don't have to use it for fuel pressure if you don't want to. You can use it for anything. Same thing for the shocks on the right here, right? You want to use something in there in place of a shock. You don't have to have 4 shock sensors. Nobody expects you to. Just put whatever you want inside there. It's just 0 to 5 volts. Okay. Yeah.
What you have, or you have to keep that?
That name stays in there for time being. Yeah. For the next software rendition, we're working on a different interface. That's you're gonna be able to actually edit that there. Yes. But for the time being, you're gonna have to say whatever that input is, it's going to be tied to right front shock, left front shock, whatever it's going to be. Okay. There are certain ones you have to keep, in certain spots, like if you're using the CO2 based boost controller, you've got to, that wastegate pressure is what we use for CO2 boost controller. You got to keep that one plugged in. Okay. So for like fuel pressure safeties, if you want to run that, you got to actually put your fuel pressure sensor on that. Okay. So there are some instances to where you'll actually want to run those, but they're just 0 to 5s. Anything you guys want to bring into those, you guys can bring in. Okay. Doesn't matter. What's that? On the touchscreen dash itself. Yes. On the dash, he's saying in the software. Yeah. If you're looking at a log, it's locked in a log for now. Okay. So anybody have any questions on that at all? Oh, see here where it says accelerometer signs. Okay. So that's your G meter. So when you guys launch your car, do whatever you're doing, the x-axis or y-axis here, z-axis, is either going to be positive or negative. So what'll happen is, depending on how the ECU is mounted in the car, one of those axes is going to either show really high positive or negative when you launch. Okay. If you're going backwards, if you're going down, just switch these signs around. Just go, if you were positive, it was going negative, just go to negative, and then it'll show a positive number when you leave. Okay. The accelerometer, literally for the most part, sits on top of a race pack. We still got a bunch of race pack cars that work in conjunction with the Gen 4. And if you actually look at the 4 with the race pack, it literally is the same exact number. So, which is good, obviously, right? Because everybody, that's kind of the gold standard is the race pack, right? So you want to be able to have something that, okay, I'm used to my race pack, and yes, it's going to be right there. Okay. And we'd like to have the ECU mounted flat, all that type of stuff. If you can't, no problem. I've had them mounted vertical. Again, if it's not perfectly flat, is it going to be the exact down to a thousandths G? Probably not. Okay. But if you're using it as a tuning tool, use it for your car, use it for your application, and that way you can use it to adjust based on what it's showing you for the G. Okay. Does that make sense? Okay. So that's it for the pressure and sensor area right there. Again, the most important part is that map sensor area here as far as choosing that. So I'll go back to a 5. That's what Brian's car has in it. So we'll just go back to a 5 right there. Yeah. So let's talk about that real quick. So can everybody see how that's red right there? Okay. So all that button is when we're making changes actively, the ECU is taking it. Okay, you don't technically have to do anything for these. The ECU's got it. All this button does is sync up your laptop to the ECU. All right, so if you're making changes and your Windows did an update and screwed you, okay, don't worry about it. The ECU's got it. But the next time you log back in, it's going to say, hey, we got some differences here. What are we supposed to use, right? It's going to say, am I using what's in the PC or am I going to use what's in the laptop, right? So anytime you hit that button, anywhere in the calibration where there's differences between the laptop and the ECU, it's now sunk up, okay? That's all that is, all right? So don't get wrapped up if you don't hit that. Unfortunately, we still have a lot of guys that are newer to the system and they don't do that every time. And they come back up and every time there's differences because they don't do that. So if you get in the habit of making that change and just coming in here and when you hit burn like that, okay, I just hit it. Okay, see how it goes gray? So now that it's gray, everything is completely matched up between the PC and the ECU. That's what that means. There's no differences at all. All right, does that make sense? Okay, so
what you're saying is if you actually make changes, don't hit burn, it's actually in the ECU.
absolutely
It's just not in the laptop.
correct.
So if you connect again, it's gonna say you have discrepancy. Do you
Yep.
want the ECU data or do you want to push the computer data?
Exactly.
That point in sync.
Yes.
They'll be the same.
Yes, exactly it. So again, it will take the change. It's just that if you don't do this step, if you don't get in the habit of it, when you connect up to it, it's going to flip you the bird and say, okay, what am I doing here? Right? Because you got to have some brain power a little bit. You can't just you can't just guess at it. So this way, when we do that, we know that everything is sunk up. I mean, if I just literally come over here and just press an up arrow here, okay, and this time constant right here, look, I just went red, right? I made one change. So it knows I got a difference. What am I doing, right? So just remember to hit burn, okay? And then now everything is sunk up.
You make that change and make it go red again.
I'm gonna go back. I'm gonna go back to 25 here. Yep.
Done something else and you go, oh my God, I forgot what I changed, but I don't want to set it. You hit the back arrow.
Yes.
Go back at it.
Exactly. So anytime you're working inside a window, you'll see that blue and it'll say undo.
Keep clicking at that red will eventually go off when you get caught up.
Correct. Here's the catch. And of course, there's always a catch, right? It's only if this window's open. Yeah. So if that window, if you closed, you can't go backwards anymore because now you're out of that window.
Just like,
Yes, exactly.
I'm just saying, if you put 4 changes in there and you get lost in your mind, because I do that a lot.
Yes.
I can just keep hitting that back arrow until the red goes away, then I know I'm back to square one.
Correct. Yeah. So a lot of times how that,
Guys, I didn't know this.
it's a good question though, but if you actually come over here and so let's talk about the tuning down views. There's no back button here, obviously, right? I can't go backwards on these nice, beautiful tuning and dyno view tabs. There's just no back button. But if I pull up the actual fuel table here and okay, if I made this 1, okay, and I hit enter now I've got the back button, okay? So I just blew up my cow. Oh my God, I pressed 1, right? So now what do I do, okay? Just go ahead and just hit the back button here and then it'll put it all back in for you, okay? It's very simple. So that's what Brian's talking about. If you just want, I've got guys that'll just do the fuel tables and they'll make a bunch of changes and they'll just keep pressing the back button and go back to where they were, okay? And now they're back at the beginning versus just having to load back in a different cal or anything like that at all, okay? So yeah, back button for it. And you can see here, the forward button's open, right? Because I can go back to 1 if I want, right? So if I come over here, I can go back to 1 by just going back, okay?
It's got the forward arrow.
Correct. Well, I can't go forward anymore. That's why the forward is great. I can't choose forward, right? So that I can go back here and just hit back and boom, it's back. So it'll just keep going back, but there's nothing here on this table to change. Exactly. Here in this section here. But again, you'll see here though, that's still red, right? So it's telling you, hey, something's different. Okay. Now, what you could always do, it's up to you. You could literally shut the software down right now, fire it back up and try to connect it. It'll actually tell you graphically, hey, these are your differences. Maybe you forgot what the differences are. All right. So you could always do that too. Right. But that's just the big thing to remember is just that the burn is a good idea, but I'd actually rather to where it's a different name. Burn, for some reason, some people just don't understand that word. They think it's a bad thing. Yeah, save, apply. I think down the road we're going to change that, you know.
Goes back to burned the chip.
Yeah, it's probably something like that, you know. But But the bottom line is that if you see that red and all we're saying is that, hey, there's sun different, just send it down. It's going to go red. I'm sorry, it's going to go gray. And now everything's matching up. Okay. Does that make sense? All right. Since we're on this window too, one thing to remember also is, guys, every one of these windows can be saved, right? And what I mean by that is in the upper left-hand corner, instead of having to save an entire calibration with everything being saved as one cal, you can save every one of these tables individually, okay? So what I tell guys, especially that are dyno tuners, say, you know what? If you don't want to save the whole cal as one, you can just save a fuel table. If you're gonna start messing with this by itself, start going to town. If you get lost, you know, out there in La La Land, you know what? Just load the actual fuel table alone back in. Okay. That way you can literally just have to load this one table versus loading in the entire calibration back in. Okay. So it's really simple. You just hit save and it tells you exactly what the name of this table is. Okay. It's fuel table 1 card. This is just date and time. Okay. So it always applies to date and time. Yeah. You can make whatever you want, but what I always personally, I always just leave this name and I'll just do like, you know, BS or BigStuff. So I'll name it like this here, because what's nice about if you leave the fuel table 1 card name in there, if I save this, okay, if I go load, okay, include additional dependencies, okay, there's no file name in there. So you don't know what this thing's called, right? So if just before you load in a table, if you come in over here and you go file, save, oh, it's called fuel table card 1, right? You know, I'm not going to save it, but this just tells you what this table is called, right? So if I go back to file, if I go back to load, okay, there it is right there. So if you keep the name in it, it's very easy to remember what it's called to go back and load it back into that table, okay? And this is anything. This can be a table. This can be, we'll come over here real quick. You know, for you guys running traction control curves or gear curves, this can be this table too. You know, if you want it, you can literally have infinite tables saved just by itself. So I try to teach guys to actually do this because you can have literally as many first gear launch retard curve tables here as you want. And this way you can just load these tables alone without having to load an entire calibration. Because if you're editing air fuel ratio, fuel tables, there's all the stuff you could be changing in the background versus you could just simply load just this one table in and it makes it way easier, right?
So Ben, based off of that, which I wanted to get to, which is fantastic, can I go in and pull a Spark table out and just load it in?
Absolutely. Yeah, absolutely.
Fuel tables? I don't have to go in, go find out, oh, we have 2 passes to go.
No.
I like that Spark curve.
Yeah.
And I have to go back in and reburn the thing.
Yeah. Every table can be saved. Every table can be saved. Okay. So there's the Spark table. Again, if I just want to save that Spark table and Spark table 1 table, boom, there it is right there. So you can load in just that 1 table. Okay. So yeah. So it makes it really easy that way because a lot of guys, again, unfortunately, they don't take really good notes and you don't actually know all these different changes you've made in the background to all those other parameters. If you just, you know what, I want to load in that Spark table, whatever, just load it in. Exactly. Exactly. That's the point. It depends. You can do it the other way. So many people are just comfortable with just saving an entire calibration, loading in the entire cal.
You want to save that cal for extract conditions, extract.
Yes.
Whether you can save the whole thing.
Right. Exactly. Yep.
It's gonna be a hard habit to break.
Yeah, I know. That's what I'm saying. We're all used to saving. Yeah, you're used to saving the entire thing, right? But that's where, especially with traction control curves, I mean, you could have all these different engine RPM plots, drive shaft plots, right? And you could have all those stacked and saved. You know, you could have, you know, I'm just talking a 550 to a 530 eighth mile for traction control, then a 520 to a 50, all these different curves just labeled and just load that curve in and you're done. Leave everything else alone. So it's a different way of thinking, but for the guys who I do know that are working with it that way, they really like it a lot because ultimately they have to worry about, oh my God, did I make an air fuel ratio target change, right? Did I change something in my Spark tables? If I'm running multiple tables that I make, you know, you can get so lost in the weeds, all that stuff, right? And if you just focus on just that table alone, you have no danger of wiping anything else out. because you're simply just targeting that table, right? You only have to care about notes for that table. That's all you got to care about. Okay, does that make sense? Okay, so again, it's kind of a habit. It's kind of a habit to break and to not come in here and go file, load tune and load an entire calibration. It takes a little to get used to. It's not that you can't do that. It's just a different way of doing it. That's all. Okay. So, any questions on that? That's obviously a big, area. Any questions on the pressure sensor by any chance? No questions on that at all? You simply, that's how the software comes. If your buttons are up here like that, you just left click and drag it over to here, and they'll just stack on the left-hand side. Just a viewing preference. That's all that it is. Okay. Yeah, that's why. That's why. So over here in this pin configuration section here, basically this is where you can set up individual pins to do whatever you want. So this cal actually has the transmission loaded in here. I'm going to turn this off because when you turn that off here, okay, all of a sudden, boom, a lot of stuff isn't grayed out. So what I want to show you here with that is, if I have the transmission turned on, watch what happens to a lot of these inputs here. Come over here. If I enable this guy, okay, see how all that stuff just went away? Basically what it's saying is you can't have those inputs and outputs anymore, okay, because the trans got control of it, all right? So I'm going to disable that, boom, everything's back up and open, okay? So on these inputs and outputs section here, for streetcar guys, used a lot, okay? Obviously you have on digital outputs, you've got fuel pump outputs, you got fan outputs, okay? Basically, the AC override, if you got air conditioning, it'll turn output on to bump up the RPM or turn on the actual AC compressor, whatever you want to do. But all these are just outputs. These can be used for default purposes, or if you guys want, you can just come over here and just choose general purpose. And then this is where you can get into all the custom programming. And we'll touch into this here because we are here. So literally on any output, you can make it do whatever you want it to do based on whatever programming you guys want. This is where you get really lost in the weeds, okay? Remember I was telling you about on the gyro, if the car gets, lost side to side, you can come over here in this generic section over here. Let's just say, for example, I'm going to choose fan 1, all right? The fan 1 output. See right there where it says fan 1, enable over here on the right, GPO5, okay? If I choose this fan 1 low side here and I hit enabled, okay? I can now choose up to 4 active conditions to turn that output on. All right. So common stuff is for like, dump valves or, any type of shift output if you want to do something. I mean, it could be anything, you know what I'm saying? You can do anything that you want, and you can add in up to 4 conditions here. So you've got 4 different conditions you can program, okay, to turn that output on. You can take it over, do whatever you want with it. All right. So all you got to remember is you set it to general purpose over here, coming over here to the generic section, program it however you want. If you guys want more help on the output channels, I'll be happy to go over that with you later. But basically in this output channel, this is everything that you can imagine that's in the box, okay? This is all the G meter gyro, 2-step, 3-step, when the first gear retard is activated. I mean, the rim module EGTs, okay, all the individual O2s. I mean, anything you want to do, you guys can do inside here. All right. It's just literally up to your imagination. We also throw an active delay and an inactive delay and a pulse time. So all that means is that when the output channel conditions go true, if there's an active delay, we're going to wait X amount of time before it actually starts. Okay. Inactive delay means when the output channels go false, it's going to hold it on for X amount of time and then go false, right? And the pulse time means that it's only going to pulse. So if something goes true, it's pulsing and it's stopping. Okay, that's all that means. Okay, and every one of them is set up that way. So any questions on that at all? Again, this is kind of high level. I'd love to go into this more, but this is how you guys can program anything you want on basically any output. And also this applies to the PWM stuff, which we'll talk about later. But that's how you can do whatever you want in any of the outputs. Questions? Does that make sense to you guys at all? Okay, good. So all the outputs that you can play with are over here are listed on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 outputs right here. If you add the touchscreen dash, then that has built-in outputs as well. That's not over this, but you can configure the dash as well. It has its own virtual switches. Like I've got a guy that actually just called me yesterday. He wants to have it on the dash to where he hits that button and it's going to activate the trans brake so he can go in reverse the whole time. You can do it from here if you want, but the virtual dash will hold that output. Trans brake goes on. Now he can just be in reverse as long as he wants. You know what I'm saying? Because the touchscreen dash has its own outputs. Okay, so it just depends again on whatever you guys want to do. Now you can come over here and rename this guy. So if I come over here in this section, okay, set an alias name. Let's just say I want to call this dump valve. Correct. No, it's not glove worthy there, but you can come over there and you can change names of these. So if you guys have some custom, some custom programming on an output, you can come over here and say, oh yeah, I want to go make a change on my dump valve. Well, you can change it here. All right. And obviously, again, you'll note here that I got red, it's burnable. Now, one other thing, this is one of the things I really implore to write down or just take a good note is, whenever you make a change in this section, you have to restart the ECU, okay? The reason being is because whenever the ECU fires up, this section of the ECU fires up. So it reads it and goes, okay, what am I doing in the generic section? It loads it and pushes it in. Just because I made these changes right now, it's not active yet. Okay, so that stuff only goes active on a reboot. Okay, there's not very many things that have to be restarted, but this is one of them. Okay, this is also too, guys, all your, again, we'll get into this here. We got advanced tables for fuel, spark, lambda, boost. We got all these generic tables. You have to activate the generic tables through this as well. All right, so let's just say you want to add on a fuel adder so that when the engine's cold, I want to add an additional 15% of fuel for whatever reason, right? You'd have to say, okay, coolant temperature coolant is less than 180, So you come over here, and this then actually will activate a custom table for you for the fuel side. All right. So generic section is really powerful. It basically lets you do anything that you want for the most part with fuel table sparkers, your boost controller, all your outputs, your PWMs. It's sky's the limit. Okay. So I've never had anything I can't do with it yet. I'm pretty sure there's not going to be anything we can't do with it. Okay. So that makes sense as far as that goes there. And again, what's that? I know. It's kind of, we're running through. Okay. It's already, I know it's quick. So it's already been an hour. All right. So that's how fast this goes. So I know, right? So let's go to the analog inputs here. Analog inputs, we talked about the shocks, the laser height sensor. Okay, a lot of guys use this, and that's obvious for obvious reasons here. If you have a laser height sensor, it can read how high the car up is, activate a timing table, pull a bunch of retard out. Okay, this works really well. Digital inputs over there, upper left-hand corner. Again, if you want to flip a switch on, do some custom programming in the generic section. I got a guy that says, hey, I want to have when I come back and make a hit, I want my water pump, my cooling fans to turn on with a switch. Okay. Turn on the switch, right? Let's just say we choose one of the nitrous inputs. We then activate two outputs to turn on his water pump and fan, right? Okay, it's all programmable, however you guys want to do it, okay? PWM outputs over here. We can talk about this here, but if you guys do much PWM, basically all that is, you can vary the output from 0 to 100% to control stuff. So going back to dump valves again, whatever you guys want to do, you can control how hard the dump valve is being controlled pulse modulation wise, okay, versus just off on. All right. So this is where the pin configuration is. I hate to go through this really fast, but this is how you set all this stuff up here. All right. And again, if you have any questions on it, just give us a shout. We can go into more in depth. Okay. Any questions on that at all? No? Clear as mud still? Tom, question? No? No? Good? Okay. All right. Yes. 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 You have to select that. And then one other big thing is too is, so, okay, how do I know if it's a ground or a positive trigger? So LS means ground. Okay. So anything that says LS next to it, that's a ground output. LS, low side, right? Low side or high side. Okay. Acronym. Right. So anything LS is low side. And if it says HS up there, there's only a few high side outputs. The fuel pump output, high side 12 volts. Okay, HS. But for the most part, everything is ground triggered. Okay. So One other thing is too, is on the digital inputs here for us turbo guys, or it can be for anything really, but that boost kick in is your scramble button. So if you got turbo car, hit that button, set it for boost kick, and then it'll apply however much extra CO2 you want whenever that button's hit. Okay, that's how that works. So pin configuration is done. All right, we talked about generic port editor. We'll go back into that later. Hardware config, okay. Basically, all you guys got to do, and no one here is, this is actually how you set everything up for how the motor is going to be run, okay? 8 cylinders, okay? Obviously, for most of us in here, it's going to be 8. The fuel map strategy we talked about is going to be volumetric efficiency or pounds per hour, all right? 99% of guys are going to be on volumetric efficiency. If your nitrous car, if you basically have a motor that has no vacuum for the most part, you're going to choose as pounds per hour because there's just no vacuum to play with, right? So you've got a throttle and you got engine RPM, and you're basically going to calculate in pounds per hour how much fuel you want to go on the engine, all right? Yes, exactly. So that's what alpha N was back in the day, but now it's really just pounds per hour, okay? Yeah, okay. And then if you choose pounds per hour, okay, a lot of guys will say, well, will it convert my VE table to pounds per hour? No, it won't, but we can help with that, and we can give you a table to start from, get going, okay? And the pounds per hour is not exact. It's just a guess, okay? Because it depends on how you have the system programmed as far as what that pounds per hour means, all right? It's not exact. A lot of guys think, oh my God, I'm off by 100 pounds. Well, depending on how you're programmed, it may be just that way because you have it programmed. You may actually have 100 pounds more fuel in there than you actually think, okay? For most guys, for what we do in our world, most guys are going to be on volumetric efficiency, okay? That's what they're going to be on. Now, you can choose, map or TPS, whatever you want. So I can be in VE, and I can choose the TPS as my axis if I want, which is kind of cool, okay? So it doesn't have to be based off of manifold pressure if you don't want to. It can be based off throttle, okay? Map pressure display, if you're NA for the most part, you're probably going to be in KPA. If you're a boosted guy, you're going to be on PSI, all right? That's pretty self-explanatory. Engine type, Chevy or Ford. That's how we get away with knowing the individual fueling, okay, without having to have a cam sensor. Pro mod mode, so this is what Brian runs. This is why you'll see down here, see how the coolant and intake air temperatures are showing -14. If I go into pro mod mode right now they both came out to 100 degrees, okay? And the reason why we do that is because we want to run the VE calculation, but we don't want to have those sensors have any bearing on the actual fueling calculation itself. Streetcar, we want that, right? We want to know what the engine temperature is, air temperature is. That's all part of the VE calc. When you have a race car, it's making 3,000, 4,000, 5,000 horsepower. We want to lock that out, okay? So basically, those two variables go away, and now you're just tuning on the VE side of things with locked out air and water. But you can still use those sensors. They're still available for you. You can still use them. They're just locked out for the purpose of programming, okay? Makes sense? You can choose either a GM sensor. We also have the ability to use the RIFE high air temperature sensor. So they got one from like 0 to 500 degrees. You can choose that if you want, okay? That'll read just fine. But in our world, the GM's been there forever, right? In the pro mod mode, it's just a GM scaling. So there's companies out there that make a lot of stuff now with GM scaling, 1/8" male NPT sensors, you know what I'm saying? 3/8 male NPT for like screwing or cylinder head. It's just the GM scaling. So for the air and water on those two inputs, get anything you want as far as GM scaling, you can put whatever you want anywhere you want. Okay, that's how those work. Okay. Fuel type, gas, ethanol, methanol, flex fuel. Again, most guys are going to be on gas, your race car, ethanol. Okay, if you are only on E85, you choose E85. If you're on a flex fuel sensor, okay, you'll see the stoic goes away. Obviously, a flex fuel sensor means that there's a flex fuel sensor reading. It's going to measure between E85 and gas. All right. Very, very important here. For whatever you're calculating, if you have gas, enter in your stoic or the fuel type that you have. Okay, that's important because ultimately in the overall fuel calculation, it uses that number. All right. So if you're on gas, plug in 14.6. If you're on methanol, okay, 6.4. One thing too is on these little pullouts here, these little question marks, it'll tell you what to type in here. Okay. So if you get lost and you're not sure of something, so right there, it says gas 14.69, E10 14.08 for methanol 6.45. Just plug in those numbers right there. And wherever you have one of those question marks, okay, it'll give you a quick little note. Okay. Also, since we're here, there's a little box here. You can type your own note. So you can, if you want to remember something inside that point, you can add your own text, type whatever you want in there. No, it'll do it offline. On the comment? Oh, yeah. Okay, you're gonna have to be then. It's next to the question mark, or no? Some points don't allow you to have that comment next to it. Are there no comments at all listed? Are there no comments at all listed at all? Okay, all right. Yeah, you got to be online then for that. So, but you can do it though, to type in your own note. For what? It does, but it has to start with KPA though. What? Right, right. Say that again. What's that?
A manometer.
Right. So for this CAN bus type real quick, what this is, so in this ECU, obviously you can plug a race pack into it. We do not take anything in. So this only sends data out. All right. On the CAN EGT module, we have a small little module that looks like a pack of cards, and that's where this CAN bus will ride as well. It's not the same connector, but this is where we choose here what type it is. Okay. The Garmin is for like Dakota Digital guys. If you want to run like a Dakota Digital dash, you can have that CAN and it spits out, and then everything the BigStuff sees, the Dakota Digital stuff can use as well. It's just J1939. Anything J1939 we can use on that guy. All right, that's what this is. And then for the EGT source, it's going to say rim or race pack because on the rim modules or big bands, you've got your EGTs here. Okay, so you can choose either the race pack or the rims, or you can use the CAN EGT up above. Okay, are their modules. So you got 3 different ways you can do that. Okay, so what a lot of cars do is if they actually have race pack in the car and they take it out, I just tell them to keep the EGTs in there because they can read EGTs right from this. Those we can bring in, which is nice. So instead of having to redo all their EGTs, plug it in, boom, race pack EGTs just read right over the CAN. Okay, so that makes it really simple to swap out. Yeah, exactly. Yeah. Don't worry about the other stuff down below. Again, that's just kind of getting lost in the weeds. But basically, the top stuff is what you really care about. Once this stuff is set, guys, you're never going back in here. I mean, if you guys use this often, it's just, this is just basic setup. Once your combination's done, you're out of there. Okay? So don't worry about going back in here ever again. Close that out. All right. To this here. Next is this is one of the more important ones here, okay? Operating configuration, okay? This is a big one because up there where it says injector flow, this is where you're going to enter in the size of your fuel injectors, okay? So again, other systems care about fuel pressure and all that type of stuff. Just we're very simple, okay? All that flow rate number is what your fuel injectors are flowing at whatever fuel pressure you have them at. All right. So if you have a fuel injector that's 60 pounds or 600 cc's at 45 pounds of fuel pressure, you're going to put in 600 here. All right. But if you have that same 60-pound injector at 60 pounds of fuel pressure, right, it's probably flowing about 700 pounds or so. Just enter in 700. All right. You don't have to tell what the fuel pressure is. Just tell us what that injector is flowing at the fuel pressure you're running at. That's all we care about. Okay. So the fuel will be calculated correctly because you're telling the system, hey, I'm flowing this as my base. Does that make sense? Okay. The reason why you have a pounds per hour number here is because if you're in alpha N, it's best to enter that number as a pounds per hour number. All right. So if your volumetric efficiency, you'll just leave everything in cc's instead of the actual pounds per hour. You only have to worry about that if you want to run it in alpha N mode. I'm sorry, pounds per hour mode. Okay. Makes sense?
Spend 70 in there right now, right? In pounds per hour. And then I go hit volume and go to cc's per minute. Does it automatically make it 700?
It's doing it in the background.
Or do I have to physically go back in and make that 700?
No, you click 7. You just go back to volume. It makes it 700. It's just a multiplier. It just does it for you real quick.
I think in pounds per hour. I don't think in cc. So
Right.
46 in
Right.
instead of going in on things that
It's really just times it by 10 for the most part.
10.5 or something.
Yeah. 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 So
But you physically have to go back and type in at 700. It doesn't convert it.
correct. Correct. You need to enter in exactly what you want it to be. So, and again, that's the whole point. All we care about is knowing what it's flowing at the fuel pressure running at. That's all we care about. Don't play, there's no fuel pressure entering in anywhere. Okay.
That same question, let's say I'm doing a test and I'm going to use pounds per hour, 60 pounds per hour.
Mhm.
Let's see if there's something at like 70 pounds per hour.
Mhm.
Do I have to go back and adjust my base fuel map?
No, it'll give you more. It's actually going to give you a little bit less because if you're going up in fuel injector size, it's going to take a little bit out for you, but you'll have to do some tuning on it for sure. Yeah, but if you don't do that, we have a lot of guys, they'll just do that change and well, stuff's not adding up. Well, it's because you're at a higher fuel pressure, right? And you didn't change that number, so your fuel numbers are going to be off, right? Because you didn't update the software to let it know what it's actually running. So that's very common. You'll have a guy that has a Bosch 160 in there and he's got it cranked to make over 200 pounds per hour, right? Well, now he still has a set for 600 cc's. So his fuel calc's all off because he's not accounting for it actually being a 200-pound injector, right? So it's going to be showing less. That's why it's kind of smoking. It'll totally work, right? But is it showing you the correct numbers? No, because it'll still work. It's just that it doesn't have the right numbers there that you're actually flowing what you are at that fuel pressure you're actually running at. That makes sense?
Yes.
So yeah, just enter in whatever you're flowing at your base fuel pressure. That's all we care about. And the numbers will all add up. Okay. Fuel specific gravity. Again, you can click on the question mark. Okay. So you can plug in anything for there. Basically 730 is always going to be your base number. You only really care about this again if you're in pounds per hour. Don't really have to worry about that if you're in cc's here. Engine displacement. This is different. Gen 3 days. This was, if you had a 540, you'd plug in 540. Okay. This is now done in cc's. So Google has quick calculator. Just calculate cubic inches to cc's and you plug in that number. All right. So this is like a 300-inch motor, 5,410 cc's. Okay. So that's what we use to calculate the actual engine size. Over here, offset angle. All this number does is when you're setting your timing, this is a very, very important one. This actually calibrates your timing where you're supposed to be. Okay. When you fire an engine up, supposed to read in 20. If you're reading 15, right, you're 5 short. Okay. You just simply use that number to get you to where you need to be. You can move the sensor around if you can, but if you want to use a laptop, okay, in this case, if I was at 0, okay, and I was 5 short, I would just simply put a 5 in here, and now I should be synced up around 20. Okay, that's all that number does. Again, this is all initial setup stuff. Once this is done, you're never going back in here, but it's really important setup stuff that you need to know. So always too, just because we're here, always go to 3000 and check it there. Okay. If you're off a little bit idle, we don't care. The whole point is that when you're 3000 or above, that timing stays where it's supposed to be at. Okay. So that is your software adjustment for doing that. Now, this crank wheel teeth is grayed out. I'll show you why that is in a minute. If you're the ignition compensation here, again, very simple. If you're coil on plug, okay, just make it 112. If you have an MSD box or points or anything like that, make it 10. That's it. Just don't have to mess with that number. Inductive delay, just leave it alone. Okay, you shouldn't have to play with that at all. It's all built into the box to just leave it alone for the most part. Okay. You'll see here too, okay, that see how all the stuff is grayed out right here on the fuel pump, AC parameters. Okay, you guys remember why stuff's grayed out? Because something's taking it over, right? So if I come over here to system and pin configuration, it was because I had turned all that stuff off and just made it just generic stuff, right? If I come over here and start turning it back to the base calibration stuff, now the ECU can do what it wants with it, right? That's why stuff's coming alive here. Okay. So remember, if stuff's grayed out, there's somewhere else saying, hey, you can't have that. I've got control over it. Okay. So I just turned everything on as general purpose just because I'm just talking race car stuff. For the most part, if you got a street car, you're going to leave all that stuff on for street car stuff. Just have the computer take control of it. Okay. All right. So the other important parts here is that the dry shaft sensor here. Okay, here's our fun acronyms again. TOS. Anybody know what TOS stands for? TOSS? Anybody know what that stands for by any chance? No? Transmission output speed sensor. Exactly. Transmission output speed sensor. So by default now, we only use Hall effect inputs. So if you have a really old box or if you have a 2-wire inductive, it ain't going to work. So you got to go to a Hall effect now for that. You can use the TIS. Anybody have an idea what TIS stands for? Input. Yeah, transmission input speed sensor. Okay. Again, it's a Hall effect. You can use that for anything that you just want to measure, frequency based for that as well. Enter in the gear ratio, rear tire diameter. It'll calculate mile an hour perfectly. Okay. If you got a turbo speed sensor, you enter in the amount of blades you got over there. You can enter in front and rear speed inputs as well. Those are 2-wire inductive pickups for those guys. Okay, if you want to use those, that's for our roll race control. Works really good. Over here on the right, if you want a shift light, this is basically how you calculate the shift light settings here. Okay, it's pretty simple. After trans brake release, there's a delay. Program anything you want inside here. Okay. Auto shifter, don't mind these numbers. I just updated this box. Auto shifter here real quick. I'm just going to go through. We can do this here real quick. So if I want the auto shifter to shift at 7,000 RPM and I want my third gear shift to be at 7,500 RPM, this is how I program it. Okay. Auto shifter here, half second out. It's going to wait. I'm going to go to 7,000 RPM. It's going to drop 200 RPM. Now, a lot of guys get lost at this because, especially with Turbo 400s, right? You have to shift it way early, and then it's got to go up, flare up, and then it may not come back down, okay? So if I have 7,000 as my shift point, if I got 200 RPM drop, anybody know where I have to get down below before it actually resets? Any idea how that works? Right? So what this means is that if I'm at 7,000, and if I have 200 in here, I got to get back down below 6,800. Also, it's not going to reset. Okay. Now, if you got a crazy loose converter, or if you have a 400 that just loves to take forever to shift from 1 to 2, right? Or the hysteresis is too high. Exactly. Now, if you set this, if you want to just say, okay, I'm going to set to 25 RPM, right? Now, unfortunately, it may shift too soon, right? Because now it's already looking for the next gear. And if you're right there, it's going to smack going to 2-3. So sometimes you got to get creative based on the torque converter you have or how you're running this stuff. But you've got to have something in there for a drop. It needs to reset based off something. MSD, everybody does it. You're going to have something programmed in there. And if you have a really loose converter, we threw a delay in there, okay? So let's just say, you know what? I'm going to let it shift at that 7,000. I'm going to reset, but I want to wait before it actually punches out to 2-3 because maybe it's already there, right? If it's really loose. So you can program in a delay. This I just did 1 second. So now it's going to wait 1,001 before it allows it because you may actually already be at the 2-3 shift as soon as it resets, right? So program in that delay, and now it's going to punch out 2-3 1 second later if you're already there. It's making you wait at least a second. Okay? Does that make sense? Yeah, right. You got to have something in there because especially if it's loose, it's just gonna keep going, right? So again, we can get very creative with this too. On like the generic section, we can tie multiple outputs together with this as well. I mean, we can do anything to make the shift work. You just got to get creative sometimes to make it work. But the biggest key is that damn number right there. So many guys get lost. Now it's shifting at 7,000, but it's not resetting. Well, we got to get below 68. If we don't, it ain't going to go. Okay. And the shifter is going to stay there. It's punched out. The CO2 is not going to let go. Right. So, you can also use the shift light as well to do the shifter. If you want, the shift light is just an output too. You can always do that too. Now what's nice about the shift light is that is just a pulse time. So if you don't want to use that, you can use a shift light and say, you know what, when I meet my first gear RPM, just output and then just stop. So it'll output and then stop, right? And then it's going to go to my next gear. Okay, what's my next gear that I'm seeing? Oh, okay, output and stop. So you can use that as well for doing that functionality if you'd like. Just depends. So if you guys have any problems with this, you can just give me a call one-on-one and we can take care of this. But there's many different ways to have outputs be triggered on how your on how your setup is, I guess. Okay. Yes, you can. Yes, that's the generic section. So you'd use the race timer to actually just punch out at whatever time you want to go. Exactly. So, um, anyways, that's the operating configuration section. The last point here is upper left-hand corner. That max TPS for idle, that number is, if you're at, let's just say 5%, if I'm below 5%, okay, on the TPS, I'm considered idle mode, idle spark, all that stuff works. If I'm over this number, then I'm going whatever is on my base spark table, I'm out of idle. Okay, that's an important number. And then if you floor it, if I go over 80%, injectors aren't going to fire on cranking. Okay, that's what that number is. So if the engine's flooded out, just floor it. It'll stop the injectors. You'll have spark. You'll have everything else, and then it'll light off. Okay, so you can make the number whatever you want. Okay. Any questions on that stuff? Any questions on that at all? No.
So you're saying it holds air on the auto shift, so will it actually piggyback and stack and hold multiple solenoids?
Yes. Yeah, you can. If again, if you'd have to tie some outputs together, yes, it would totally do that. Absolutely. Yep. Okay, so that's this section here. Again, more street-based stuff over here, fan controls, you know, on-off temperatures for coolant. Again, that's all pretty self-explanatory stuff. All right, so this is the other big one here. If you're a long-time user, this is the one that John loved to hide. Okay, this is the old school dealer menu. We don't hide them anymore. There's no reason to hide this stuff. Okay, so this is where you'll just simply come in and you'll choose a setup that you have. Okay, crank sensor type, pretty self-explanatory. Cam sensor type. Okay, on the engine configurations, pretty self-explanatory. For most of you guys in here that actually coil on plug, you'll be continuous coil on plug. For a distributor like you over there, you'll be on continuous distributor here. Okay. And again, you just simply choose whatever crank and cam sensors you have, the engine type that you have. If you have any questions with that, just you can give me a shout. But if you have coil on plug chosen, which is what most guys are going to be right here, you got to choose what type of sensor you got. Okay. If you choose Hall effect, you can choose rising or falling on that sensor. If you guys are 2-wire IPU, you can't choose rising or falling because we automatically set it for rising. Okay. That's how our stuff works. So Hall effect, you can change all that stuff you want. If you guys don't know what a pull-up is, don't worry about it. All the pull-up is a voltage on the signal wire that'll make that sensor work. Okay. But obviously, again, this is just setup stuff. Once you guys get in here, you're never in here ever again. Okay. Very important though. If this is not set up correctly, this is like the guy that lost his cam sensor. Okay. It's set up. Hey, I got to have I'm coil on plug. I got a cam sensor. This is how everything's set up. Okay. So when it goes sync, these are the settings it uses to go sunk. This is what it's looking for here. Okay. Makes sense? So you may not have it, Brian, on yours if yours isn't updated. So Mr. Metz may not have updated that here recently. So you may have an older one there. So it's under system, under dealer configuration. Yeah, it's not that. So we'll get it in there for you. So over here under system 2, you're going to have FSL configuration. And basically what this is here is you can choose how to run the engine. Most guys are going to be on BCP. Anything 16 injector based is going to be on staged. Okay, so Brian's got 16 injectors. If you have 16 injectors and you have a methanol setup, you're going to say, okay, I'm going to have my second set kick on at 15%, and anything above 15%, I'm on 2 sets of injectors. Okay, I get back below 5%, I'm going to go back to single. Okay. Over here, though, for guys that want to start getting into some more advanced features, you can have multiple maps per gear. So you can say, okay, I'm going to have four tables. So if I come over here, you'll now see I've got four fuel tables. Okay. So again, this works really well if you know what you're doing, because if you're in different gear ratios, the motor can definitely handle different fuel spark timing events, right? That can definitely help you go faster. So all this stuff can be configured here. If I said I had 2 tables here, if I came back over here, now I've only got the 2 tables, right? So you can do it based on RPM. You could also do it based on time. So as you're going down the racetrack, bing, 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 just do it based off time as well. You'll start flipping on, okay, different tables as well. Yes.
There's spark table option for that.
So yeah, so what that means is if I go back to the gear over RPM, which is the most common, you're now going to have 4 fuel tables, 4 AFR tables, and 4 ignition tables. So as you're going down, they all change. They all change. So you can have different air fuel ratio targets, right, for different gears, different timing numbers for different gears. Yeah. And if you really want to get lost in the weeds with it, obviously, if you're on Spark table 2 or 3 or going on the track, okay, you would scale this table to be entire RPM you're at, or 1500 where you're at. Now you've got incredible resolution, right? Yes. Good idea. Yeah, I'm sorry. Good question. So you see this number right here, this RPM drop in 50 milliseconds? That's how it knows when you shift. So this value here is what it knows to actually calculate which gear you're in, all right? So if you look over here, we've got minimum RPM for gear determination, reset RPM. So all these different things reset it back to square one. As soon as you start going down, either the road, racetrack, whatever you're doing, this number calculates when it sees a shift. So that's all that it is. It's just software. MSC does it. We all do it our own ways. That number is what we use to say, okay, I'm in second gear, I'm in third gear. It just literally calculates how fast the engine RPM drops. That's it. So, and it sometimes takes a little bit to dial in, but for the most part, our factor number works pretty well. But that's why whenever you do this, you make all the tables the same. Then once it sees the gears really consistently, then you can start getting lost in the weeds and tightening everything up, because now it gets in the gear indicator correctly every time. That's how that works. But yeah, it works really well. It works extremely well to do this. Yeah, yeah. And again, when you start zooming in, and because again, if you look at the base, your base table of 400 to 7,000 RPM here, right? And full KPA, well, instead of being 400, 7,000, I could be 5 to 7,000, right? Because you're up there anyways. You can just go as tight as you want in all those different boxes and have it be whatever you want. And you're still in closed loop too. So as you're going down the track, if you want to have correct and stuff, it'll close loop correct and everything on its own too. Okay. But yeah, there's no danger to this at all, because again, if you make every table the same to start off with, it doesn't matter. So if it misses the gear, it don't matter. You're on the same exact tables. So once you get the cal correct, as far as it's seeing different gears, boom, boom, boom. And it's all in the log too. You'll see gear 1, 2, 3. The log will show you. So if it missed that gear, it didn't see it, you'll just simply lower that number down a little bit. Okay. If it's shifting too fast, you'll raise that number up. It's actually really simple. Yeah. Okay. So
I will say, hey Ben,
yes.
I will say to the guys out there, this is what I think just sets BigStuff apart from the rest. And when you can go in and control your spark, your fueling, in each gear, you can fine tune your engine so tight that, like I said, that to me, that's just really one of the reasons that sets this apart from the rest of the systems that come from China.
Yeah. Chip's got a small block Ford, and he's been using that for a while, and it works pretty well. Once you get it in, once you get it dialed, and again, that's the thing, is some guys are afraid. It's like there's nothing to be afraid of, because you make it what your first table is anyways. You can't mess it up. It's the same values, So, but yeah, once you get a handle on it, though, you can literally. We've seen G meters pick up out there. You shift gear all pick up again. It's like, really? Because again, if you've got some mechanical advantage, you can lean on her a little harder, right? Because you got some gear ratio helping you. So, doesn't fit all, standards sometimes, but sometimes it can really help out quite a bit. So, all right. So that's FSL index mode. Just what you're talking about too, Chip. If I come over here to BCP, okay, if I wanted to, it tells you right here, I can choose 1 through 4. So we default to 1. Most users will just simply keep changing fuel table 1. But if I came over here and I said, I want to go on number 3, well, now I'm on fuel table 3. So you can program all these different tables if you want, and just choose, hey, I'm going to go on 3. Now AFR is at 3, right? And my spark's at 3. Okay. So you can configure all these different tables. If you want to get lost in the weeds, go ahead. You don't have to, but it's there for if you want to. So put that back to 1. And then again, you'll see that as I'm going around making changes, it's red down there in the burn, just lets you know, hey, you gotta write something here. Okay. So almost through this one section, this is the, well, again, what the heart of what's going on here. Rev limiters, okay? So how this works here, guys, is we actually have 3 different rev limiters that you can apply. You got a 2-step, you got a 3-step, and you got a half-step. All right. So 2-step is easy. Everybody thinks of 2-step though in other systems in the old MSD days as the main. It's not in our world. Okay. The 3-step is the main rev limiter. All right. So when the 3-step releases, that's when everything starts for us. Okay. 3-step is our race timer. Everything for us is 3. The 2-step is if you want to have like a burnout rev limiter. You know, if you're a turbo car, you want to have another rev limiter come in and build booster, whatever. Okay. So that's just a rev limiter for whatever you want to do. I've got guys to where they've actually got a switch on the bumper. These drivers will just floor it and they want to have a low RPM. They flip the switch up and now they're at a much lower burnout RPM. Okay. Because they can't control the burnout. On the half-step is if the 3 and the 2 are both activated. All right. So what's nice about that is for any reason at all, if you don't want to go to the 3, you press both, you can then have a different target to sit to. All right. I think kind of the best example is if you got a really high horsepower car that you're racing and it's maybe bracket or index, you don't want to sit at 4,000 or 5,000. The other guy's got, you know, lights coming down. You want to sit in the transbrake forever while he goes. If you got a really fast car, you can sit there basically, watt, have both these activated, be at a much lower RPM. As soon as you release the 2, it then jumps right to your 3. Okay. What's that? Starting line enhancer. Yes. So it's nice because you're floored, you know what I'm saying? But it's at a lower RPM with both those inputs being triggered. But if you just press the 2-step alone, you can have a burnout, you can have a higher rev limiter, right? So it gives you another input to play with, which is nice, versus having to sit at the 3-step for, you know, 5,000. You got a big tire car for some guy that's just going to take forever, and then you can finally go. Okay, that's how that works. So that's what the half-step is here. Okay, high rev, max engine rev limiter. Okay, that's all that one is. Okay, on the touchscreen dash, you don't got to worry about the pedal bits. Just know to set this really high. You don't got to get into this right now. Just set those really high. It should always come high from your factory cal. On this touchscreen dash rev limiter override, what this means here is that you can choose to have the rev limiters be set from the dash, okay, or from the software. So some guys get mixed up on this, okay? When enabled, ignores the settings from the touchscreen dash, okay? If you have a touchscreen dash, the touchscreen dash takes priority for first gear retard tables, your boost control tables. The only thing that you can ignore from the dash is this, all right? So if you want to just keep setting the rev limiters here in the software, you enable this to ignore the dash, okay? If it's set to disabled, then it's only going to take the RPM settings from the dash. So if you want to be in the lanes and going, oh man, the track just went to shit, I'm going to change my 3-step from 4 to 3,500. You have to do it in the dash in this case, okay? If it's disabled, then you have to do it here in the software. All right, that makes sense? So that's one of the only things though. If you got touchscreen dash in there, it's using everything else though for your other tune-ups, okay? So that pretty much wraps up. Oh, well, where are you going here? So you have 2 rev limiter error tables. And what these are here, okay? You have a starting line. Basically, in other systems, you have, let's just say, a hard cut and a soft cut, all that type of stuff. You have the ability to completely, you know, control your rev limiter, how hard it hits, okay? So the high rev limiter here, this is the max engine, okay? So where it says high rev up here, that's the max engine one. So whenever you bang the max engine rev limiter, it uses this table, all right? And again, we're acronyms. ETM, okay, is what we use to control torque, okay? Torque is spark. So the way this works is you have 0 to 31. 31 is full power, 0 is no power. And when I mean 0 is no power, you have no spark. You can literally just kill the engine by going to 0, okay? So what we've done is we've given the end user the ability to fully adjust how hard they hit these rev limiters, okay? So max engine, most guys will leave this alone. But on the starting line, if you want to play with this table, depending on how hard it hits or soft it hits, sometimes the rev limiter can get a little wavy sometimes, or depending on the combination, it can overshoot, undershoot a little bit. We give you a table here to fully adjust how hard it actually hits. All right, good. Yes, no fuel. Absolutely no fuel. No, we don't want to change the way the fueling's done on the rev limiter, because God forbid you go lean or something like that. So this only applies to spark. Again, you don't have, Brian. we will we will we will show you here later. I think we ran out of time to put on your computer there. Sorry about that. But sure. So no, you may not have it either, Russ. This is actually a newer update. So you may, are you? So good. Just go to system, and then it should be under the rev limiter section under system. So that's where these two tables are. So you just have to remember rev limiter error table, anything starting line. 2-step, half-step, 3-step, that's what this table is, okay? The high rev is the max engine. So again, our rev limiter is a little different, because when it starts banging and popping, if you don't have very low numbers up here, okay, it's going to sound, it's not going to sound as bang, 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 like how some cars are, because it's fully adjustable. You don't need that a lot of times. It'll hold very steady with a table like this for the most part, okay? And the way this works here is, see how it says acceleration on the bottom, and to your left it says air? It's very simple. So that 0 on the error line, okay, that means that if I'm at a 4,000 RPM target for my rev limiter, whatever I'm at, I'm going to have these ETM numbers here, okay, of 28 to 17. Now, the acceleration rate stands for the acceleration of the engine. So me and the guys made up this number. I'm sure it actually means something. I don't know what it means, but 0 to 8,000 means that we're accelerating positive. Okay, the engine is accelerating. Negative 8,000 means I'm decelerating. Okay, so all we do is this table bounces around based on set point. If I'm decelerating, I'm going to shove power back in it. Okay, I'm going to 31. 31's full power, right? If I'm accelerating and I'm going over my target, I'm going to start taking power out. That's how this works. It's very simple. So in our world, okay, a 15 number, because 31 is almost half of that. If you got a V8, you're running on 4 cylinders. That's how you have to think about that. It's very simple. Just cut that number in half. Boom, I'm running basically 4 cylinders. And we got some really cool data that we got on the rev limiter from Dan's stuff. And on the rev limiter, our stuff was pretty even, right? I think you saw. Yeah, it was very even on the rev limiter. So the whole point of what these guys, you know, because again, these guys were the first to do a lot of stuff, Chip, you know, back in the day, right? All this stuff was just, nobody had done it before. They figured out a very good way to keep all the cylinder pressures even. And I never saw it firsthand, but with Dan's stuff that day, we actually saw it firsthand that day. It was really cool that we actually saw the cylinders literally almost all even on the rev limiter. So the point of that is it wasn't picking on one cylinder more or the other, right? So we didn't have one cylinder had way higher cylinder pressure than another. When the rev limiter was popping and banging, everything was pretty much even for the most part. And that means the motor's happy, right? We're not loading up a certain cylinder over the other. And to see that, and you know, for real, was actually really cool. So yeah. Yeah. Sometimes with certain combinations, if they don't want to use our coils, if they want to use CDI boxes, sometimes it can get a little wavy, and sometimes you'll have to go in there and do this. For the most part, the factory stuff works okay. It's all, we just want to give more, you know, ways to adjust to the end user. That's all that it is. Some guys want to have that big pop bang and firing off, you know, fuel in the exhaust and stuff. We'll lower these numbers down, man. It'll load up really good. You'll have some really great pictures, you know. But if you don't, if you want to try to tighten it up really good and not have to take away as much torque to keep it at that RPM set point, leave something like this. That's how this works. Now you're distributor based, so you don't use this. Right. Yeah, exactly. So distributor based, like your MSD box, MSD just takes care of all that, right? But if you're coil on plug, you are 100% using these tables. Right. Yeah, but that's the thing. The MSC's got a hold of that when you're on distributor based. I know. Right? Yeah. See, I got the hecklers out there today, right, Chip? Geez, these guys, man, the buzzkills.
Yeah, I just want to, hey Ben, I want to bring up to the guys that talking about this rev air table. I actually was running into some problems where if you're on a 2-step and you're trying to leave, obviously you're setting it 4, 42, whatever you're trying to leave at, that I was having issues where basically I guess it's banging too hard and it was dropping the RPM below where my set point was. So I was not leaving at the RPM I wanted to. Like it would vary. It would just not be consistent. So it's like, man, I know I put an extra 100 in it because the track got better, and I left 100 lower. You know what I mean? Because it was just hitting the motor too hard. So working with Ben, he changed some things around and made it much smoother. So it's almost flat now, where it doesn't hardly change any RPM. So this is an important thing for the guys who are trying to drag race and be consistent. This is one of the things you should, play with and pay attention to.
Yeah, because again, like an MSD box's job is rev limiting basically for the most part. So it's got 30 years of experience to do that perfectly, right? We're trying to take a bunch of universal parts to come in and rev limit perfectly. Either knock a much torque out of it, right? There's so many different ways to do that. But the bottom line is that this table is what you're going to use if you're on the starting line for any reason to start making changes to that. Okay. So over here, again, it's system. If you don't have the latest software, you're not going to see that. And actually on the old software, it was on the SR2 section. We actually had it over here in the traction control. Well, we moved it because not everybody's going to have 2.4. You want, because you're offline, it's not going to show you what you're on. You got to be online with the EC to show it. Start right now. So if you wanted to grab it, you can go get it. If you don't have that latest 2.4, we just put this out about a month ago. Yeah, so it's pretty new. So system one's very important. Obviously, for everything you're going to be doing now as we go out into the other tables. Okay, so you guys have any questions on that section all as far as setup goes, or anything in there at all by any chance? No. Okay. All right. So don't have to. Oh, one more thing here. This is the last part. So for test modes, okay, this is how you're going to be able to test all the outputs on the ECU. Okay. There's a few that we do not have on this, which most users won't use, but it's going to come out in the next software iteration. But basically for test modes here, when you enable this guy, you can test each injector and you can test each coil. You can test all your outputs. You can test your PWMs. Okay. So if somebody wanted to, I don't want to enable his car and start hitting stuff, but when you enable this guy here, okay, it's going to say, hey, if you do something wrong, it's all on you, buddy. Sorry, right? So now that it's on, I can start clicking away and doing stuff. Okay. So instead of having to run the car, you can test all the outputs here. So you want to test your shift solenoid. You want to test if you have stuff on the fan outputs. Again, we just put the base names in there, but if you're using the fuel pump output to drive, a dumb valve, whatever, you just hit that fuel pump trigger and then boom, it'll just go. Okay. Yes. Yeah. Unfortunately, we've had a few guys do that, fuel rail full of fuel. Oh, I'm gonna test my injectors, I'm gonna test my ignition, and boom, off she lights. So yeah, don't do that. Okay. Be very cautious. That's where that little disclaimer is in the front. Yeah, exactly. But this is very handy, obviously, when you're going through. If you actually run through the firing order here, you can run through the firing order, you can run through the coil firing order. It'll go through depending on how you have the firing order set up. So yes, yep, system test modes. Again, you may not have that, but it's okay. We'll get that set up there for you.
Question, got a
Yes.
problem. What here tells you that you have a problem?
You don't. Nothing will. But you can come over here and say, I'm going to test this. I think I have a problem. And it works or it doesn't work.
Box driving the
Well,
injector.
so you'll hear the injector solenoid.
Oh, the injector is going to click.
There's nothing that says like, coil misfire number 8.
No,
Like they have a.
no.
That's what you
Mm-mm. Mm-mm.
respect that. The login data should say where to start with.
Yeah. So, just in case some of you guys don't know, if you have an ignition coil setup, you got to ground that spark plug. So a lot of guys will say, I want to know if I got a bad coil. We'll just throw a spark plug in. You can't have it in free air. You're going to melt it. Okay. So make sure that coil is grounded somehow. Just rest against the intake manifold or something. And just that way you can trigger that coil and you'll see it spark and light off and you won't melt the coil. The biggest killer of any IGN based coil is it makes spark, but it's got nowhere to go. You've got to ground it out. It'll start oozing white pus and there you go. So you gotta keep that sucker grounded. Yeah, exactly. But yeah, this is obviously very handy because again, we've got, you know, a lot of guys that'll just say, you know, it didn't work. It didn't work. I'm like, well, let's just go test it and see if it worked. Well, it actually worked. Shoot, you know, so is there something else going on? You know, it's nice too for the fuel pump trigger for streetcar guys. You throw in a new fuel pump, you want to test for leaks, hit the fuel pump off, let it run, just see if any leaks going on in the system. You know, it's obviously however you want to do it. Okay. The PWMs are really nice because if you're doing like a fan or something, or if you're just doing anything that's PWM based, you can have it go and you can actually change the duty cycle in real time. So, you know, if you were at 25% duty cycle for PWM05, you'd see that item slow down. Then if you went to 75%, for example, you would see it ramp up and go to 75%. So you'd see the speed change in real time. So it's really nice. Okay. Big thing is, obviously there's not everybody's gonna remember to turn this off, of course. So if somebody actually turns on the engine and forgets to disable this, don't worry about it. As soon as we see any RPM, we turn all the stuff off. Okay. But it's definitely a good idea to disable it and then get out of it. And that way it's actually not on. Okay. But anytime the engine starts, we get out of that. Okay. So that's a system section. Obviously a very important section. That's why we had to spend a lot of time on, unfortunately. But once you're basically in here for the most part, besides the rev limiters and test modes, you're pretty much out of there. It's just for the initial configuration. Okay. Any questions on this stuff at all? You guys hopefully somewhat sinking in there. I know it's a lot. Want to take a 5-minute bathroom break here, get some water, whatever. You guys stand up real quick here, and then we'll keep moving on. You guys hanging it in there okay online? You guys doing all right? Yeah, yeah.
Require us to bring your own. Or you can just. Or you can just sell it.
Yeah. So what Chip was saying was that he used the rev limiter table to vary his, and he uses the gear by shift tables too. Loves that. So it works really well. We actually had a guy that just the other day was racing his cam crank advance all over the place because his cam was screwing up and it's going track. I'm like, yeah, there's something going on with the cam sensor, man. And we used it back then. We don't use them anymore. You know, it's like Bob with you guys, we don't use them anymore. It's just once it starts, it's gone. Yeah, once it starts, it's out.
I have a guy who's got to switch an ECU because of another manufacturer.
Sure.
Because of cam cranksync issues.
Right.
And we had the same problem with the same ECU manufacturer when we were trying to get our stuff going.
Right.
He's got the same problem now, and they've been trying to run the machine for intermittently. I'm going to tell you it's almost a year to the day.
Right.
And it was the blue one that was on the dyno the other night.
Mm-hmm.
It's still having problems.
Mm-hmm. Yeah.
So it's getting.
Yeah.
And that alone, like it's like.
Yeah. I know.
Because if you're not locked in sync.
Right.
And there's no reason to.
Yeah.
Once it's locked, it's locked.
Right.
It doesn't need it.
Exactly.
This is TDC compression.
Yeah.
That's it.
Exactly.
That's it.
Exactly.
Do it once.
Exactly.
I love
Yeah.
that.
Yeah.
I love that.
No, I mean, when we actually saw it happen in real time, like at that race in Vandermeer, that was so cool because he literally made a hit, it won the race. And if he had lost that sensor, he would have, you know, he wouldn't be able to run, obviously. But because he fired up, and thank God, either it was at the track or the down track or the burnout, he lost it somewhere out there. Freaking made the hit, and he came back. The miracle too was that literally it was sitting right there. Like somehow when it was flying in the cam, it popped out and landed on the water pump right there. You can't make that shit up. It just got stuck right there. We used the little pick. Holy cow, you know, pounded it back in with some JB Weld, and there we go. We were done, you know, so.
Have it welded on a bracket and it falls off.
Well, you need to start it. That's what you need it for it to start. Right, exactly. Yeah, you need it for it to start. Yeah, it's crazy. Exactly. Yeah. For distributors, it'll actually run fine if it loses the cam. Yeah. If it loses the cam for distributor base, it'll actually be fine. It's just the coil on plate. You got to have it. Yeah.
Hey, Ben, it's Dan.
Hey, Dan, what's up?
Hey, a question. You know, I bought that system secondhand for this small block Ford I got in here, and you said
Yes.
that the cam sensor isn't necessary for a distributor based. What about the crank sensor?
The crank sensor in your case is just going to be the distributor. So over here in the dealer config, you would just be down here in a continuous distributor. and you would set up over here as a Hall effect. I'm sorry, as a VR. This would be how it would be set up, just like this. So if that's not how it's set up, again, when you're ready, we can log in and get you going for the first time too. But
Okay.
this is how those dealer settings will be set up for that application.
Where now? What does the crank sensor have to be? Does it, because this doesn't have a crank trigger or anything like that? This is literally working off the MSD box.
Correct. Yeah. So the crank trigger is fed into the BigStuff, okay, or whatever you're using for the crank input, whether it's 2-wire distributor, 2-wire crank, whatever it is, and then we output through the points wire to the actual MSD box. So the BigStuff gets the signal. We need that signal in order to actually run the car.
Okay, so in other words, that plug, or so I saw it had a ground loop and it also had the weather pack plug on it. Does that tie to distributor then?
Yes, that'll tie into the crank IPU connector on the main engine harness.
Okay, that's what I was kind of wondering, because I'm slowly getting to that point after pulling out all the old Holley sniper crap.
Yeah, when you see the 2-wire distributor, output, that's the crank signal that you're going to plug into the BigStuff. It's that signal, those 2 wires. That's your IPU input.
Okay, now also I have a quick question. I noticed it had an HEI weather pack connector. Is that
Not used?
Okay, all right. So basically, I will be putting aside the cam sensor plug and the HEI plug.
Get all out of the way. So the harnesses come with basically everything you need. You're not gonna need everything, but it's all out there on the harness, so that either you can use it or set it off to the side of its use for future. You know what I'm saying? So you won't be using the cam input and you won't be using the HEI connector.
Okay, that's perfect, because I also the obviously the harness has different connectors for the IAC and for the TPS. I bought the appropriate connectors, and I just have to plug them in appropriately.
Exactly. Yeah, we definitely will need TPS. If you can run an IAC, that'd be great. Especially for a street car. I mean, it's really handy to have that, obviously. But yeah, we got to at least have the TPS for what you're trying to do.
Yeah, this has air conditioning on it too, so obviously that helps.
Yeah, we're gonna want that input to also bump up the engine RPM, so that when the air conditioning's on, we can give it a little bit more RPM to then run the air AC compressor as well.
Okay, perfect.
Yeah.
Thanks.
Yep. It's kind of going in though, guys. This stuff kind of sinking a little bit though, hopefully, and again, obviously afterwards too, while waiting for him to come out, just real quick on this software. So a lot of guys want to talk AFR. So if I'm looking over here at this tab, the system always defaults. See how it says Lambda? It's bouncing back and forth on 1.0 right there. Okay. If you want to see stuff in AFR, which most guys obviously do, if I come over here to the AFR section and target O2 table, okay, you're going to see here it's all in Lambda, but it's a very quick change. Come over to AFR, the parameter section here, and see how it says O2 display Lambda. Just make it AFR, and then everything in the background changes. Okay. Yeah. So make it AFR, and now you can do AFR. You can do Lambda, whatever you want to do Lambda wise. Okay. And then anywhere in the software, all this stuff is completely configurable. We just give you a baseline with all these different tabs, gauge cluster, tuning and dyno views, the logger, all this stuff here. Okay. So if I right click over any of these boxes, a window's going to pop up and you can go nuts doing whatever you want to do inside this software to redesign it. But all I'm showing you here is if I come over here to base system IO, it's right over manifold pressure right there. Barrel's right there, and your map's right there, Tom, right there. Right there. Okay. So if I right clicked over the left bank secondary, and if I right click, now I go in the system over here, I can go left bank AFR, and now I'm looking at it AFR wise. Okay. So if I right clicked over here on the primary, okay, now I can click on primary. Now I've got everything in primary. Okay. So all you do is right click over anything. Just right click. Okay.
West-based software component should be all.
Yes. Yes. Why not? Well, we give you the choice. We're flexible that way. It's okay. Maybe you don't want to be in that way. It's all good. It's all good. But again, so up here, right, where it says right bank lambda, it's bouncing back and forth. I just right clicked and same thing, right? Base system IO, right bank primary, do anything you want. Okay. So all these different values here, as far as all these different gauges, they're all preloaded. You can just shove anything in there that you want. Okay. I just chose Digiset by accident there. AFR. Okay, so a big question where guys always get confused is, well, what's primary, what's secondary? How do I remember all that, right? You know, what am I doing here with that? So here's how to remember that, okay? On this gauge cluster tab, down here I've got Chevy individual cylinder lambda, all right? So if you ever forget, or you want to know how this works, whether it's a Chevy or a Ford, right here where it says right bank lambda 2468. Okay. If I'm on the secondary, I'm looking at 1357. Okay. So if you ever, if you have dual O2 sensors, like if you have dual NTKs or if you have dual Bosches, you want to make sure these O2 sensors are on the right banks for obvious reasons, right? Because we're in closed loop on bank to bank. So when you have only one O2 sensor, you want to make sure that it's on the primary side, which is 2468 of the Chevy, right? Right. So now when we're in closed loop correction, it's a global closed loop correction for all the cylinders. But when I have two O2 sensors here, I'm going to be in closed loop per bank. All right. So we don't, again, other systems, I think average and stuff. No, we are bank to bank on that bank, if you would, for closed loop. All right. So just remember that secondary in this case is 1357 for the Chevy. It's kind of backwards, right? You would think, well, why isn't primary number one? It's how it's always been. I don't necessarily understand why, but that's how they did it back in the day, and it's still the same. Okay. Right. So yeah. So if you come over here, I got a Ford Lambda. So you can just click on that. Okay. So now it's telling you for the Ford Lambda, you're 1, 2, 3, 4, right? And then your 5, 6, 7, 8 for the secondary, right? So primary is pretty much correct. Primary is pretty much always passenger side. Okay. Again, secondary is driver's side. You kind of think that'd be backwards, but it just is what it is, right? But if you ever forget, it's very easy to remember and do it this way. All right. So it's very important that, unfortunately, we've had guys and their O2 corrections going like this, and the banks are going, you know, the wrong way. It's because they had their O2 sensors plugged in backwards. Okay. So easy fix. Just remember to come here, and this tells you exactly how to connect those O2 sensors up. All right. Yes, you're gonna have 10 O2 sensors. Correct. Yeah, you'll have, if you had like your guys set up your factory stock, you have all 10 showing when it's running. So when we get over there to the AFR section, this right here where it says number O2s, this is where you choose dual or the rim modules. And that's actually how, when you're in closed loop, it corrects. So you could have 10 O2s and just be correcting off of your collector based ones, right? Or if you had 10 O2s, you could be collecting on the IC rims. Now you're closed loop per cylinder. Okay. So what's really cool about the closed loop stuff, I just geek out on it because if you're a manufacturer, we've done this a couple of times, you change camshafts and you can literally on the very first pull of that camshaft change, see the fuel correction in closed loop. So it tells you basically instantly what that cam has done to that motor, right? Because the O2 sensor is going to want more or less fuel depending on what that cam or that manifold or whatever you changed did. So now you can say, wow, look at that. We just added a bunch of fuel last cylinder, or we just took a bunch of fuel away. Well, that means something, obviously, right? So you can look at the O2 data, but when it tells you, hey, I'm adding or taking fuel away from these cylinders versus the last pull, it's like, wow, that's cool. It just tells you so fast. It's just speed, right? So you're saving money on time, you're saving money on parts, everything, right? So, but we'll get there. One thing also is just since we're here real quick, this O2 heater startup mode, it won't work for the alcohol-based injectors, but when you do this heater startup here, it actually turns on all the O2s. Okay, so in the old days, the Gen 3, you would actually turn the key on. There was an ohm value where it actually would sit there with the key on and the O2 sensor would turn on. We don't do that anymore. It defaults to off. The sensor will not turn on. That's why these things are bouncing at 1. It's not on, but just bouncing on. But if you turn on this heater startup, all the O2s turn on and heat up. Okay. And they'll actually will all show like 200 to 1 because they're sitting in just free air. Okay. A lot of times we'll do the heater startup so that if in cranking fuel, if you want to see what the cranking fuel is, what's happening with it, you can hit it. If you're really lean, you're really fat, you'll catch it right away because the O2s are already hot. You know what I'm saying? So it's a nice feature to have for this O2 heater startup. Doesn't work on the NTKs though. We don't do that. We don't want to burn up an $800 sensor. Okay. So, all right. So everything here going forward, guys, like obviously, again, we just burned over an hour in one section. I'm not gonna be able to cover everything perfectly, but the biggest sections that we're gonna want to cover here for the most part are going to be the fuel, AFR, and ignition, and then the traction control. So try to buzz through these here. Basically, for the most part, these are going to be the ones that you actually are going to be interfacing with the most, okay, when you're actually making the calibration changes, all right? Yes, that's after lunch. Yes, yeah. So we're going to do every section here, okay? If you see the fuel settings has a modifier, okay, I got a fuel modifier, got an O2 modifier, got a spark modifier. All these modifiers basically are, these are additional features that can be opened up in the fueling section, okay? So decel fuel cutoff, EGT, add fuel correction, fuel pressure safeties, like all these are basically extra things you can enable in the fueling side, okay? You can turn all the stuff off and have nothing enabled. You know what I'm saying? It just depends on how you're doing everything and how you're running everything. But all this is basically are just additional features of the fueling section, okay? So to run through them, the most basic ones are like a coolant correction table, right? So the coolant correction table, once I do that, you've got this table. If you're a race car, you don't care about this. But if you're a street car, if you're turning street cars, you're gonna have you're gonna have more fuel in there. Typically, if it's cold, as it warms up, you pull it out, right? But that table is turned off and on inside this modifier selection here, okay? So that's why it's important to have these dialed in, okay? You can have air temperature correction enabled if you want. So you'll see here, right? If I enable the table, now it's showing up. Makes sense? If I turn the table off, if I disable it, it's not going to be there, okay? So only stuff that is technically in action is going to pop up for you, okay? So if you see something showing there, it's running, all right? So EGT add fuel correction, this is for typically methanol cars to where if the EGTs are getting too hot, you can actually program it in, and it's right here to where, okay, I'm getting too hot. What do you want me to do? So we can say here that at 1100 degrees, okay, I'm going to add 25% fuel. Okay, so if you lose an injector, if injector's getting plugged up on that cylinder, it'll start throwing in a ton of fuel. If we get to 1200 degrees, we're going to shut that cylinder off. That's how that works, okay? And the reason why this is very important is because if you have a methanol deal, it doesn't take much to burn up, unfortunately, all right? So if you enable this in what's called dyno mode, it's always on. So you make a sweep, there is no, turning it off. It's always on. If you're in race mode, okay, what we do is this is only running when you're going down the track. So for burnout, three-step, all that crap, we don't care, okay? And that's what this delay from transbrake is. We're going to say, okay, after 1 second, now you can start looking at these tables to shove fuel in if needed, okay? There is a point in the logger that will say, hey, we turned this on also. It'll say EGT safety on. So you know it turned on, and you'll see a cylinder just start shoving a ton of fuel in, right? Or go to 0% duty cycle because we've turned it off based on the EGTs, okay? So that's how that works. It actually has saved quite a few engines if it's enabled. If it's not enabled, it's not going to do anything for you. So you got to have it on.
That did work.
Mm.
I remember something about like some new feature you came out with just saved somebody's motor.
It's one of them. I mean, it definitely works really well. This was brought out just because anything can happen, and if an injector fails, if something does happen, yeah, thank you. So if something does happen, we're just trying. versus doing nothing, letting it burn up. Okay. So, and again, you can tailor this to however you want it to be. Dyno mode, again, just for the most part, you make a sweep and it's always on. It could be on gas. It could be anything. It's just mostly it's for the alcohol guys that want that safety. Okay. So that's how that works. But again, it's all based off of the modifiers here. Okay. This is how we turn all the stuff off and on. All right. Your generic curves. This is basically when I want to, it's the same for whether it's spark, it's air fuel. If I turn on a generic curve, okay, I can either add a pounds per hour based table or I can do a percentage of fuel. All right. So on the x-axis data source, I can have it be whatever I want to be here, RPM, coolant, boost, it doesn't matter. But what I do is if I come over here to this generic section here, okay, if this is open, then I can mess with this thing. And then this is where I'd basically add a bunch of fuel, take away a bunch of fuel. I mean, again, it can be whatever you want. So basically this is a percentage. Let's just say when the engine RPM is 300, okay, I'm going to add in, I guess I'm just saying something here, 30% fuel. When I'm at 1800, I'm going to just take it away. So this is how you can configure these tables to add or subtract fuel or do anything you want based on those tables going true. Okay. Sometimes these tables look really weird. And if I just come over here and hit auto scale like this here, now you can actually see it better. Okay. So, but all these tables, all these sections have a modifier selection. And this is where you can turn all these extra features off or on, turn on tables, do whatever it is I want to do in these areas. Okay. So if we go into the fuel table itself, this is how you basically make changes. Okay. I'm going to come over here to the hardware config. I want to go back to map. Okay. So I've screwed this table up on purpose here. Okay. So I got a load KPI on the left and I got an RPM on the right. All right. Well, let's just say you're working with a new setup and you want to just change how the scaling of this table is. It's very simple. You see that little box down there where it says toggle. Okay. Just click on this table here. And now you can set this to be whatever you want it to be. You can set the axes up any way you want. Okay. So let's just say I'm going to a high horsepower setup and this table was 407,000. Well, I'm going to make the very first box here 1,000. Then I'm going to make the last box here 9,000 RPM. Okay. So I'm rescaling the axis for the engine RPM and I'm going to highlight all that stuff. All right. So now I've got all that highlighted. If I right click on it, interpolate selected cell values. Okay, so now I'm going to interpolate between 1,000 and 9,000. Okay, does that make sense? So now I've done that, and boom. So now I've rescaled that whole table. So if you want to get a little anal on it, you can get a little cleaner. So instead of being 1347, I always take the 50 and round up or down. So I'll make that 1,300. Hit enter. Then 1,695, 1,700. So you can just round these up or down, right? So instead of just having just random numbers in there, you can just take it and just clean it up a little bit. See what I'm saying? So
If I go to 3782 right now, make that 6,000.
Yep.
Go all the way to the right to the 9,000 and then hit interpolate.
Yeah. So we'll just do it. So
not linear, but that'll give me a higher resolution.
Correct.
RPM.
Correct. Exactly. So yeah. So now we've got. Yeah, exactly. Exactly. Yeah. Yeah. It's just any way. I mean, you could put, 6,000 down here if you want.
Yeah. Okay. I mean,
Just however you want to do it. Sure. Yeah. Yeah. So you just hit interpolate. Yeah. No, it's again, you can make it whatever you want it to be. Okay. Yeah.
it's the same thing. Pressure. Boost, you got like 2100s there. I'm sure you want to.
Yeah. So we want to fix this, right? So, I'm going to see if I'm set for KPA or boost. So I'm set for just KPA right now. So again, I can make this anything I want. So let's just say you're just doing a 1-bar map sensor, right? We'll do 105 KPA and we'll do 20 KPA. Okay. So atmospheric pressure is right there at 105. If I right click and I interpolate, okay, it just takes it and just scales it exactly how I'd want it for a 1-bar map. All right. If I had a 5-bar and I wanted to make it, 500 kPa or just something higher. I mean, again, if you want to live in the kPa world, you can do that, interpolate, and now I'm seeing it that way. Okay. But you can scale these tables. And the reason why I'm showing you on this field table is anytime you see a table that has that icon down there, low left-hand corner, you can do this. So it doesn't matter what it is. I'm just giving you the example on the fuel table. All right. So the other thing here is that you can apply what I've done and it'll leave all this unchanged. So if you want to leave these numbers, you can, or it can actually interpolate these values based on what you've just done. So it'll change all this stuff here. So I'm going to leave the Z unchanged. I'm just going to apply that now. Okay. So now if I close this out, now everything's done. Okay. So I've got my new RPM range. I'm starting at 6,000 down here, over 9,000. So now you've got a ton of resolution, right? From atmospheric pressure all the way down to vacuum from there. And then obviously I'm a little bunched up down there, but it's okay. You obviously care more. So it's going to accelerate really fast through here. And once I get to 6,000, it's going to slow down, obviously, right? Because now I've got more cells to play with. But anytime you see that symbol, if I open up the spark table, see it down there, okay? If I open up the AFR table, okay, there it is. Anytime you see that table with that read bin, scale those suckers any way you want. All right.
That section also, right?
Yes. Correct. Yep. Yes.
So I go into my base fuel map and I just did right there.
Yep.
Going from 6,000 up to 9,000. Does it go into air fuel and does it go into spark?
Nope.
And rescale the same?
Nope. You gotta do those too. So again, these are independent tables. So if I go to my target O2 table, okay, see how it's 507,000? So, and the AFR table doesn't have as much resolution, right? We don't have as many columns here because it's an AFR table. It's not, you don't have to have the resolution of a spark or V or fuel table. So you'll come in here basically and just say, okay, let's make this 6,000 now. I'm going to make this 9,000 here. Okay. Come over here, right click on that guy, interpolate. I think that was the 1,000. So I'm gonna interpolate from that 1,000 to this 6, interpolate, okay? And then again, I would scale that axis any way that I want, okay? And then come over here, change it, boom, now it's all set. Okay? So scale away. It all depends on where you want to go with it, okay? Anytime you see that little box, that's how you rescale any table. It's very simple. It doesn't matter what it is, okay? Over here under the target O2 table, you're going to have positive O2 corrections. And again, positive and negative O2 corrections, you got to scale it. If you're scaling away other stuff, make sure everything else matches up with it. Okay? So what's nice about the positive O2 correction and negative tables, these will sync together. Because obviously these two tables, these positive, negative O2 corrections, these are basically the same thing. One's just positive and one's just negative. So these will work together. When you change one of these, it matches both these tables up. Okay?
One table.
Exactly. Exactly. But you have a ton of resolution to go negative or positive either way. Okay? So that's the big point about any table you see here, okay? Hit that toggle, do it however which way you want. You can have the fuel table be 1,000 to 9,000. You can have the AFR table be 4 to 6,000. The spark table can be 2 to 10. It doesn't matter. It's just going to scale it any which way you want. They don't have to match at all. Okay? It's just however you want to actually run it. Okay? So when I'm in here, what's nice to see is that you got a little, you have basically a heat plot here, right? So it's basically saying I'm going from green, which is smaller, up to red, which is hotter, right? You got a 3D view here, okay? So what's nice about the 3D view, just if you're doing a quick glance, is if you screw up somewhere, okay, I just put a 5 in there, right? Well, now it's flipping me off because now I got a 5 number in there. Now that should stare out and you're like, oh my God, I got a green and amongst a red, right? Something's wrong, obviously. But if you can't see it that way, okay, now I can. Okay. So obviously something is glaringly wrong there. Okay. So it's always a good idea to, when you're done making your changes, come in here. When you're looking at this live, okay, it'll show you where you're at. So right here, we're at 55.3. So when it's running, you'll see the ellipse, running around here. Okay. But this will tell you the curve. It'll show you the shape of the curve for whatever you have programmed. All right. Now I got the back button because I never left this window, right? So if I click back, it'll go away. Okay. So it's always a good idea. If you haven't been there in a long time, if you can't see, if you're colorblind for whatever reason, if that wasn't staring at you in the face, that green amongst a bunch of red. Again, any of these tables here that look like this can be seen in that mode. So if I came over to Spark table, okay, I got a bunch of green, a lot of red. If I looked at it here, okay, all right, it looks really strange. But according to what you're doing here, that's actually what it's doing. We got way low timing down here at idle, and then I got a lot up here under watt, right? So shape of the table is obviously very important. So any questions on how to rebind these tables? Does that make sense at all? Pretty clear? Okay. Oh, well, you can also see to the Spark Advanced table, right? It doesn't like, obviously you don't want hundreds up here. You'd have to rescale this too. Okay. So it's broken on purpose to show you guys. Obviously, we wouldn't give you a cal like this, but it's just showing you how to fix this, okay? So again, I can't go into all these different modifiers here, but just know that it's all in the instructions too. If you want to turn any of the stuff on, this is how you do it. If I wanted to turn the EGT add field correction off, I turn that off, and now those tables aren't going to do anything, okay? Real quick here, on the wide open throttle cylinder lambda offset correction, again, what's so badass about this is on the big bands, if you're on the 8-channel closed loop control, you can actually add an offset to certain cylinders, because obviously certain cylinders are working harder than others, right? So if you wanted to add, if your target AFR, in this case, going down track, if I just set this as a global number of 12.5, okay? Well, I can put an offset to certain cylinders. So if I got some cylinders that don't want to have nearly as much fuel, I can make that a little bit leaner. I can put a 0.2 offset and make that cylinder 12.7, right? I could also say negative 0.2. If I got certain cylinders that I know the worker bees, I want to keep them a little richer, I could do negative 0.2, and now their target becomes 12.3. So you have individual closed loop correction in real time, targeting their own cylinders, closed loop correction in real time. So it's pretty cool. Okay. So, but again, that feature has to be turned on down here. And then if you came over here to the, AFR configuration, okay, there's your targets right there. So I've turned it on and boom. So it's kind of hidden over here, but the word is anyways. But you could add your offsets in right there. Right. So for cylinder 1, if I wanted to make that one, 0.1. Okay. Now this is in lambda. Okay. So remember, everything in the base we do is lambda based. So you have to do that in lambda. So that meant if I target 0.85, I just made that 0.95 for that cylinder watt. Okay. So, but you can do it if you want. So does anybody have any questions on these modifiers here, how this works? Does anybody have any questions on that at all? No? Makes sense? So back to the fuel table here. This row up here, okay, this is a very important little section here, because this is how we're going to actually adjust these tables. And again, this is global. This applies to everything, right? So if there was a certain section here at idle that was way too rich, okay, I can go up here and I can start doing some stuff, okay? I have an equal sign, increment sign, decrement sign, minus sign, plus sign, pause, multiply, interpolate horizontal. So all these different buttons up here will apply to all tables. This is how you adjust them all, okay? So if this was too fat, I can come up here and say decrease cells by 10. Okay, so now all these just decrease by 10. Okay, if I want to add 10, I'm just adding 10. Okay, very basic stuff here, applies to all of them. If I wanted to add a percentage and say I want to take away 10%, I go 0.9. Does that make sense, right? Everything's based off 1, right? So I'm going to go 0.9. Now I just took these down 10%. Okay, if I want to go up by 10%, 1.1. Okay.
0, if you want to put 10% more, it's still 0.9.
10% more is 1.1. Everything's 1. Yes, 0.9.
Once you learn that, you don't see that. It's like starting from 0 from 1 again.
Yes, exactly. Once you close the window, you can't go back, all kind of stuff.
What you're saying is when you see those icons of whatever stream, they all are doing the same thing.
Exactly.
You're making a change here and it's populating through everything else globally.
Yes, correct. But it's what I mean by globally is that every table that you see here will have these buttons. So every table works exactly the same way. There's my Spark Advanced table. Here's my AFR table, right? They all have the same exact buttons. So they all do the same exact thing. Don't get lost in it. It's all the same stuff. You're either going to add, subtract, multiply. Okay, we'll do interpolate next. Okay, but it's all the tables have the same ways to adjust them. Okay. So if I go back to that fuel table I was working with here, so I've got an interpolate button here, okay? So how the interpolate works here is I got 4 corners. I got 58, 74, 44, 52, okay? If I hit that interpolate, it just interpolated basically everything in all those numbers and brought them together. Yeah, yeah. So it just brings everything together as one. Looks at the 4 corners and brings everything in, okay? So you can also interpolate horizontally. So if I'm going left to right, I'm like, I just want to interpolate this way. It just takes every row, okay, interpolate horizontal, and then it just interpolates this way, okay? If I want to interpolate vertically, if I just came over here, okay, it's going to say interpolate vertically. I just now interpolated from this box up to here, right? Good.
You made a change of 2,000 and 228, and you made a change of high, then you interpolate.
Yes. Yeah. It just depends which way you want to go with it. You want to interpolate going left to right engine RPM. If you want to interpolate from top to bottom based off map, off the load, it all depends on just what you want to do. Yep. Yep, exactly. I mean, there's some cars where they want to pour the fuel out back, and they want to have 25% fuel out there. Okay, so now I've got really red. If I look at my 3D view, but again, that's how you make those changes, and every table is the same.
So Ben, on the first one, pick a box. It goes from the 4 corners to the center.
Yes. Yeah, that's what it does. It just brings everything together from those 4 corners. Right. So what I'll do is a lot of times if I'm working with a cal that I'm completely starting from scratch, I'll basically come out here to, let's just say somewhere, this is kind of skewed, but let's come out here by peak torque, and I'll put in numbers like this here, and then I'll just hit that interpolate button. Now I've got a nice map to work with here because I just hit all 4 of those corners together. I just built something in 2 seconds, right? Because these numbers here, just because I've been doing it, these numbers 44, 64 down here, and 101 and 1, this was something to start from. And I just did it in 2 seconds by just interpolating it. Just hit that button. Okay.
What chooses where it turns red or green from?
That's just based on the actual value itself. That's just in the background. So as the numbers go up and get bigger, obviously, it just goes up higher and they get bigger, it gets darker. So
Okay.
Obviously, as we're less, we're getting more green, and that provides the green color is less. Okay.
Okay.
So if I hit the interpolate for this whole section, boom, now I just interpolated that whole box, and again, I use these 4 corners, right? So you really can't screw it up because, man, I didn't mean to do that. Well, okay, I'll just go backwards again, right? As long as you got those tables open. And what I always encourage guys to do too is if they want to just start from somewhere, before you even start working, just save this table, right? Just save it, because that way you can go and blow this thing up and it don't matter. You got a backup of it. You know what I'm saying? It's sometimes we get so ready to go and you jump in, you want to start tuning right away. You forget to do that step, obviously, but if you're constant of that, if you remember, okay, I'm going to just create a quick backup, not of the whole cow, right? Just of that table itself. it's a piece of cake because now you've got something to go back to. Okay. You also got a button here called smooth. Okay. And again, it's kind of self-explanatory. Basically what it's going to do is if I look at this guy in a 3D view, okay, I got a bunch of stuff going on here. Now, what we can do here is I'm just going to blow this thing up. I'm going to take this down by 20. I'm going to take this up by 30. Okay. So now if I look at this 3D view here, okay, I got stuff all skewed, right? So all the smoothing feature does is it doesn't matter whether it's 4 boxes down here in the corner or these 4 boxes here. It just applies a smoothing to all these numbers. So instead of having basically a jagged peak that just goes up or down, it just simply just smooths it out. So if you watch from like this 85 to 142, okay, it's going to take all these numbers and basically just start taking the edges off, okay? So if I hit that button, you see it just smooth everything out a little bit. See how the color changed? You can hit it again and you can just start smoothing it out even more, okay? And it takes out, you can see how I start getting a curve now, okay? Totally up to you to do that. Again, it just depends on how nice you want these cals to look. Sometimes they don't want to be smooth at all, right? But it just depends on how far you want to go into the table. And again, because every table has all the same exact freaking buttons, you can do it to anything, okay? So they all apply, okay? Does that make sense? Okay? It's just if you have a table, you will have the exact same icons, okay? You can also import and export tables too. Again, it's kind of the same thing as saving each table. It's just a different way to bring in that table or export it out to bring it to somewhere else. What you could also do too is, let's just say Brian's got a tune-up and he wants to share this fuel table with somebody else, okay? Just saying, you come with this guy, oh, I got a tune-up for you, right? But, right, right? But it's just the fuel table. You can take you can take his fuel table into your project and bring that fuel table in by itself. It doesn't have to be your own, okay? And that's what this import export is. You can actually export this table out, okay? And now I've exported this table. I can take this table now, import it into your cal. That'll come right in. Now, it's going to come in scaled. It's all exactly the same. And if your cal is completely different, well, it don't matter. You brought it in just like how his is. But what's handy about that is for the SR2 stuff, like gear curves, dry shaft curves, that's actually pretty handy. Because now if one dude's got a plot that you like, take it and bring it in, right? So that's what's very handy about that import export. You don't have to bring his entire cal in. You're just bringing in just that one table, okay? You're not blowing anything up. You have to worry about blowing anything up. You're just simply taking that one table itself, okay? So any questions at all? Any questions?
Are
Okay,
those
so
going to be the CSV files, just like the whole tune is?
what's that?
Are those going to be the CSV files, just like the whole tune is when
No.
you get the table?
No, so he's asking if that's going to be a CSV file when you make these. No, it's if you actually come over here and you do this export out, export here, it's a dot table. So these are not CSVs at all. CSVs can be generated from data log files, not from these. Okay.
Okay,
So
thank
this
you.
has nothing in relation to an Excel. Correct. Yeah. That it's only gonna interact with the Gen4 software. That's it. Yes.
One of my big questions. What are the file extensions on all this?
So Chip's asking what the file extensions are.
In BigStuff 3 Gen 4.
Yes.
Is it .big? I mean, that was a cal.
Well, when you save a tune, okay, a
Yes.
tune is called .big tune.
There you go.
Okay,
Right?
a tune is called .big tune. If you come over here and you save a table or you export a table, okay. If I come over here, save, it's going to be a .big tune part. Okay. Part. Okay. And then the logs are MLG files. They're called MLGs. So when we get over into the logger section, they're just .mlgs. You don't have to worry about anything else. Okay. See here where it says MLG. Okay. That's it.
There's only 3 extensions.
The only 3 you have to worry about. And for the most part, all you're ever going to use is going to be the .big tune or this. Okay. If you start getting in individual tables, great. That's the only other one they use. There's nothing else to know. Okay. All right. So real quickly here in the fuel settings, all this transient fuel stuff here, this is when you're just tapping the throttle, if it's going pig rich, if it's going pig lean, okay? You can go mess around with stuff in your heart's content. It's all in the instructions. That's what all this stuff is. If I come over here to the tuning and dyno views tab, and I come down to Excel Enrich TPS, okay? See that one down there in the corner? These are the only two tables that you have to care about for when it comes to when you're whacking the throttle, okay? And all these simply are tables based on the throttle moving and how fast the throttle is moving, okay? So this guy right here is basically like cam profile and a carburetor, okay? This is basically when you whack the throttle, this you know, counts how fast it moves. So this is going to give you a bigger pump squirt, okay? So basically this is raw milliseconds of fuel, okay, being introduced based on how fast you whack the throttle, okay? Some curves, okay, look like this. They're very high, okay? So you whack the throttle, boom, I got to shove a ton of fuel in there, okay? And some curves, for the most part, are almost next to nothing. Come down here, that's 1 millisecond. Interpolate. Again, it's the same icons here, right? Up, down, minus, plus, X, right? The same exact little icons down here, okay? But it just depends on what your motor wants. So again, you start whacking the throttle, it's all muddy. If the O2 sensor starts showing it's going really pig fat, these are your two tables to work with, okay? So that shape, though, of this one here, 99% cars are going to have a shape, you know, with something like this. Okay, I just know it's just how they all are. Okay, you need something like that. You start going over a certain point, just shove a bunch of fuel in there. Okay. On the A position curve over here, what this is as a throttle blade opens up on anything fuel injected, when you first start to open up a little bit, that's when the most amount of air comes in first. Okay, that's when that big swig of air comes in. So you'll see here we're adding fuel based on that. Okay, and then ultimately, as we actually wind out, we start pulling fuel out. You're gonna have some curves that are gonna be up really high like this, or some up low. It's just the way the throttle interacts, okay, with the system. Okay, but these are your two tables. Just follow these shapes, move them up or down. That's all you gotta do. Either it likes it or don't like it. Okay, don't get lost in all this other stuff over here. There's a lot of other stuff to play with. Okay, don't worry about it. Yes. No, that's when the fuel first comes in. That's why you'll see here it's got that bump, right? It's a percentage adder. Yes. So these tables work off of the base fuel map, whatever fuel map that you're on. Okay. Everything works basically with whatever table you're running. The accelerator pump curve, though, that's just a raw millisecond. So whatever you guys hit, it's going to add that much millisecond based on that throttle moving that fast. Okay. The A position curve, though, okay, that's a percentage adder. So when you first move the throttle from a half to, let's say, 24%, I'm going to add from 40 to 7% of fuel right there. Now, if you whack it really hard, I'm actually going to pull out 20%. Because what happens is if you're not opening it up slowly, you go watt real quick, you don't need to add a bunch of fuel. It's already on the fuel table at that point for the most part. So this curve actually works really well, okay? I've got some curves that are actually from -60, again, it just works, to like -90. Oops, sorry. -60 here, -90 there. I'm going to interpolate, right? Just going to use that little interpolate feature. Okay, I'm buried down there something like this, but it just works. So just move that curve up or down and you'll find it instantly. Right. Yep. You possibly do. Yeah, it's very possible. Our factory curve is actually this. It's -25 to 0. I'm sorry, to 0 here. -25 there. So I'm going to interpolate from here to here. Okay. And then I'm going to make that -30. I'm going to interpolate from here to here. This is actually how, sorry, I should be a 25, not negative. Okay, so that's the factory curve. So when you first open the throttle, we're going to give you a bunch of fuel, because if you're not opening it very far, you're going to have a bunch of air that goes by. Give you a little bit of pump squirt, right? But if you open it really far, we actually are going to take fuel out. It's just the way the curve works. It works really well. So literally, if you take these two curves and just go up or down, you'll nail it within a couple pulls. It's that easy. So don't overthink the Excel pump. It's really just these two. That's it. Okay. What this noise threshold number is this number up here where it says 2. Okay. As your throttle is moving, it's basically the number that says, do I provide Excel enrichment or not? Okay. So the lower the number, it's going to be providing pump shot all the time. Okay. The higher the number, which I believe the max is 12, it's going to take a lot to actually see the throttle move before it actually activates these tables. Okay. So that's how fast you adjust the resolution of it. Okay. Now, just so you know, all these tables here in the tuning and dyno views, all these are just grouped together tables out here in the calibration itself. So if I got a fuel settings, transient fuel, accelerator pump curve, this is going to be the same exact table, right? If I click on this, okay, there's my table. So all the tuning and dyno views are just everything out there just put together so you can see them nice. So when you make this change here, okay, out here on just this table alone, if I was to make this 0, okay, this one changed also, right? Because it's all the same stuff. So don't worry about, oh, do I have to go back now? And hey, Brian, the battery's at 9 volts over there, just so you know. Is that charger on? I just saw it down to 9 right now. There we go. What's that? All right. There we go. Now we're climbing up. Okay. So just so don't get lost, like, oh my God, there's a million tables. It's not. We're just grouping them together nice and pretty for you. Okay. And if I go back here, and what's nice about these tuning and dyno views also too is the fact that you can come down here and look at all the values down below while you're playing with this stuff, right? Because what do you care about this stuff? You care about your TPS moving, you care about the O2 sensors showing you what's going on when you whack it. So it's just grouped together nice and pretty for you. Okay. Does that make sense? Okay. So like I said, just follow those curves. It'll work. It just works. Just follow those curves. Go up or down with that. You'll win every time. Okay. All right. So that's basically the fuel setting stuff. For injector phase angle, guys, don't worry about this. I get questions about this. Leave it 170. This is for if you guys care about where the fuel starts and stops. It's really an NA thing. You got to have a cam card. You got to have all that stuff. And maybe Tom wants to go more into it. We don't have any time for that today. But leave this at 170. Don't touch it. Just leave it there for 99% of users. Okay. Right. We're not going to that right now. All right. Startup. So this is very simple, guys. Crank configuration here. All this means is that when we're above 400, the engine's considered running. When we're cranking, we're going to provide 15 degrees of spark. Okay. Very simple stuff. Okay. So under 400.
Pick up the football on your spark table for crank spark?
No, it's Gen 4. And the 3 would actually use the table.
That's what, yeah, I just said.
Yeah.
Okay, okay.
So in this, you just set whatever the cranking value is here. Okay. So the other one that you have here is, okay, again, you got a curve. So all these curves are, okay, again, all the curves are exactly the same. Basically, it's a 1D table here. Okay, and all this is, if you don't have numbers at the bottom of these tables, you see these little dots up here in the upper right corner? Okay, just left click that. And now it'll show all your values down here. Okay. So when you're cranking, again, it's very simple. This is just a raw millisecond number. So at 100 degrees right now, because we're in pro mod mode, right? I'm going to provide 12 milliseconds of injector pulse width. It's a raw table. Okay. No, it's only based off coolant. Right. Yeah. So what you can do is there's an adder you can do based off cranking to add more fuel if you want, or you just simply just crank these up to, add 20 to them or something. If you got a belt drive pump, needs some more fuel pressure built up, just give it just more. Know what I'm saying? So, but the base table is just based off coolant. Okay. Again, all the icons down here, right? I got an equal to, up, down, minus, plus, multiply, interpolate, right? It's all the same for all these 1D tables. Everything's all the same. And again, what can I do? I can, hey, Brian, I want your table. Okay. You give somebody else your table if you want. You can save each one independently. Everything can be saved on its own. Okay. The other ones here for more street stuff: desired idle RPM curve, IX start position curve, throttle follower. This is all just idle stuff. We can get into that later on if you want, but very basic tables for setting up idle stuff. Okay. All right. So now let's go to the AFR section. So again, the modifier selection, I can activate tables, 1D tables, 2D tables based on Lambda stuff going on. Okay. That's how we do it. Same as the fuel section. This is the modifier. Okay. This is the heart of the AFR section. So you got a couple things to look at here. The heater startup mode, we talked about that a little bit. Basically, we just turn on all the Bosch sensors if you want at the heater startup. You got big bands, you got 802s, all those suckers light off too. Okay. O2 feedback control. If you want to be in closed loop, let the system correct for you. Great. If you don't, press open loop and there's no feedback at all. All right. So if I am in closed loop, just to run through these here, you got to have some thresholds that are met. Okay, closed loop on RPM, 600. So that means above 600 RPM, closed loop's enabled. The on threshold's 150. Will I ever actually, because I'm in Pro Mod mode, get to 150 degrees? No, I won't, right? Because Pro Mod mode, I lock them out at 100 degrees. So if I'm in Pro Mod mode and I want this stuff that I want closed loop to work, I got to set this at, 80 on, 70 off. This way I satisfy, right? Because it looks at this coolant value in Pro Mod mode also. So you've got to fake it out. You got to say, okay, if you're over 80 degrees, I'm obviously at 100, it's going to work. Does that make sense? Chip?
What about with the two-step?
We turn it off.
This gets turned off?
Yeah, you're not in closed loop. You're not in closed loop. So anytime you're on a rev limiter, closed loop is turned off. Okay.
That's new to BigStuff 4, right? Or Gen4. I'd have to put my two-step up around like 4,000
Yes.
for closed.
Yeah, because you're on the 3.
You wouldn't read the random.
Correct. Yeah. If you were on closed loop before, if you were really low and it was closed loop correcting, as soon as the rev limiter's turned on, you'll see the correction turn off. Yeah. Yep. Even on the max rev limiter too. Anytime any rev limiter goes true, closed loop turns off. Okay. So you can't. The reason why is because when you're misfiring, a bunch of raw oxygen is going out the tailpipe anyways, so it's going to read extremely lean. Yep. So there's no reason to be in closed loop anyways. Okay. So when you're over here as well, this is how fast the closed loop correction works. Okay. If you're in duals, you're going to be at 35% or so. If you're in 802 closed loop correction, you're going to be around 10. Okay. Again, we're slowing it down. The smaller the number, the slower it reacts. You got 802s. Sorry, you got 8 fuel injectors working to control. You got to slow it down. That's what Tom was talking about in the very beginning. Okay. So speed it up for duals, slow it down for the bank. Okay. Number 02s, 90% of our guys or most of the guys are going to use duals. If you're on the IC rims, you set it for IC rim as far as these guys here. Okay. For the big bands. You can have the big bands going and just be in dual as well. It's up to you, however you want to control. Okay. The engine bank, again, we need to know if it's Chevy or Ford. Okay, why? Because we showed you on that screen back here, right? Depending on where the O2 is, right? We got to know what type of engine it is, right? EGT units can be in Fahrenheit or Celsius. Now, when the EGT misfire, remember we talked about when EGTs get too hot, okay? You can set it to where it starts cutting the ignition too. So when that EGT safety hits and turns off a cylinder, it'll start banging ETM. So it'll go to a 20. and go brrrr, so you'll actually feel it too. Okay. You can make it though, so that you got a 31 in there for full power. So if the safety hits, you'll never actually know. But this way, when the safety is triggered, you'll feel the engine misfiring because we've knocked the ETM, we've knocked the torque down to a level of 20. Okay, that's what that number is for. The NTK O2 sensors, the alcohol-based ones, you can calibrate those. We won't do them now. But if you click yes, that is how you test to make sure those O2 sensors are okay. All right, Bosch guys will never have to worry about that. The Bosches don't do that. All right, and if you actually come over here, there's a tab down here in the very bottom right here that says NTK wideband O2. If I click on that, it'll actually give you right here, this O2 percentage, okay? This will actually show you in real time what it's actually reading for O2. It's about 21% in free air. So that's how you actually make sure those sensors are scaled okay and they're correct. If they're out in left field either way, around, if they're not near 20, the sensor's dead. That's how you know. Okay. So that's that section here. Now, the other important part of when you get all the closed loop settings correct is when you come over here to this target O2 table, it's going to correct based off these values, okay? This is what it's going to correct based on, is whatever is in your target AFR table. If I come over here, though, I got to set the positive table. So in this case, I'm set up to correct 50% positive, and I'm set up to correct negative 10% out here like this, right? So, but again, it's the same table as you guys are used to. If I want it to be 50 up high, but 10 over here, okay, so up to only 10% here. As soon as I get above 2600 to 37, okay, now 50%. Any way you guys want to do it, totally scalable. A lot of guys run an open loop too. They don't want to have any correction. Totally fine. It's totally up to you, okay. But this is how you establish the min and max limits based on the fueling requirements that you've targeted, okay. So new combinations will pretty much target. I'll do a bunch of correction at first, just because you never know what's going to happen out there. Then you start reeling it back in, right? Okay. Okay. We have an AFR safety correction here. So I'm sorry, an AFR safety configuration. What this basically means is that you can establish an ignition cut and a safety to trigger based off the system going too lean. Okay. You can enable it or you can disable it. Basically, again, you have a threshold. If I wanted to make it, 18 to 1, okay, it's going to turn back off with a 0.1 hysteresis here or whatever hysteresis I want to make. Minimum trigger RPM, minimum TPS, and I'm going to do a 25 ETM. So you can have it so that if it sees any AFR on the dual bank or the individuals, it'll cut the engine, all right? If you're doing rim modules, it'll tell you which cylinder that it cut. Okay, so if you have that cylinder go too lean and it hits that target, it'll cut the engine, it'll activate the ETM number of 25, you'll feel the brrr, and then in the log, it'll show you which cylinder it took out. Okay, so if you have something going in that cylinder, something's happening, that's how you set it up. Okay. All right, AFR section. Any questions at all about that, guys? About that section at all? Okay, you guys learn this table, right? Same table everywhere, same icon, same everything, right? It's all the same, okay, on how you adjust everything. Obviously, the values are different, right? You're going to put in different values, okay?
Ben, I remember what that thing was that you put out that saved the motor. It was the Blaine brothers, and didn't their pump go bad or something?
Yeah, so they lost their fuel pump, they lost fuel pressure, and O2 correction just came in, just took off, yeah, and saved the engine. Yeah, it was up there quite a bit.
Something.
Yeah. So we'll finish Spark here real quick and then we'll get some food. But again, the Spark Advance here, okay, same thing, same table, same icons, okay? We've already talked about the scaling of all this stuff, okay? That's just Spark Table 1. Spark Modifier Selection. Again, bunch of adders you can have, okay? I can turn on idle spark. There's an intake or temperature spark based on, it can add or subtract timing based on the intake air temperature. This one here is when you're on the trans brake, 2-step or 3-step, we can actually take some dwell out of the engine, again, to kind of calm the engine down on the rev limiter as well. but all these modifiers are existing to the engine, I'm sorry, to the spark section itself. Okay. So,
Just well. I forget the MS.
correct. Correct. Yeah. So just real. Yeah. So just real quick on that. If you have a CDI box that we're driving, we can drive any CDI box. Those boxes have built-in ignition control. So all we do is give it a signal and then it takes it from there. Okay. For ignition coils, there's something called dwell time, and all dwell time is the amount of time that coil can charge up before it releases the spark. So CDI boxes, we don't do that because they control it themselves. Okay. If you have a set of our coils or any coils that you're running directly, you can establish that charge time. And while you're actually on any rev limiter, I can knock out as much dwell as I want, again, to calm it down. Okay. Totally up to you. You can run it if you want to or not. So also the other one that you're going to use here is this test timing up here. Okay. So when you first get the engine running, remember we talked about that in the very beginning. That's how you establish the timing. The engine, the ECU has no idea what timing is. It doesn't know. It doesn't care. It's up to you to actually establish with your eyeballs where you're at. Okay. It has no idea where it's at. So you have to tell it where it's at. Okay. And that's what that one's for.
Okay, so you go and check this box, no matter what your spark map says,
Yes.
you got a 30 in there, so do you have to go over an RPM threshold?
Yeah. So what'll happen is you always go to 3000 to set it.
Yep.
But then if you go, let's say watt, I think if you go over 25% throttle, it bails out of this and goes to your main spark table. So there's a safety in place if you forget to turn it off. Okay. So if you do leave it on by accident, it's after 25%, it goes away, and whatever's on the spark table that you're running is what it goes to. Yeah. So again, it's one of those things to where when you set it, leave it alone, disable it, and forget it, and just get out of there. You'll never be in there ever again.
Well, just for everybody in BigStuff 3, Gen 3, you got to actually go in and build a check my spark map with all 20s in every single cell.
Correct.
And then you got to get it above TPS, so it gets rid of the idle spark function, and then you can hit it with a light on a coil and plug and make sure that it's
Correct.
20 degrees. That's our checkpoint.
Correct. Exactly.
Oh,
Pretty much. Pretty much. Pretty much. Are you sold yet or no? Are we still? It's getting close. Whoa. Whoa. Wow. Look at that. Yeah. Yeah. Well, we've covered pretty much the spark section now. Well, real quick here. Dwell timetable. Okay. This is where you can establish that dwell time. It's very simple. Again, if you know anything about dwell at all, just got battery voltage and you got engine RPM. Okay. Just set this to whatever you want the dwell to be. Most times you're going to have a high number up here. You'll have, let's just say 7 milliseconds or so, and then you'll ramp it in or something, something like that based off of engine RPM. Okay. That's how typically most of these tables are. It's do it however which way you want. Totally up to you. The other two that we do typically work on are idle spark. So as your engine's running, this is just adding or subtracting spark to keep the engine RPM target where you're at. Again, very self-explanatory. Use it all the time. Love that. And then the last one is here's the gear shift retards. So you can have a retard in here. So when it shifts gears, you can apply a retard amount, let's just say 5 degrees, and that would be your ramp rate of how fast it comes back in. Use that all the time, small time racing or small tire racing. If you shift that gear, especially a turbo car, it may take off on wheel speed. Apply some shift retard right there, and you can establish up to 5 different gears in there if you want. Okay, so that's how that works. So it's all built in. It's all built into the system. So it's actually four gears. It would be 5. So, anyways, let's eat. It's 12:05 already. Crazy how the day goes by, isn't it? Go ahead. Let's eat some food. Dan is in charge of in-cylinder pressure monitoring with his system. So we're going to have him start talking about this now.
All right,
Right.
guys. Wanted to say thank you to Brian and Ben for having me here today to give me an opportunity to introduce myself. I'm Dan Cordier, DC Inc. What we do is combustion analysis work. So we got to meet Ben and Brian at a dyno test where we were doing some mountain motor pro stock work. And during that time, the customer had a grid ignition system that we felt a little limited by the control. So that's how we ended up meeting Ben recently here. He came to North Carolina and we said, hey, we need some expansion to be able to run individual coils so we can do our spark cal the way we really want to do our spark cal. We were a bit restricted with the grid ignition and distributor. So Ben flew in and Brian came up and they said, hey, we're going to make sure that this installation goes clean. We want it to be perfect. So we're going to attend the test opportunity. The installation was successful. We got to work together for the day, moving the spark trim, spark cal to run this big inch engine. This process was then moved over from the engine dyno into the car, and we'll talk about that as we go a little bit. So here's some background information on me and what we're going to do today. We're just going to overview, just high level, why would we even want combustion analysis? What are we going to gain out of doing this? So we're going to kind of do a flyover, talk about some of the things that are involved in procuring the data, some of the components of it, a little bit of tech, a little bit of detail, but I guess my background is in 500 cubic inch pro stock. So in 2000, I first started working for Dart Machinery in Detroit, Michigan, on their pro stock program. Moved to North Carolina in the mid to late 2000s, worked on the Mike Edwards pro stock program for quite some time, moved on to Gray Motorsports. That's where we first started doing combustion development work, is at the Gray Motorsports program. I ended my time in pro stock in 2018 with Tanner Gray's championship, where combustion analysis showed us so much. That was instrumental in the success of that program. And that's why I'm standing here today. So when we first got introduced to combustion analysis, it was through our COPO program. So Robin Wright of General Motors came down and spent some time with us from GM doing dyno testing at our facility. And the time that Robin spent with us, he was impressed with how feverishly we worked and how hard we worked. But he was also equally impressed with how inaccurate we worked. So he said, you guys process hard parts amazing. However, you're skipping over the details of all these components. And we knew that we could get better. And it was like, all right. So he says, you know, if you guys would just take some combustion
real quick.
development into your equation, you could do a lot. We said, well, what will that do for us? He said, well, first and foremost, you could build an engine that makes more power and is more durable. And that was such a foreign concept. The idea of making more power and gaining durability was so separated. You know, we pushed that stuff within a half inch of its life, backed it up 1/8 of an inch, and we ran it like that. So that was the start of the introduction for me to combustion development. It was like, huh, we need to learn more about this. So I'm going to jump ahead a little bit, saying after 2018, I went on to novel engine technology development. So we were doing a rotary program. It was not apex rotor like a Wankel, but it was barrel design. And I got introduced to that program, went in and I said, look, from what I've learned and where you guys are trying to take this, you're not going to do it without combustion equipment. It's not going to happen. And so that's how I got integrated with Plex. Was I was looking for a system that I could self-manage, that we could afford, and I started growing our novel engine technology and needing more features out of the Plex. So as we were trying to grow the engine development side, we were also growing the Plex side of the data acquisition, what it needed to be for the general user. And that's how Plex and I became integrated. I became almost a beta tester for them while I was doing engine development. So we came up with this great relationship. We worked together all the time to provide a turnkey solution for the average user at an affordable cost point. So that being said, let's talk about what we learned in 500-inch development and say how it affected me. So the first opportunity, let's back up for a second. The first opportunity we ever had with combustion development, we subbed out our cylinder head machining. So we sent the cylinder head that you see here to a shop and let them do the drill and tap work. And we're going to talk about some drill and tap work here in a minute. But you can see these plugs right here in the cylinder head. Okay. So AVL comes in. AVL is a large dyno manufacturer. They make combustion systems. They make combustion analysis equipment. We hired in a representative. The representative shows up. We have our engine sitting on the dyno. He walks into the cell, starts to set his equipment up. His name is Gary Patterson. He takes the combustion sensor, screws it into the cylinder, and it just keeps going. We're done. First shot. Game over. So we got this guy down here at thousands of dollars a day. We have everything set up. We're excited. We're ready to go, and we're not. So Gary says, well, I'm going to head back to Michigan. Hang on, buddy. We're pro stock guys. We're going to fix this. Just sit tight. We had a 4-day test session scheduled. We spent 2.5 days fixing that cylinder head and getting it back on the dyno. Okay. These are M5 threads in these sensors. They're very small. They're very fragile. And there's a face sealing feature with a spot face in the head to make all this work. So we ended up plugging that head, getting it back on the dyno, and then this is what happened. So we make our first dyno pull. Gary says, okay, let's see your baseline. Okay. So we were peak torque 8,500, peak power 10.5, 11,000 RPM shift. And when you pulled the gear, it pulls back to 9,000. That red curve you see is a very typical pro stock dyno pull with that saddle or that belly in it. Okay. How do we get to that? Well, the reason the engine has that feature is because as we turn more RPM, the headers got shorter, the manifolds got shorter, and the tune got more sensitive. It became way sensitive. Well, we also had the amount of dyno resolution. So when you run, let's say, a commercially available dyno like a Superflow, there's nothing wrong with a Superflow, but a lot of that data is aliased out of the dyno. They build smoother curves that you can see. We were running DPAC software and it was very raw. So we got to see this. And the first time I ever saw this when I went there from Mike Edwards' program into the Gray program, I told him something was wrong with their dyno. I did. I said, something's wrong. And they said, no, it's not. And it took me a while to believe that. So we make our first pull with Gary and he says, okay, I'm going to start doing some ignition tuning for you. So now we have a scope inside the engine with the pressure sensor that shows us the calibration. And he says, okay, we're going to add and remove spark. Okay. So you start saying, add spark, put 3 degrees in this cylinder at this RPM, put 2 degrees in this cylinder, take 1 degree out, add, remove, add, remove, add, remove per cylinder per RPM. Every 100 RPM, we're doing this. I looked at him. I said, time out. Hang on, buddy. Are you sure about this? I'll never forget it. He looks at me and goes, as a matter of fact, I'm more than sure about this, and I'm just getting warmed up. As a guy who builds 500-inch engines, timing is sensitive. And I knew that that thing was going to be a pile of metal on the floor that I was going to be fixing. I said, all right, here we go. And I held my breath. The green pull is the next pull we made after the calibration work. We took out no wrenches. We changed no hard parts. Nothing happened except optimizing the calibration. It picked up power over the top. It filled in the belly. No matter how many hard parts we threw at that 500-inch engine, intake manifolds, exhaust, camshaft, springs, rocker gear, it would not fix it. We could shift the curve about that 9,200, a little closer to peak, a little further from peak. It would move around, but we couldn't make it go away. Why? Because we didn't have tools to analyze what was going on. That's why. The minute we did, the science behind what that is, we're not going to get into today, But the idea of having a scope and a tool that you can use to work on your engine and gain performance and durability is the answer. So everyone here is in tune with, no pun intended, calibration with an O2 sensor, right? Walk in to a program, pick a program, and say, I'm going to tune your engine without an O2. Yeah, you might get it running okay. It might be all right.
Right.
But now I'm going to walk in behind you and I'm going to put 8 O2s on that engine. I'm going to look like a hero. And that's what we're doing here. We have the tool and the scope to look in the cylinder and say, what does this need for individual RPM spark timing to be able to calibrate it? So we're taking what you guys are used to in individual cylinder calibration and adding the spark timing to it. How do we do that? What do we need to do this? Because after the day I saw that, you can't unsee that. You are not going to walk away. This number right here in the middle, that's over 2 years of hardcore, excellent pro stock development. That number in the middle and some up top, it's hard to come by. And after we did this, you don't go back from it.
How much horsepower is that right there? How much is that gain?
I'm going to tell you the bump in the middle was probably filling that belly was 15 on the average in the middle and 5 over peak. There are some folklore stories about how much it might have been really worth, but that's what I recall off the top of my head.
Okay.
It was back in 2014, but
yeah,
we started then saying, okay, we're doing better on our dyno development. Now, what do we do from here? Well, that's a hard call. We're going to go through a little bit of data here, but it's intermittent, right? So it's not just a particular cylinder, but when you do see the outliers of, let's say, number 7 cylinder, all of a sudden the cylinder is breaking a whole bunch of parts that makes extra power than the other ones. Now I get it, right? Now I see why. So what do we need to do to collect some data? We have to have some parts and features, right? We have to have a piezoelectric sensor. We need a charge amplification for that sensor. We need to find out where the crankshaft is. We need a combustion system. We need some software, and we need wiring. The piezoelectric sensor is going to take your pressure and use a diaphragm inside of the diaphragm and crystal inside the sensor to create a millivolt signal. We're then going to take a charge amplifier, condition that signal into a voltage signal. We're going to find out where that crank is at every degree of rotation. We're going to take the combustion system. That's how we're going to harness and gather this data. We're going to use the software to analyze what we've harvested. And the wiring harness is going to be the communication between the sensors on the engine and the combustion system. Okay. I prefer the back of the crank 9.9 times out of 10. So what do we have to do to be prepared to take a signal for this sensor? Well, this is the point of entry, right? This is the scary spot for everybody. This is the, I got to cross this threshold. Well, it can be scary, but it can also be explained, right? We have a form, drill, and tap that makes it so this is the port. This second step is the seating face shoulder for the sensor and the diameter for, or drill diameter for the tap. And the next diameter is the clearance hole. And we're going to show you that in a second. But this is what we're trying to do. Most cylinder head machining can be done in a manual way. It'd be almost like drilling and tapping for spark plug thread, right? You're going to move over on bore space, things like that. It's fundamental machining. There's a few features and do's and don'ts along the way. We're not going to cross those today, but for the guys who do want to talk about this, I'm more than willing to share information with you about what it takes to put a sensor in a head. But this is just a broad scope overview of intersecting the combustion space in the head. There's the tools it takes to do it. And this head was done on a Bridgeport with a rollover fixture. There was nothing dramatic about it. Sir.
Location of sensor to be consistent from cylinder to cylinder.
Right. You want to have it consistent. So you're gonna pick your zero location and like so LS engine 400 bore space, right? You're gonna do multiple phases of machining. What I like to do is if I'm gonna do it, I'm gonna spot the head first for a flat pad, right? And I'm gonna move over 400. Then I'm gonna come back, do my center 400, right? Each cylinder. Then I'm gonna come with my form drill. I'm going to set my depth and I'm going to set a positive stop on the mill if I'm doing it manually. I set a positive stop on the mill. Cylinder 1, okay, I got my depth, I'm satisfied, 400 again. Then we're going to tap and we're going to tap. I don't have the confidence to power tap something like that. So we're going to use the mill as a centering device with a spring-loaded center in it, force the tap down, and we're going to count 16 turns for a full tap, back it out, and we're going to do that again for 400 until we're done. So the answer, yes.
Where it enters into the
Yeah, that I think I do want to answer that question, but I think that's a kind of a loaded question. No, let's say that every application is going to have its nuances and challenges it's going to fight, and the standardized answer would be what I want to see is I want to see a 50% bisection of the combustion space into the quench pad or squish pad to get port flows and squish flows. Now, your engine over there in your car is a lot different, but you also have different constraints and this has water in it, right? Or where your car does not. So there's opportunities that we need to figure out based on constraints. So some of the constraints are maybe even the exhaust, right? You want to stand that sensor straight up and be as perpendicular to the piston as you possibly could, but that's not going to happen, right? So we have to make compromises and look at each situation holistically, because your stuff would be different than this LS or a small block Chevy. So, but what we really want, just to open this up now that you have said it, what we really want is to be as far away from any ringing noises as possible, which means valves, spark plugs, right? We want to be as far away from those as possible. We want to have the sensor wiring that comes out to be as far away from any heat, rotating parts. Seems pretty obvious, right? But those are some of the constraints. So certain engines, we've ended up favoring the exhaust side. Certain engines like this was a better opportunity just to get where it is on the intake side. Yeah, the intake valve is bigger, it rings louder, but it's really far away, right? So each one of these presents its own unique case study and challenge. Now, I mean, you do multiples of yours or something, then, you know, you set it up for a standard, so they're all the same for your engine package or a Noonan or something like that, then yeah. So let's talk about what the installation really looks like. This is truly the point of entry that once this is done to an engine, it's all pretty straightforward from here. Like, we take out the parts, we send you the parts, we bring the parts, whatever it is. This is the part that scares everybody. So if we can take this away from scary and say, this is what it looks like, it's pretty accessible. So if we look in the top picture at the cutaway, you can see the port. That was our 125 drill diameter that's going to go into the combustion space to get pressure to the sensor. We can see the face sealing. We can see the face sealing feature where it seats, the threading, the hex drive for the installation tool, and then the clearance, which is about 290 diameter, depending on which tooling we select. We look down here and we look at, here's the sensor installed. Here's what the tool looks like. It's a tube with a hex inside of it. The sensor wire passes through the center of the tube, depending on the sensor wire we're using, or it has a cutaway in the tube. Like, for example, one of the sensors I have with me has a hex on it to thread onto our amp. That cannot pass through the center of the tube, but if it had a BNC connector, it would unthread, go straight through the tube, install, remove the tool, which is just a tube, thread your sensor end back on. We torque them to 1.5 Newton meters or 13 inch-pounds. We have to seal it on the face, so the torque value is important, but more so internally in the cutaway of the sensor, you see the diaphragm I'm speaking of, and there's crystals inside of there. That's what generates that piezoelectric sensor signal. So inside that diaphragm is moving with pressure, and that wall of where the threaded area of the minor of the thread and that exterior, you can crush that thing and ruin that sensor. Sensors range right now, currently sensors are $3,400 to $4,500 a piece. So the idea that you're going to just wind one in and just say it feels good, probably not the best choice. So this is a like Amazon special tool, right? I buy these things, they're like $200. Anybody that has a torque wrench, like a Snap-on Digital, it'll go into inch pounds or Newton meters. Whatever you got, that'll go to 13 inch pounds or 1.5 Newton meters. So that's about the sensor installation. So we did kind of talk about what makes up the system. Well, we have to find the crankshaft. So we're all familiar with a reluctor wheel, whether it's inside of our Hemi or LS or Ford, an import engine, a lot of them on the inside. But if we don't, as Tom stated, right, do you run it on the front or do you run it on the back? Well, I run them on the back whenever possible. I'll go through a lot of hoops to get one on the back of a car or back of a flywheel because it's more stable back there rather than the balancer. If you look at when you gap your balancer to your crank trigger, there's a reason you're running 50 to 75 to 80 thousandths, because if not, it's going to hit. Well, if we're trying to indicate where that crankshaft's going to be and we have this whirling unpredictability, that's a bad idea. Like on the front of that blower motor of yours over there, Brian, who knows how much the front of that crankshaft's flexing? I mean, I don't know what your lifespan on that crankshaft is, but what's that? Yours is on the back. Well, there you go. So, so we need to find the crankshaft position. We can make, modify, find reluctor wheels, a 60-2 or anything divisible by 360. Encoders will work with our Plex system. There is the Plex system. Just for illustration, there's other indicating systems out there that look like your VCR for size. They're just sheet metal boxes. They're not made for outside of the lab. We feel differently about it. There's a PCA 2000. It's 4 by 4 inches. It's extremely light. It is a billet case that is sealed. It's I-67 sealed, so it can take weather. So, you know, in my mind, I see power sports. In my mind, I see a boat. In my mind, I see, you know, the racetrack. So size, light, compact, pro stock bike guys are looking at it, stuff like that. We have our charge amplifier, again, size compact, right? Everything we do with our wiring harnesses is sealed, potted, DR25 wrapped, labeled, and auto sport connected. They look like this. This is our mini harness. What you see there is a full harness. There's different reasons to go with each. Here's our exploded view of our sensor. Face sealing, 5mm, hex, pretty straightforward. So those are things that you're going to need. What are we going to do when we're all installed? We have the sensor, we have the wiring harness, we have the PCA, we are ready to go. What are we going to see? We're going to see IMEP, indicated mean effective pressure. That is going to be an average of the pressure over an entire cycle, 720 degrees. P max, the maximum pressure and the crank angle it happens at. Heat release, that is the pillar and foundation of our CA50 calibration. We're going to get to CA50 in a minute. To describe burn duration. When we collect data, what are we going to do with it? All right. Well, we saw in our pro stock example, ignition tuning matters, right? So the base of every comparison test you're going to do, you're going to understand your spark calibration. You can always put the fuel back. Ben does a great job of having individual cylinder control with the fuel. You can work on the fuel. You got an O2 to read it. Let's get the spark back to that. If I have manifold A and manifold B, if I haven't brought the spark calibration back to a standard, which we're going to go through that in CA50 in a minute. If I haven't brought that back, now I have an ABC test, not an AB test. You have to bring that tune back to look at that. It's a big deal. I I think we've stepped over a lot of good components in the past because we weren't analyzing data, which misdirects a program, right? I know that a manifold being shorter does this. It didn't run good. What do we do now? Well, maybe we need to make it longer. No, you don't make it longer. You fix the calibration, right? So it drives the direction of the program taking quality data. What else can we do? Well, camshaft designs, right? We're going to look at this PV loop here. The PV loop would help us with camshaft designs. We might want to make exhaust design work changes, data quality checks, health and engine inspection. All of a sudden, yeah, the cylinder's not running good. Maybe we need to stop. Maybe there's a mechanical problem. Maybe it's a tune problem. Knock detection, big one, right? Get an engine knocking, start really damaging some parts, knock will show high pressure spikes that damage and over Pmax an engine, right? Power per cylinder. I kind of like power per cylinder because I can kind of point out the weak link in the chain. I can say, man, I got 6 cylinders that run really good. I got one that is extremely good and one that's just terrible. Why? How do I make the other 7 like the one that's really good? What does that do that's so exceptional that makes this better? Total observed power, all of them together. Brian and I were talking last night about what if I basically gave you a dyno sheet running down the racetrack? If I said, yeah, you're making this much power today, but next track you go to, the conditions are totally different. You're 500 horse observed off of where you were. How would that affect your car? How would that affect your tuning? Information for manufacturer. Everyone in here has made pistons before, connecting rods. Your manufacturer says, hey, what is your Pmax threshold? What do you expect to see? Most people go, I don't know. Well, now you do. The information's here. Dyno validation. Good one. Your combustion system says you're making more power. Your dyno says you're making more power. Everything's cool. What happens when the day comes when you question that dyno? You go, man, I know this thing's better than what it is. You look to that combustion system and it's going to tell you, you might not like the answer, but the engine is down or the dyno is wrong. For better or for worse, that combustion system will back up that dyno, right? If you know how to use that tool. CA50. I keep saying we're going to talk about it. Here we are. CA50. C is crank. A is angle. 50 is 50% of the burn. We have a target placement or CA50 being 7 degrees in most naturally aspirated engines between production to performance, right? Even a pro stock engine, they kind of favor maybe an 8 level. You get to a 7 to 8, it might not have much merit. You have CA50s of 16, 12, 14, things like that, and you push it into CA50 of 7 or 8, yeah, man, you're going to look like a hero. You have CA50s down in the 5s, like a cup engine can run down in the 5s. It may not be what I recommend for most people to do right off the bat, but we're going to talk about how you make those decisions moving forward when you don't know the answer. A lot of times, like Brian's car, we would not take Brian's car and say CA50 of 7 fits all. That's not how this works. CA50 and Pmax hold hands, and we're going to go through that in a minute. But most forced induction cars are never going to get to optimum ignition tune because the Pmax is too high, right? You're going to overpressure the engine, and that's where we're going to use this type of a tool to determine what are those thresholds. CA50 and Pmax. I keep saying we're going to do it. Here we are. So these are equally scaled graphs. I'm not sure how well they're showing up at a distance. I probably should have put a reference line across them. But let's just say this is your standard 23-degree small block Chevrolet 1955 design, has a distributor, a grid ignition, and a carburetor, makes under 500 horse. Okay? So this is straight timing. This is a CA50. And if I want a CA50 of our data point of 7, I have cylinders that are as high as 18 in CA50. That needs 11 degrees of timing in it right there at that fuchsia colored high point. Well, look at my cylinder 1. Like it's at like 5 at the same spot. It needs like 3 degrees, 2 degrees out of it. Well, there's a couple in the middle that are pretty good. How are you going to do that? How are you going to do that without a tool? How are you going to do that without information? How are you going to do that? So this RPM range is from 4,600 to 7,000, 6,900. That's right. You go get your tea leaves in your cup and you read the ground strap, right?
The end of the run.
Right. Yeah,
If it's
where did that
left,
happen?
if it's left, Tom.
If I have nothing to work with, I'm going to look at pistons. I'm going to look at engine durability, right? All of a sudden I'm taking pistons out of engines. I'm miking pistons and that skirt's collapsed. When did it happen? I can't tell you, but we better ease up on that cylinder, right? We're beating the bearings out of something. We better ease up on the cylinder. We knock the head gasket out of it. By then that shit's too late, right? It's like, it's done. It's over. Your weekend's ruined. Your time is ruined. So that CA50 target of 8, I would say that blue line has the most respectable flat curve out of all of them. It could use some fixing, but we can see what it does to the Pmax. This yellow cylinder is over time by a good bit. Well, look at the high Pmax in yellow. It's the highest. Look at the highest CA50 or the largest number CA50. It's the lowest in Pmax. Look at the one I said is average, being the blue. It's kind of right in the middle. Okay, so we have a distributor and a grid ignition. What can we do? Well, we can do work. We're a little handcuffed. I know Tom's lived this life before with bending reluctor wheels and such. But let's just say we group this thing decent. There you go. We group this thing decent. Is it perfect? Absolutely not perfect. It's good. It's better. Now look at our Pmax. It's coming together and it's mirroring exactly what we're seeing in CA50. This is spread apart, that's spread apart. This is grouped, that's grouped. So if I had an engine that I didn't know what the Pmax or what the CA50 needed to be, I would look around and say, which one of these Pmaxes makes the most sense that I should calibrate the rest of them to? And I would back into it like that, or set a max Pmax threshold, which I've done before with some turbo stuff. Say, okay, we are not going over 200 bar. We're not going to do it. So whatever it takes to put the spark at 200 bar, that's what it's going to be. So the CA50 might have been 12 or 13. It's not going to be 7. It's not going to be 6. So that's where this really is a great tool for backing into that. Now, you make a run on the dyno, you get this thing grouped up, and maybe I'm going to group it like 10. I'll push a global degree in it. How did it react? Oh, I picked up 10. Well, we're going to push another global degree in that. Did it pick up 5? Yes or no? The next time you did it, maybe it'd pick up 1 or 2. You're done, right? For me, I'll let the experts push that 1 horsepower stuff. So why is it impactful to use the data? Old adage, time is money. That's it, right? We're going to try to save some time. We're going to pick a development direction. We're not going to work on the stuff that doesn't need to be worked on or fixed. That's how you misguide the programs. We're going to minimize our waste. We're going to reduce our costs because we're not going to be running things over and over that don't make sense to run. So at the end of the day, the best thing about it is we're going to increase the durability of the engine by balancing the engine, keeping it out of knock, keeping it out of high pressure, and we're going to increase the power when we do it. And then we're going to be happy because we're working on the right stuff. So here's a run. So this is the engine program that Ben visited North Carolina to work on. That car went to the track. Here we are on the racetrack with the device. So now we're off the dyno where we've made a spark cal on the dyno. We know what our tolerance or our threshold of our Pmax or our CA50 needs to be. Now let's take this thing to the racetrack, right? Let's tune it at the track. Let's use the device in mobility. Again, we talk about light, compact, small, weatherproof. This thing can go to the racetrack. It can go out to the dirt track. It can go wherever it needs to go and be useful. The Plex can also do Spintron software analysis. So no longer is Spintron 2004 supported, This gives you modern, useful equipment for your Spintron. CAN bus integrations, you take your BigStuff 3 or your BigStuff ECU, and you bring your CAN high, CAN low. We start talking about our spark cals, and we start talking about fueling. Anything that the ECU will put on its CAN bus can come over to the Plex and be integrated, and we can do meshes and overlays of ignition, what the ignition system demands are versus how it's affecting the spark calibrations or the tune calibrations or anything like that. Other CAN bus integrations, like when we were doing Novel Engine, we built a dyno that was an AC dyno that had CAN bus outputs. We were sending dyno data into the Plex and Plex data back to the dyno. So our dyno had maybe Pmax or IMEP in its recording, and we'd have torque or power or some metric of the dyno. Again, building these layers of mesh in overlay in your testing. Emissions and calibration. Emissions are hot button topics all over the world. Don't care what the fuel is. If it's internal combustion, it's being scrutinized. Whether it's outdoor power, power sports, large industrial, no matter what, they're all being scrutinized. Emissions calibrations are all done with combustion analysis. The load versus the tune and how the output of hydrocarbon or NOx emissions are created, that is all done there. I've lived that life along with the scientific validation. Using combustion analysis, there's no OEM that cares that your dyno makes more power. My widget, my part, my production piece, my theory, my concept, it makes more power. They don't care. If you want to sell it, you need scientific validation. That's SAE white papers, things like that. That's the only way stuff gets sold. Other high-speed data, such as intake pressure and exhaust pressure. You start taking high-speed intake data or high-speed exhaust data, overlaying it crank resolved on top of your combustion. You start talking about intake manifold development, exhaust header development, those types of things, taking that high-speed data and putting it on top of crank resolved data that is has combustion data with it. That's how you build the story of building manifolds, exhaust systems, things like that. That's a lot less forced induction thinking, I would say. A lot more naturally. Absolutely. For sure. Yeah. I mean, Tom and his experience with the Cup World, I think he could probably stand up here and speak to this much better than I can at times. But this is good because that's, this is just becoming like back when this happened, right? When you had an O2 sensor, like as the aftermarket. I mean, I've heard stories of those things costing $10,000 for an O2, and that's unachievable for most people to have an O2 or Harid. Yeah. So now this is affordable for everybody, and we're doing the same thing here. We're bringing affordability and making it usable to a common user. So it's been around. This isn't new. It's just becoming commonplace, where it used to be just for the OEM, just for F1, just for Cup. Now we're drag racing it. Now we're right. It's becoming more affordable to more people. We have customers in Novel Engine, military, drag racing, development style stuff. So it's a broad spectrum.
That's the way you sell more.
That's right. That's right. And I think we have done a good job of controlling that. It'll never be the cost point of mass volume ECU production, but a lot of what we're doing today is really driven by the cost of the sensor, right? The sensor itself costs so much, but we've already reduced that cost by a bunch. And I think we can, for certain, like that application right there, I'm going to show you a new sensor that we just did, and that'll probably be the end of our time doing this. But we see it as a large scale problem because when I come up to someone and say, "Yup, the only sensor option I have for you is $32,000 for a set of 8." Well, it's not so obnoxious if you're doing single cylinder development or 2-cylinder development. But when you get out to 8, it gets. But now our new sensor is about $8,000 less. It's $1,000 less a hole. So it's all directionally correct. Will it ever be, the cost of a fuel injector? Absolutely not. But bringing that cost down and getting more people engaged or finding more applications for different sensors, I would really like to be able to sell a sensor at $2,400. And I think we're there with certain things for certain applications. There are places for that, but it's not in Brian LaFlemme's car, right? And it's not in a Pro Stock car. Those two sensors are completely different. But if we can have 3 choices of sensors for low RPM, modest pressure development as a low, like the low entry point, the sensor like what would go in LaFlemme's, and then, your Pro Stock naturally aspirated cup, that type of high resolution development, that comes at a high cost, right? Here's just more about the Spintron module. That question comes up. I think 1 cylinder at a time leads the whole project astray, because the feeling that a single cylinder is going to react like the rest of them, or if you make balance or try to move it around the engine, by the time you move it around, right, the pulsing on the engine, the way it pulls, the way it reacts, the way it distributes. The good news about plug in the hole is we sell it's a commercially available plug. You just thread it in. You haven't ruined a set of heads. We ran,
Lots of times you wouldn't run the sensor. You would have to track, but you wouldn't run the sensor, you put a plug in.
put the plug in it, right? So they're about $80 a plug, just rough cost, and they torque just like a factory or just like the sensor. But
Show up for a second. These Kisslers, or are they ABLs?
what I distribute is a Kistler.
Have you ever used the instrumented plugs?
I am aware of them. We prefer not to. They are available. The plug is available. Here's the problem with the plug. It's expensive. It makes a bad spark plug and a bad transducer, right? So you end up with a $5,500 spark plug that if the spark plug goes dead, now you're done, right? And you have to send it. Some of them can be repaired or modified. Some of them cannot be, but now you're asking the manufacturer to now take this 3mm sensor and put it into a spark plug. Certain applications, I don't know which one it is, but I know that there's a certain Ford spark plug that they can't even make one like that for. So you're trying to avoid.
That we would run that engine though.
So you're trying to avoid I wouldn't call drilling and tapping for cylinder pressure sensors an easy job, but you're trying to avoid it. You're trying to avoid something saving money that's going to cost you more money in the end, right? You got to just do the work up front, say I'm committed, and go in and do this. Back to the Spintron side, this is like having your cam doctor. Deviation, jerk, acceleration curves all show up here. Save data, log data, add a speed. It's like having your cam doctor on the engine running. Great entry level to start working with Plex software. And we can add the combustion features to the Spintron, or we can add Spintron to combustion. It's a module that comes over line, and it's just a purchase license. The hardware and firmware is the same. So this box does either or both. So when the license check is initiated, you will see that it has Spintron or it has combustion, or how many channels. We can do 4, 8, and 16 combustion channels in this, or 16 high-speed channels. They don't all have to be combustion. For a guy who wants to run 8 combustion channels with 8 intake pressure sensors or something, some other high-speed data collection, that's how it happens. Last slide. I think we've already kind of touched on it, but here's some product photos. Again, I've held up pictures of the wiring harness, the amplifier, some sensors. This is the new sensor in the upper right-hand corner here. It is Kistler product. Yep, I do distribute, and they do develop product for me, which is a pretty bold statement that they're developing product for some guy out of North Carolina that is trying to impact motorsports and combustion in mobility. They also offer their own system. I don't promote that system because it's cost prohibitive, and it's a fine system, but it's cost prohibitive to most customers, as well as space constrained, right? It's like a sheet metal box, and it really doesn't belong in a race car. And if you have a $50,000 box in your race car and something happens to your race car, in the AVL case, it $90,000 worth of these sheet metal boxes. If we have to replace this module because something terrible happened in your race car, you've already had a bad day. Why lose 90 grand or 50 grand on top of it? Let's take the percentage. It's risk mitigation, right? Let's say this black box, your license and your software are still active, but this box, maybe it's 5 grand of the cost of the entire purchase. We put a box in it. You might lose the wiring harness. We get you another one. It would be a bad day even talking about something like that, but it's a whole lot better than 90 grand.
The other stuff,
Research laboratory grade, right? So, I don't want to take too much of your guys' time because you're here to learn about tuning your big stuff. And, I do appreciate this, but I'm going to stick around the rest of the day. And if there's anyone who has interest, questions, wants to cover some tech topics, see some product, I'm more than happy to share. So, but I'll thank you to Ben and Brian. I'm going to tie it up so that you guys can get back to your tuning and calibration, but I hope this was insightful of what it takes to grab the next level of data.
Yeah, I just like the size of that thing. I mean, it's so small. It's ridiculous, you know, as far as what it was. Because I'd seen what it was before. I mean, that's it. It's so light too, you know, it's really cool. So, and what I like about it too is with the CAN integration to our stuff, we'll be able to actually take real-time knock and say, hey, we're actually knocking for real, you know, do something with it, right? This ain't a knock sensor that's going to false trigger a million times, right? This is real stuff. So yeah, there's a lot of capability for that stuff. And it's so unique too. That's why I asked him to come down. So a little bit. But yeah.
So
Thanks.
thank you guys for your time. Appreciate that.
Thanks, Dan.
golf clap.
There you go. There you go.
Thank you. Thank you.
All right. So we got to get back on this now. Make sure we're on the right screen. Yeah, we can see it now. All right. So, okay. So thanks again for that though, Dan. That was awesome. I mean, that's why I asked him to talk about that, because it literally is the voodoo magic. And when I saw it, his system working for real, I was like, when I walk in Dyno Cell, well, that thing, I'm like, that's it? Really? You know? So, yeah, it was really cool. And again, just seeing the stuff on the rev limiter and seeing the pressures was just really cool. You don't get to talk about that stuff too much, you know? So thanks again, Dan. That was awesome.
Thank you for the opportunity.
Yeah, no, it was cool. Okay, so so basically what we're gonna move on to now is we're gonna try to cover as best time as we can, because I know these days always go by fast, but I really wanted to get him in here too. Basically, the rest of the stuff that we got going on here now is we've touched on fuel, we've touched on the AFR tables, we've touched on Spark, okay? Everything else now down below is going to be based on what you're trying to accomplish power management wise, okay? The next section that we've got going on over here, okay, is ICFS, okay? So ICFS is individual cylinder fuel and spark, all right? Just to come right off of what Dan was talking about there. So basically inside this section here, okay, you've got Gear 1 ICF and ICS, okay? ICF, anybody take a chance what that stands for by any chance? Individual cylinder fuel? Yeah. So we got individual cylinder fuel, we got individual cylinder spark, okay? So basically in each gear, quote unquote, you can adjust all your individual cylinder fuels and spark. Now, if we were to go back to the fun stuff and do a gear over RPM here, okay? Now all of a sudden I've got all those individuals per gear as well. Right, Chip, see that? So as we switch into our different gears, we got our different tables. Well, now you can have different fuel and spark per gear as well, right? So if you know you're nursing a hole that's making more power, or one that's, you know, doesn't make as much, you're doing whatever, as each gear change happens, you can have it follow that with the individual fuel and spark per gear. Okay, that makes sense? And then, yeah. So let me show you a quick little, so back to the tuning and dyno views here. If you actually come over here at the very bottom here, we've actually grouped them together for you, okay? So here's gear 1, okay, 1357. So you can see here that, again, if you see that little symbol lower left-hand corner, what can you do? Scale it to whatever you want, right? So in this example up here for cylinder number 5, basically from 1,000 to 6,000 RPM, we're adding 2 degrees of timing from this engine RPM and that load. Cylinder 5, right? Same thing for cylinder 7. So I can come in here and go to 2468. It's all grouped together. It makes it really fast versus coming over here and choosing each one, okay? So we just default to these tables here, okay? So we only have the gear 1s per se. So there for cylinder 6 and cylinder 8, we're actually pulling out 1 degree, okay? But you can do this to your heart's content. Again, when we were doing it with Dan, and they were making changes, basically like he was telling about, and I saw for the first time, I said, are you kidding me right now? They were adding 4 down low. Then the next 100 RPM, they were taking 2. Then they were adding 6, then taking away 3 of them all. What the hell's going on right now? But man, it worked, you know? What do you mean? Zoom? Yeah, should be. Oh yeah, no, I just minimized them. I minimized them. Yeah, we're still good. We're still good. Yeah, exactly. So, but anyways, that's where you'll take and you'll apply individual cylinder, fuel, and spark here. And that's why with his data, we were able to, well, I didn't do anything with the spark. They were going through and just making these huge ramps. And I just said, this same thing, like he said, it'll never work. And all of a sudden, pow, gained all that horsepower. I was like, well, okay, I see it now. That's really why if I was out here, if you wanted to come down, because it was just really impressive to see that data that they were able to see and then go and just do that. It was remarkable, really. So, and again, it's like Tom was saying, when you get down that sportsman level, that'll be really cool. But at some point, it's like anything else, it'll slowly start coming down eventually. So, but anyways, individual cylinder, fuel, and spark, it's all the same. It's a raw number, okay? So what I mean by that here is the fuels are percentages, okay? So you're always going to have a percentage, either add or subtract, okay? And the spark is obviously a whole number, okay? That's going to be, I'm taking away 1 degree, right? Fuel is percentage, spark is whatever that number is going to be. You'll look in a log, you'll see each individual cylinder will show the total amount of timing in it based on these tables, okay? So if you have individual cylinder spark going on, you're going to see your numbers all different for all 8 of your cylinders, okay? And the log, all right? Okay. So now we're going to talk about SR2. SR2 is the traction control section. And I kind of, it's tough to say traction control because really this is a plot that you create that either you can follow with drive shaft or engine RPM, okay? And this also allows you to do first gear gear curves, okay? And I don't call this a retard curve because on these gear curves, this can be a positive or a negative number, all right? So just for example, I'm just hypothetically just saying here, okay, for some reason, if I actually wanted to leave here and actually add 5 degrees on the launch, okay? You see here, I got 5 degrees going. And then if for some reason I didn't want to have anything out at all, I wanted no retard. And then for some reason, if I wanted that to be, -10, the whole point here is, let me scale this correctly. The whole point is that you're able to make this a positive or a negative number, right? And you're able to get away with that because in first gear, you've got a lot of mechanical advantage, right? So obviously, correct. So you're probably not going to hurt anything if you're shoving a bunch of spark advance in it, right? So I don't like calling this a retard curve. It's not a retard curve. It can be anything that you want to do, okay? And this is based over time. So if you look down here on the bottom, this is configured from 0 to 10 seconds. But again, it can be anything that you want, all right? So you've got up to 9 different curves you can plot, okay? So if you're one of those guys where you simply want to just work on one the whole time and not have anything else, I can highlight all those and just make it 0, right? And then just play with only this one here, okay? Does that make sense? And what'll happen is, as you highlight those dots, see how those dots turn red? Whichever one you're highlighting, the dot will turn red, okay, to indicate which actual curve you're on, right? So this works whether you're coil on plug or your distributor based. As long as we're controlling the engine timing, you can use this guy, okay? So if that option's activated, to your heart's content, you can have this. And this only works on the start of the race timer. So again, the 3-step in our world is how that works, right? You drop the 3-step, boom, it starts. Now you can plot this, okay? Any questions on this at all? No? Very simple? Yeah. It's a good table. Obviously, if you're in the racing world, you're going to do these curves all the time, okay? So to activate the SR2, you've got a couple of different parameters. You're going to have a minimum RPM, minimum TPS, okay? Now, again, it only activates these tables when the 3-step is dropped. So you just flooring your car, you just doing and monkeying around, okay? It's never going to start these until it actually sees that 3-step go off. So you've activated it, you're sitting on it, you release, you're above these 2 parameters. Now, whatever you've got programmed in here, it's going to go, okay? Make sense? All right, so we'll talk about this roll race. We're going to come back to that stuff. So now, all this stuff here, okay, it's, again, all this stuff is grouped together, but we're all talking about the same thing. So I got my gear curves here, up to 9 curves in that section. If I come over here now to this menu, this is going to be, if I'm on number 1, okay, there's my table right there. And again, if I auto scale this stuff, you can make these tables look a little bit better here. This is just default stuff, okay? So if I'm on number 1, there's that curve I plotted, okay? Then it'll also show me down here what my actual dry shaft curves are, or engine plots, okay? Because remember, number 1 works together with the gear curve and the ETM SR2 plot you've also created, okay? That's what you choose number 1, it's all grouped together. So in this case here, if I plotted a dry shaft, I'm just gonna make some random numbers here. So here's 5,000 for my max dry shaft or engine RPM, whatever you wanna do. So I'm gonna come over here, it's the old interpolate button. Again, it's all the same stuff here. See that guy right there? Get interpolate right there. Okay, so now I'm gonna make, what I typically do is, you can do it either way. I typically have the ignition cut above the timing. It's better, it'll be faster if you can have the timing react first versus slowing the car down with ignition cut, okay? So it's all Windows-based stuff. I'm just gonna hit Control-C for copy, okay? I highlighted, oops, I just wanna have the middle row, sorry. Oh, I did, that was just gray. Okay, so I'm gonna copy this, Control-C. I'm gonna go to the ETM line, which is my ignition cut. I'm gonna Control-V. So now I've got the exact 2 same things for both those lines. You guys see that right there? I just copied and pasted, right? So now I'm gonna just add, again, just so you can see it, I just added 300 RPM over that curve. So now timing's gonna try to go first. If that's not enough, then my ignition cut's gonna go. Okay, that's how that works. And this can be either engine RPM or this can be dry shaft, which one you want it to do, you want it to work. So completely up to how you want to scale that guy. This time is also scalable as well. I've got up to 10. You got a 5-second or 4-second 1/8 mile car or something. You have to set that to 5 and then tighten up that resolution, obviously, right? Okay. So it totally depends on however you want to do it. But if I choose number 1, I'm choosing all this. I'm choosing the number 1 gear curve, and I'm choosing whatever I have programmed in for the SR2 and ETM. Okay. So SR2 is timing, ETM is ignition cut. Okay. Yeah, Brian? Yes. Yes, of course. Yeah, this isn't just something you're showing. You can come in here, and if I wanted to make this, 20, you can come here and do whatever you want to do. Exactly. Exactly. Yeah. So if I left this window open, and I came over here and also opened up the gear curves, okay, there it is right there also. All this SR2 gear 1 dry sheet ETM curve 1 this is just grouping stuff together. So again, if I came back here and hit the back button on this guy here, okay, now it goes back and this one goes back too. So it's adjusting all those tables together. We just group them together to make them, okay, I'm on number 1, so there's my gear curve and here's my plot for my engine or dry shaft, okay? So it's handy because if you want to look at everything you got programmed for one, you can look at this window. If I came over here, okay, there's number 2, right? So if I choose number 2, now I'm on the gear curve 2, and I'm on the drive shaft ETM curve 2, same for 3. Now, obviously I've got up to 9 different gear 1 curves, right? So how that works is curves, if you choose SR2 gear curve 4 through 9, you're always going to be on the number 3 for your dry shaft or ETM curve. Okay, that's how that works, because we don't have 9 engine plots or dry shaft plots. You only got 3. So if you start going up above 3, you're going to use whatever you got programmed for number 3 as your dry shaft engine plot. Okay, that's how that works. And you can see here, what we've grouped together on this table is the SR2 gear curve. This is your timing curves, right? And you only got 3 to play with, right? Whereas the gear 1 curves, I got 9. Okay, does that make sense? So again, if you really if you wanted to quickly just blow through here and just say you wanted to add, create some curves, if I just did Control C for that very first curve, and I went to my curve number 2, copied and pasted. If I went to curve number 3, copy and pasted. Now they're all the same exact thing. If I went to number 2, I'm just do this for exaggeration. I added 500 there, and I went to curve number 3. Oops. Yeah. 500. Okay. So now, obviously, you can see I just built 3 curves, right? So I'm not really basing this off of anything right now. I'm not basing this off of any data. I'm just showing, for example, how that's built. Okay. So again, you can come over here at these 3 dots, auto scale this stuff here, bring it in tighter. Get this max out there a little more because we're going out to 10. Something like that. But again, you see how these plots are all move around. You can control, copy, paste, move. The Gen 3 is definitely not as fast as doing stuff with this right here. It's extremely fast, okay? So now that you've got these built, okay, well, how much am I going to pull? How much am I going to add or pull based off that, okay? So that's what this error table is, okay? Again, what do I got down here? I got my little configure this table for whatever I want it to be, right? So how this works is if I'm at 0, I am right on my target for my curve, whether it's an engine plot or a dry shaft plot. Okay, I will just ride this line the whole way. But if I start going over my line by 100 RPM, I'm going to start pulling 10 degrees. Okay, does that make sense? If I'm over 400 degrees, I'm pulling 11. If I'm over 1200 RPM, I'm pulling 15. So these are default numbers in a lot of cases. I don't like having, because obviously if you're 1000 RPM over, your run's probably over, right? So if we do the little rebin here, if I come in over here and I make this negative 300 and I interpolate like that, then if I come up over here 300, interpolate like that, apply it, unchange. Now I've got a much tighter resolution, right? So now if I'm 43 RPM over, I'm going to start pulling 10. Now that's actually pretty aggressive for only being 43 RPM over, right? Because we changed the resolution. So that may only want to be maybe, -3. And then if I came over here, remember that interpolate horizontal box right here? So now I'm going to start with that 15 to -3. I'm going to interpolate vertically, and now I just made a nice curve going down, right? So now if I'm 86 RPM over, I'm pulling 5 out. If I'm 171 over, I'm pulling 9 out. Does that make sense? Okay. Yes.
I didn't see your keystrokes for the negative numbers. Did you have to type in negative?
Yes.
Or is it assumed because you're below the 0 and negative territory that it's a whole number integer?
No. So the way it's written is, for whatever reason, if I'm 43 over, or if I'm actually going over the curve, it's actually set up as a negative value. I don't know why. There's a reason why, but if I'm over, I'm in this negative zone.
No, I understand, but when I go to put the value in there, that 3?
Yes. Yes. Yes, you have to. You got to put a -3. And here's why, okay? So if I'm under my curve, I can also shove in timing. Yeah, so that's what you want to do. Okay, so if I'm under the plot, all right, and I want it to allow to be able to push it in, that's what this is for. So if I'm 75 RPM under my curve, let's just say in first gear, or, you know, for the first second, I want to allow it to be able to shove in 5. Okay, and then after the first second, after the next second, I want it to be able to shove in, you know, 2, something like that, right? So now, if I made this all 2, so you can shove it in if the wheel speed is not high enough, right? Sorry. No, it's whatever it's riding through. So if I'm under my curve by more than 75 RPM, I'm going to let it basically add in 5. Okay. In the first second of this. Then after a second, I'm going to let it add in 2. Then after that, I'm going to let it do it anything.
Entertainment, go to -43 where the -3 is. Yeah, right there.
Mm-hmm.
Just pick out one cell.
Okay.
Just type in 3. No, -3. Just
Sure.
Okay. Now what happened?
It'll add in timing.
Yeah, but red too.
Yeah, it doesn't want it because that's a high number. It should be a negative number. Yes. Yes. Exactly. But it will add in if you don't put that as a negative. So yeah, you gotta make that a negative value. So
First second, you've got it adding 5, let's say.
yep.
If it goes past the first second, does it automatically stop adding the 5?
Yes. Yeah. Because
Still below it, only add 2.
yes. Yep.
It's not stacked.
Now, here's how this works, right? So you got a base spark map. More than likely, if you're doing something like this, you probably have a first gear curve of some sort. So you probably are pulling time or you're doing something in that curve anyways. So what's nice about this is if that gear curve is off, this will actually show you what you need to do. All right, because if you're pulling 5, but it wants to add 5 to get back to your curve and you're going, well, why am I pulling 5 out then? Right? So it gets you there faster. I'm not saying add 5 degrees going out in high gear, because obviously that's not good. But you can more likely get away with it when you got some gear to help you, right? That's what you want to do. So, you know, again, you gotta be careful though, because not in all instances are, you know, oh wow, it's trying to add 5. I can add 5 all the time. That's not the case. That track condition, that day, wherever you're racing at, I'm probably a little far off. You know what I'm saying? So it can probably take it. The track's really good, front end staying down, all type of stuff. So you can use this to your advantage to actually show you that. Yeah, we don't want those. We don't want that CAD to go away. All right, exactly. So, and if you don't want to have this, abrupt change, I can say, okay, well, maybe between 1 and 1.3, right? What do I want to do? Interpolate horizontal. So I can do that, right? And now I get a nice little gradual change. I don't just drop off the shelf, right? So you can have a smoother ramp down. And maybe same thing from the 2, maybe for 2 on out to 2.5 seconds or so, I'm going to let it ramp down that way also, right? So instead of just dropping off the cliff and it's got the power that's in it, it slowly brings it down, okay? So this works on engine RPM or dry shaft, whichever one you want to plot. That's what this curve does. You can, again, have the top adder all be zeros as well. So even if it goes up in this section, it's not going to do anything. But you'll know, oh, wow, I was that far underneath my plot. It wanted more power there. And it could obviously, it may have stuck it may not have, right? But you just know that you're that far underneath your plot, and you can see that in the log. Okay. Next one is going to be this ETM dry shaft error table. Okay. Now, this is the one where it'll bring your engine to its knees. And you got to be careful, okay? Because remember, this is the 31-0, right? So we don't want to take all the freaking torque out of the engine. We do want to limit it though, based on if we start going over that curve we've populated. Because if we missed and we're just too far over the curve, we want to start cutting cylinders out. So this says if I'm 300 over, I'm basically taking out about 10% of power, right? Because 31's full power, 10% of 31 is about 3. A little over 3. I'm about a little more than 10% out. So typically what I do is something around a 17 or so is all I limit it to. That's basically getting you almost about 4 cylinders. If you can't slow down with 4 cylinders, then obviously your tune-up's way off. Come over here, highlight all that guy. Now, instead of horizontal, I'm going to interpolate vertical, right? Okay, so now if I'm 100 over, I'm at 26. If I'm at 200 over, I'm at 22. If you're at 300 over, you're probably got a botch run. So don't go to 0. Your engine will literally stop running. I've seen guys do it before. Engine RPMs can come back and pow, all this fuel lights off, and it's a big old fireworks show. Shouldn't hurt anything, but obviously you don't want to just have your motor actually make no spark at, 7,000, 8,000 RPM, right? But it will do it. It will do it. So, but yeah, this is what this curve is. So again, this is more, again, this only pulls power. You can't add any more than full power, right? Because 31 is full power. So you can't do anything really like this table like you can with your timing, where you can put more in. If you got all power or you don't, it's going to start taking it out. Okay? Does that make sense? Right? All right. And then basically for those curves, that's it. When we get in the logger section, we'll go over how to use that data itself. Okay? All right, any question on that section, all the traction control, the curves, any question about that at all? Makes sense? Okay. SR2. Yeah, actually there is, no, it's something retard. I forget what the S stands for. I forget what that thing is. Yeah. I forget what it was. There is a doc that shows exactly what that means. I forget though right now, but it is SR2. No, not SR2. It's something retard. I forget. Okay, so boost CO2. This is basically for boosted turbo guys that are running turbochargers. Basically, if you have this right now, it's disabled. If I have this enabled, see how the boost GN just went away. Okay, the boost GN in our world, that's the street boost controller. Okay, if I enable this, it gets rid of the boost GN. Now I'm just running on the boost CO2 boost controller. Okay. Just high level overview real quick. You got to be above a certain TPS percentage in order for this thing to work. If you don't, we're not going to output anything, okay? That's totally adjustable. If you're race car based, you're going to go off of time, okay? So my desired wastegate pressure, I'm going to say is X amount of CO2 pressure over time. Been around forever, works fine, okay? You can have based on mile an hour, RPM, or gear if you want as well, okay? The boost kick, that's your scramble. So if you press the scramble button, how much CO2 am I going to apply? Okay, makes sense. Split brake here, if you press the 2-step, this will also apply X amount of CO2 if you actually activate your 2-step as well. Okay, you shouldn't have to mess with this at all. Our factory numbers are pretty good. This is how it controls your solenoid valves to control the CO2. You should pretty much just leave those numbers alone. All right. This is what you guys obviously have in Chris's car, right? For this guy here. Okay, does it work pretty good for you guys? Yeah, just holds the number like it's supposed to, right? Exactly. Okay. I mean, it's just simple, but you want to keep it that way. You know what I'm saying? You shouldn't have any issues with it at all, right? All right. So if I come into my time curve here, instead of for 10 seconds, so again, I'm just going to play with a plot here. If I want to target 10 pounds of CO2 on the hit, and then if I want to target 50 pounds all the way out, you can interpolate that. And then there's a curve right there, right? So any which way you can do this, you guys can do it any which way you want. Again, most turbo cars, if they can take it, will just go to a certain number. You're hammering it as fast as possible, run it like a blower car. Just get in as fast as possible, right? So, but these are where you plot your 3 curves from. Again, if the touchscreen dash is plugged in, okay, this does not matter. If I come over here, I'm in laptop and I come over to boost, boost modifier. See that number? This number don't matter, okay? Because the dash is in charge, so you can't forget that, okay? Dash is in charge of your SR2, and it's also in charge of this. Can't forget that. No, that's just for the engine, that's just for the rev limiters. Rev limiters are the only thing you could say, I'm not listening to the dash on. The dash is connected, it does everything else, okay? So traction control curves, boost controller curves, it comes in through there, okay? So you could have a discrepancy. That could say 2, but on the dash it says 3. It's doing 3. Okay, just don't forget that. That's how that works. This is a boost rev limit RPM offset. So if you guys ever watch the car's drag strip and they go, ah, and they come back down and slam down, that's what this table is right here, right? So helps to build up a lot of boost, obviously. And basically, you'll get another table here that pops up. Okay, and this basically says, okay, if I'm not making the boost that I need, I can add it in. So how this works here is if I want to get to 10 pounds of boost, okay, I'm going to say 10 pounds of boost, I don't want to have any offset. Okay, that's what this 0 means. But if I got 0 pounds of boost, I want to give it 1,000 RPM. So again, that's why the cars will overshoot. So if I got no boost and if my set point is 4,000 for the 3-step, I can go to 5,000 RPM if the converter will let me get there, right? Then as I start making the boost, it starts coming in, I start ramping it down. Then when I get to 10, I should have no offset at all. Very simple. It works really good. All based on the converter, whatever you're running, if it'll let you go above that though, right? Just no magically going up. So works really well. And then there's more generic stuff. Again, you can do any, apply anything you want based off TPS, race timer, all those custom tables you can add in for these two curves right here are on the CO2 output itself. You can play with all that. Okay, so I'm gonna turn that back off. All right, starting line section here. For guys like Brian or guys that are making a lot of power in the starting line, you can have this table come in. Okay, it's going to be based on TPS and thresholds. So 25%, 2% and 2000 RPM, for example. Okay, and the 3-step has to go true. Then all these fun tables come out. All right. It doesn't matter whether you're making really 1,000 or 6,000. This stuff can actually come in pretty useful. So again, here's the fuel table. This is a percentage. Okay. This is a percentage, and you can scale this thing any which way you want. So if you're on the starting line, if you're at 4,000, you probably want to make this table from 2,500 to 5,000, right? Come in here, right click, interpolate, boom. So now I've got something usable where I'm going to be at, right? And the fuel is a percentage adder. So if you want to take fuel away, you want to add in fuel, whatever you want to do, that's what this table's for, okay? Same thing for the spark. This is a whole number though. This is a raw number. So whatever you're targeting in here is what you're going to get. Okay. So when that starting line section goes true and you're on the 3-step and you're banging away, ECU is going to force out this table, however you have it programmed. All right. And again, you can scale it. It's scaled based on how I just set it for the fuel. They all update and change together because you're in the starting line section. All right. So this is a raw number for whatever you're supposed to go in or for whatever you're actually targeting. Air fuel ratio, again, another whole number or lambda, whatever. It'll be called lambda, but it's air fuel ratio here. Again, not as much resolution, but you can set whatever AFR target you want on the 3-step. Okay. Whole starting line section completely at your disposal. And then back in the day, they were putting out holes on the 3-step, right? Because of all the alcohol-based stuff. So now you can go in there and in each cylinder, you can trim out certain cylinders. So they got EGT sensor, you see a couple cylinders just dropping down too far for whatever reason, go in there and just pull that fuel out and they won't drop out anymore. Okay, that's what that's for. But again, you can add it in, you can take it away. It's totally up to you. Okay, so all 8 cylinders will be in your disposal at that point. All right. Does that make sense? That makes all sense. So again, starting line section only on the 3-step, not 2-step, not half-step, it's only on the 3-step itself is when it goes true. Okay. We won't get into transmission stuff. That's 4L60, 4L80 stuff. Okay. Don't worry about that. That's if you want to run that transmission. Okay. So SD card browser. Okay. This is where all your logs are. Gen 3 days, you had to run back real quick, pull the log out. Okay. We don't do that anymore. Thank God. So now there's an onboard SD card and everything gets written to that so that when you come back, it just gets burned right to here. You never got to pull the card out, okay? Because all the files stay here, okay? It's designed so that if you turn off the ignition while the logger's running, it's going to keep alive and stay on. Oh, remember that, Tom? Remember that one? So if it's making a log, and you hit the ignition, you turn it off, don't worry, ignition's staying on, the ECU is still recording. Once a log is done, because obviously if you set the log over 20 seconds, your pass is over. It's going to finish the log and then it's going to shut down. Okay. So I was busting Tom's chops because there was a fuse that was blowing at one time and it wasn't finishing. Right, Tom? So we got that all fixed. But it does work though pretty good, right? When you got that fuse in there, you know? Yeah. So, so this box, I left this on here too. I just updated this box and this file right here, this Gen4 BSF, you were asked about acronyms. A BSF in our world is a firmware update file. Okay. So BigStuff firmware. Okay. I updated the box. It's left on here. In the old days, you had to actually pull this freaking card back out, put it in the laptop and delete the file off the card. Now it's on the interface here. You can just simply highlight it and just choose X and then it goes away. Okay. So it saves an extra step from the old days of having to pull it back out and erase it. It's all right there on the front. Okay. So these files will stay on here forever unless you erase them. Okay. So it's advisable at the race every weekend or whenever you're going to start racing to delete everything and start over from scratch. Okay. And what you want to remember here is I'm going to erase this file. I'm going to hit X. It's going to say, you sure you want to delete it? I'm going to say yes. Okay. It's gone. Yes, exactly. So what you want to remember here, okay, you see that little file at the very top, it's the high, see how it says big DQ and it has a number and it goes up in orientation, right? As far as the values go. That very last file says 11.23 KB. That's a factory file. Basically, the Gen4 is asking the SD card, are you okay? SD card says, yep, I'm good. So you'll always see that file there at the very top. You'll always see it because if we don't have that there, then we know something's wrong with the card. Okay, that's why we have that there. What's that? This guy right here. It's this guy. Yeah, yeah, this guy right here. So it'll always be the very last file will be that size. Okay, we'll never get rid of it. Don't get confused by it. But yes, but it will come back. It's supposed to come back. Yes, it's supposed to come back because that's the ECU saying SD card, you good? SD card says, yep. So we have that there to let us know that the card's okay. Okay. The next file is your latest file. Okay. So we don't have a date timestamp on it, but when you download it into the laptop, you're obviously going to get a date timestamp of when it's created and saved. So that's why I recommend erasing everything before you start, because it's very easy to keep track of the runs, because obviously as you make a new run, it's the highest numeric value. Okay, does that make sense? Correct. It's always the highest number besides the 11.23 kilobyte file, because that's always going to be there saying the card's good. Okay, what's that? And it's always a megabyte file. So in this example, it's 4.917 megabytes. And the reason why it's 4.917 megabytes is because if I come over here, this log is 20 seconds long. Okay, if the log is longer, if I set it for 30 seconds, that's probably going to be about 8 megabytes. If I set it for 5 minutes, it's probably going to be about, 100 megabytes. But it'll log for as long as you want. Okay, I've done some offshore boat stuff, and basically we'll just go when he hammers it, we'll just start the log and we'll let it go for 5 minutes. And every time he hammers it, it just starts over 5 minutes again. And we just start recording. Okay, so no, every time we can set it, the logger can be set to configure any which way you want. So you can just say, okay, every time it goes by 50%, start a log. It'll just keep logging. It's done. Next time it sees 50%, it just starts log over again. It'll just keep going infinitely. Doesn't matter. Yes. Correct. Exactly. Exactly. Yeah. As long as the fuse isn't blown. So what Tom's talking about, I got to talk about Tom real quick. There's a 3 amp fuse on the main engine harness, and it actually provides power in case the ECU needs it for anything after you turn off the ignition switch. So they didn't know it, but their 3 amp fuse was blown. Right. Right. It ain't blowing now, but they kept having their logger bomb out. They would not get their logs. And long story short was the ECU, they would turn off the ignition. Well, because that 3 amp fuse was blown, it couldn't stay alive to finish the recording. Yeah. But again, there's just to clear up any confusion, if you see logs in here, okay, because remember, you go to the racetrack the next time, you could see logs in here, right? You're not necessarily going to know where they're from because they're just going to go from oldest to newest and they're listed, okay? So that's why I recommend if after you're done making your log, downloading it, we'll do that here in a second. And then that way it'll actually establish a time date stamp on the actual computer. And then you know exactly what it is. You can also put some notes attached to it and all other kind of stuff also, okay? But this is an 8 gigabyte card, or yeah, it's 8 gigs. So in testing, I have absolutely filled it up, and I filled it up so much, it just keeps overriding. So unless you got 8 gigs of data on here, it should not bomb out on you at all, okay? So you have plenty to work with. So when you got a file here, all you simply do is if it's not shown, you can just hit this little refresh key here, okay? And then it pulls up the, it'll just show you exactly again what's there, okay? And look what's back, right? Because it wants to let you know that the actual log is okay. So I'm going to come up here, my latest one that's actually a log, just going to hit the green arrow. Now it's going to download. So that's pretty fast for 5 megabytes. That's 20 seconds worth of data. Okay, I'm just going to put test _1. Yep, it's going to go okay. Files review, and you want to view it now, okay? You can hit the Y key, or I can just go yes, okay? So this is obviously just me messing around, but there's the log, okay? And it'll open right up, okay? So what you can do is over here, you have a view edit time slip. And this is where if you want to actually put notes in with this guy, Chip was asking about that, you can put all the information that you want in there, okay? So, DA, tire pressure, whatever notes you want to throw in there, it'll be attached to this log, okay? So just the gear icon over here in the logger section, the gear icon is where all your options are for this log, for the actual section. And just come over here to view edit time slip. Okay. And that's where you plug in all that information there. Okay. Yeah, so you just throw it all in there and then it stays with that log. Okay. And then what I was talking about before is if I come over here to File Explorer and Documents, Projects, if I come over here to the UC I'm working with, so data logs here, this is the folder that I'm working in, right? When I download it here, it's going to attach that time and date stamp. So that'll give you something to go off of as far as when it was actually downloaded. If you just want to make some notes, if you want to change that to run 1, track name, what I'm saying, you can make it whatever you want. Okay, but that's how you can keep track of it when you download. So I recommend after you do it to download as soon as possible. That way you actually can put a date timestamp on it. But again, in the notes, you can also put it in there as well, date, time, all that kind of stuff here also. Okay, so just a good way to keep track of everything. Now, if you wanted to do a mass download before you race everything, that's what Brian was talking about before, is I can choose all those. I just highlighted them all, left clicked and just dragged, right? If I hit this down arrow right now, okay, it'll just do them all at once. So if you get to the track, you know what? I didn't download everything last time. I just want to back this data up before I delete everything. You can.
Race, track, dates.
Exactly. 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 So it'll download it all right there. Okay. So obviously we're hardwired to this car, but if we were wireless with our router setup, it'd be the same speed. It's actually a little bit quicker sometimes when you're wireless. Okay. So it actually establishes a new name. Again, you can put whatever name you want. I'm going to go, okay, I don't want to open all these up right now. I'm going to go no. And then if I come back to this folder here, there they are. Okay. So now I just downloaded all those files. Okay. So now I don't feel so bad if I come in here and actually say, you know what, I'm gonna dump all these, because now I've got them all backed up, starting your race day, I'm ready to rock and roll, right? So I'm gonna come over here, just hit the X, highlight them all. It says, are you sure you want to race all these? I'm gonna go, yep. And don't worry about that little error. Hit okay, and there's my little checking guy right there. That's Windows doing something right there, freaking Windows. So anyways, card's empty now. So now you're ready to go again, okay? So the card will only have one file. Again, no sweat. You'll never be able to open this up. We get questions on that all the time. It's nothing for to interact with. Okay. If it's 11.23 kilobytes, it is just a check-in file, just the card saying it's good. Okay. So the other important part to this section here, obviously, is how am I going to even trigger this guy? Right. This is the other part that you obviously want to figure out. So most guys, if they're race car guys, are going to do application of 3-step and TPS. So hit the trans brake, hit the clutch, whatever you're going to do at 50%, boom, I'm starting the log. Okay. It's going to go for 20 seconds. That's typical. If you only want to do it on the release of the 3-step, that means that when I release the 3-step and go, then it starts logging. Okay. In the old school days, header to Y2, the data trigger wire, you can still do that. So if I'm over 15% and I want to go off of header to Y2, that's when it'll start, if you're stuck on that, okay? Now, these two advanced features here, what this means is if I come back over here to my generic section, system generic over here, okay? I can now basically infinitely have this thing trigger on any type of way that I want. You know, you can totally get creative on all the inputs. So if I go to my generic section and I go to my advanced DAQ trigger, I'm simply saying every time I go above 10%, I'm starting a log. Okay? Every time. So in this case, it's going to be 10% and I'm going to record for 20 seconds. So literally every time it goes above 10, I'm going to record 20-second log. Every time I go womp, womp, whatever, it's recording. That's how that works. Okay? If I wanted to add in any other condition, like I'm on the 2-step or I'm above, 50 miles an hour, I mean, again, whatever you want to do. Okay. So this is how you do it to apply it, or you can release. So when both of these went false, that's what the advanced release means. Okay. So if I went back to just TPS filter, okay, when the TPS went above 10, I'm not doing anything if I was on advanced release. But when I went below 10, it would then start because I'm releasing the logic's going false. Okay. So there's literally any which way you want to trigger that logger is possible. It's basically infinite. Okay. Most race guys, though, most race guys will do it on application of 3. This way, when I'm on the brake, I can see everything that's going on, right? You can see your fuel pressure, oil pressure. You can see everything that's going on. That just makes sense. All your EGTs, sun's dropping out. That's typically what most guys do. Okay. So again, you'll never have to go into the SD card. You'll never pull it out. You'll always just interface with it through here, through the software. Only time you ever need to pull this guy out is if you're updating firmware. And again, back in the old days, it was painful. We had to send the box back, right? Which we don't do that anymore. So you update firmware on that guy. That's the only reason we'll ever take it out. It always stays inside the box. Okay, makes sense? Good. Any questions on that at all? Makes sense? No? Gen 3 actually only lasts for 20 minutes. And then it erases itself. So yeah, that's... No, you got to send that to us. Yes. Yeah. Make sure you insure it. Never arrived, Yeah, exactly. You can do 2. You can do 2. You can have 2 runs stacked on top of each other in a logger. Yeah, we'll show that. We'll show that next. You got to go? Okay, no problem. No problem. It's all good. No problem. It's all good. No problem. Yeah, thanks for coming, Chip. It's all good, man. Good seeing you. Right? Okay, so okay, guys, we're actually are almost through this here. So let's get a logger now. Okay, logger now is we got different tabs up here, right? Graphing and logging tab. This is where you're going to live in. Now, these guys asked a question at the very beginning. We have a crap load of data down here, right? You don't want to see all that. I don't blame you. Okay. So if you don't want to see a lot of this stuff, we actually have a list of what everything does on the website. But like if you're running a dual NTK system, you don't have to see all the AFR cuts for, you know, AFR cut 1 through 8. You don't have to see the AFR through cylinders 1 through 8, right? You can get rid of a lot of stuff, right? If you're not running nitrous, you don't have to run, you know, pull up a lot of nitrous stuff. Okay, so if you come over here to this gear, the gear icon, this is how you make all your changes to your actual logger. And if I come over here to select displayed fields, okay, you can see here I've already got available fields and display fields. So I've already moved a bunch of stuff from the display field section over to the available. I've taken them away. So I've removed E85 spark offset, all these different lambdas, NOS, individual cylinder corrections. Like there's already a bunch of stuff out of there. All right. So this is where you can go through here and just get rid of a hold down. Now I just highlighted that entire bank, right? I'm going to send it over to the left. So now I just punted that stuff, okay? And now it's going to be over here in this section. So I just removed all that. I'm going to hit OK. Okay, so now that's all gone. So you can literally just go down and just keep drilling down to the stuff that you care about, you know, to stuff that you don't care to see. All these corrections here, again, if you're a race car guy, get rid of all those corrections, that can go away. You know, it just depends on what you want to see, but this is where you can go through and get rid of a ton of stuff. So these nurse values, this is for the Bosch guys. These nurse values here, back in the old days, we had that 300 ohms is what we used to know if a O2 was good. That's what this nursed value is, okay? One thing to remember is that if you guys get rid of this stuff off the screen, it's still logged. Okay, so if you want to go back, damn, well, actually, I wanted to see what the nurse value was. You can add them, and if that log had it, it'll show you. Okay, it just removes it from the viewing of the logger. Okay, but again, if I was to come over here, select displayed fields, just hammer down, just go find nursed. Okay, there it is, nursed 1 through 8. You know, no, it's offline. You can do it offline. So again, if you're an NTK guy, you don't care about this stuff anyways, highlight it, shift, boom. Ah, I didn't hit apply. Select displayed fields. Oops, nursed. Right there, highlight there. Shift, left arrow, boom. Okay, and you just keep chopping that stuff out. Okay. So
Available until you highlight them, they won't actually graph up there.
correct. Yeah.
Respect to like clicking up will change colors.
Yeah, it'll change colors. And so this is just looking at it, okay, as one table. So if you're the kind of guy where you want to have, you know, max number of graphs up to 5, see here it says max number of graphs up to 5 graphs. So let's just say I came over here and I want to start making an AFR table here. If I right click on AFR cylinder 1 and I go to graph 2 and I make this red, okay? Now I'm going to start another one down here. So now I've got these points grouped together up here in this one. Now I'm starting at number 2, right? So if I send to graph 2 and I want to make this green.
So they're not on one area. Get too many lines. You can actually
Correct. So here, there's an AFR one. Let's just say I want to start making an EGT one, okay? So I'm going to send this to graph 3. Okay, just right click over it and I'll make that orange, okay? Now I start a third one here. So you can have up to 5 as the defaults here, you know, different sections if you would. Okay, listed. That's how that works. Now, all these different tabs, okay, are pre-built from us, but you can rename this if you want. I'm sorry, you can make your own. You can add or subtract these values, you know, it's totally up to you. These are just built from us, from the factory, as far as stuff that we would throw in there, okay? But all you do is just turn stuff off and on that way. And see how it's changing color, Brian, like that? If you don't like the color, you can send it graph 1, you can make it red. So it just depends on how you want to set it up. So if I came back over here, I did it on these 2. You'd have to go in there and actually uncheck them from that value from that graph. So for example, on EGT, right? If I came over here and just turned it off, just clicked it, now it just goes away. Yeah. So it's handy if you like splitting the stuff up that way, it's totally up to you. There are some guys that just want to see everything just on one screen. If I got rid of these AFRs 1 and 2, now I'm just looking at everything just on the one screen. Okay. So that gear icon though is where everything lives as far as making adjustments to this stuff. Okay. So let me pull up a log here.
Can you preset it, Ben, to where every time you open it automatically brings in the 5 categories or 6 categories or 8 categories?
Yeah, when you exit and save, it should save all those changes. So
When you open up a new graph, it'll bring in the same, whatever ones you had turned on in the last graph.
correct. Yep. So let's see. Right? Let's see here. No, there's one of those. All right, so basically what we're looking at here, all these different data points here are stuff that we're looking at. And what you can see is on the right-hand side, see the blue ellipse hanging out over here? See this guy moving around over here on the right-hand side? Okay, so what you can do is the biggest thing you want to do over here is right-click, and you want to make that history trace length 400. I'll show you how to do that again. Okay, and you see how that tail just got nice and long now? So you can see where you've been, right? Yeah. So that tail basically shows where it was, and then it shows where it went. So it shows you where to make adjustments at in those tables. Okay. So if you right click on that, there's a bunch of stuff you can do inside this table, but it's that history trace length right there. That's what you want to make is 400. The factory defaults to 40. Mm-hmm. Yep. So if I come over here, if I right click again on this, when you apply that 400, it only does it to that one table though. Okay. History trace length of 40, make it 400. Okay. So now both Spark table 1, okay, and fuel table 1 now have that tail on it now, so you can see where the hell it's been. Okay. Which is helpful with troubleshooting because obviously you may not be able to see where you were, but now you can obviously in that group of section, if you're lean, you're fat, whatever the heck it is, you can now concentrate on that area. Okay. You can also look at these guys in a 3D view, same like you could out there. Again, it's just something that you're looking for those weird spots. Okay. And over here in the upper section, okay, you can pull up anything that you want. So if I wanted to look at my first gear curves, okay, here, okay, it's listed here, and we'll pull up a pass and we'll show it actually moving through this section. But in all these buttons here is where you can pull up anything that you want to look at, your desired wastegate, time curves, okay? So everything is here, will then be working with the rest timer running here. Yep, yep.
Hey, Ben, I got a question for you.
Well, so you'd have to know which one is that. Yes.
You can turn those off and on by the screen down below. It's hidden.
Yeah, you've got two graphs you can be shown at the same time. Uh-huh.
Make more of those or less of those?
Just these two. You only have two to choose from. See, I've only got a button up here and a button here. This here. Yes. Oh yeah. Yeah, exactly. Exactly. Yeah, you just simply click on each dot and just adding what you want. Chip, did you say something out there? Was that you?
I did. It was me.
Sure.
So if you have a run file and then just say you go back to look at your dry shaft curve compared to where your SR2, you know, your ETM lines are.
Yep.
Is there a way to zoom in? Because honestly, really not much past the 1 second mark. Everything else is so clear because you don't really want to have your lines that tight. But in the first part of the run, you do typically.
Right.
Is there a way to zoom in so you can kind of get some old, you know what I mean? It's harder to see. So
Yeah, so here, let me show you on this here. Sorry, 1 second here. I had this one picked out, but of course. Okay. So easy to see how you can get a lot of data over here shown on this side, right? See how it's
Yep.
going from left to right? So
Yep.
Chip, you're asking up here on this table to zoom into this?
no, when you go back and look at your actual run, like the actual run itself, where it shows the dry shaft line
Mm-hmm.
from the run, and when you have your you know, your SR2 line and then your ETM line over top of your dry shaft curve.
Right.
Early in it's hard to read in the beginning of the run because obviously you have your lines much tighter than you would later in the runs. It's just trying to
Yeah,
safer as a zoom tool.
let's just look at that real quick so we can both be on the same page here. So, all right. So just turning off a bunch of stuff here. Okay. So, you want, so let me put the dry shaft. This is engine right here. So you want so just so you know, guys, too, these lines here, when the 3-step releases, we automatically plot where you're at during the run. That's what these vertical lines are right here. Okay. So, Chip, are you asking over here on the left side to zoom in? Is that what you're asking?
No, on the actual right hand side, when you actually select your actual run from, let's say you're on gear curve 1.
Yep.
And you want to see where your dry shaft line is in comparison to your curves that you built.
Mm-hmm.
Is there a way to, you know, is actually a way to zoom in that so you actually can look at it closer? Because like I said, the lines, yeah, see, when you look at,
so here's what Chip's talking about. So what we're going to go over now is, and this is a good time to start this here is, so this is the dry shaft curve table, okay? So in this case, we want to use dry shaft. So there's no dry shaft data here though, right? But we need to put it on there. So up here, we've got these 3 dots, okay? And you got to come up here and show XY data log plot. Now it's going to say, okay, what am I going to shove up there? So the x-axis field is always SR2 timer. Okay, it's the race timer going down, okay? Like this. And then I'm going to choose RPM, the good old toss. Okay. So if you can see that now, you see it in purple. Okay, this purple line right there, that's the dry shaft. Now, is that what you're talking about, Chip, to zoom in on this?
yeah, zoom in like on that lower level to the left. That way you can kind of really see how close you are to your curves early.
So can you guys see that purple line inside there? Okay, that's dry shaft. So basically what he's saying is you just can't like left click on this guy and just zoom in, Chip. If that's what you're saying here. So what you basically have to do is you got to rescale this table to zoom in tighter.
Okay.
So what you got to do is, I'm looking at the logger. If I come out here to my SR2 dry shaft curves, I can see it bigger here, okay? Because now I've done the whole XY plot. Now I can see it a heck of a lot easier, right? Okay. So what you got to do is you got to come over here and set the, let's see here, the Y-axis maximum. Instead of being 6,000 here, if you want to zoom in really tight, let's just make this, 2,000, all right? And then if you want to make it even tighter, you got to come in here. Instead of being 10 seconds, obviously, we're going to make this 2. Okay.
There you go. Yeah, that's nice.
So I don't have a way to just zoom in and out, like with the mouse, you highlight, you zoom in quicker. But if you want to get in tighter, you just have to simply reset those axes. You know what I'm saying? To get in tighter.
Yeah. Does it stay like that, or is every time you come out and go back in, you got to reset it?
No, it'll stay that way. And then as you're moving across, because I just did that window out there. I didn't do the one inside the logger, right? But it'll stay here.
Okay.
So it will hold that. So if
And
you,
you
if
did-
you really only care about that RPM up to that time, you can leave it scaled like that if you want. You know what I'm saying?
Yeah, yeah. I mean, it's like I said, you're just looking for it to, I mean, that's your traction control early. So it's really the most important
Right,
in a
exactly.
run.
And you can just, just keep playing with that to be different levels, you know what I'm saying, as far as how it looks. And you can see again, just in this example here, we start going across our first line right there, right?
Right.
So that's how you zoom in. It's not the best to where it zooms in on it for you on your own, but you can totally rescale it and get in there however close you want to get to. Okay, that makes sense. Thanks, Chip. Okay, so now that we're in the logger, if I come over here, I'm gonna go to my 3-step. Okay, 3-step input. So you'll see here that on this run, okay, the 3-step is right here. See it up here in the top left, 3-step input. So when I go 3-step false, okay, that's when everything starts. So you see how when I drop the 3-step, see this SR2 timer right here? Boom, see how that starts? That's how this works. So the 3-step is the start of everything. It ain't the 2, it's the 3. So when that 3-step goes false, that's when all this stuff goes true. So, okay, you're at the track, and now we're on fuel, excuse me, you're on fuel table 1. There's your tail. There's where it's going through, right? So let's just say it's reading, it's correcting, it's adding 20% of fuel, okay? Are you gonna, I'm sorry, it's taking away 20% of fuel. Do you want to go in there and just take 20% of fuel away? God, no. Don't do that. Okay, the O2 correction is one thing, but it's highly advisable if it's pulling 20. I usually go at least half, if not a little less than that. All right. So again, if you're sweeping through and the AFR, closed loop's pulling 20 because you're that fat, you're going to go in the area where, if I'm in this area showing really fat, okay, I'm going to hit X. And then if I want to take 20% out, right? Any idea what that would be? Instead of, if I'm taking out 20, 0.80, right? Because I want to be 20% less. Everything's based off 1, right? So just 0.8, okay? And I just hammered 20% out of there. Now, just in that box. And again, yeah, and you can see it all right there. I just dropped it all out of that one section, right? So again, you got, yes. Yeah, it's staying that way. It's not changing. It's just going to stay. It's because it's showing you the correct, because if you look above it, I got 136s here and 107s here. So the higher the number, the redder it goes. So it's going to stay that way for good. So remember, all the stuff is the same. And what I mean by that is I'm on fuel table 1 right here. It's the same thing as this fuel table here, right? When I make adjustments in the logger, it's the same thing out here, right? So when you're making adjustments in real time in the log, it's doing in the logger section, you're influencing the same exact tables. Yes, you're making that change on both. Yes. Yeah, it's just not happening out there in the logger. This table out here in fuel settings, number 1, you choosing it here or you looking at the logger, it's the same flipping table. Okay? So just something to be aware of there. Again, if I was going to take that same area, but I wanted to go back, if I just took out 20%, what did I want to do if I want to put back in 20%? Any idea? If I want to add in 20? 1.2, right? Because I want to add 20% back. So 1.2, and then I'm right back to where I was, okay? And then if I wanted to add 20% on top of this, again, same thing, 1.2, right? And then if I look at my 3D now, okay, now I'm getting really red, right? If I look at the 3D view, now I've got that big old hump in there. Okay. So again, it's going to show you, hey man, you got a lot in here, you have a lot less, right? It's going to tell you where you got the fuel in or out. But when you're making a pass and you're making a log and you're looking at your data, you always want to take just baby steps on the fuel side. The O2 is just giving you a guideline of what to do. Don't rip it all out all at once, okay? Because that next pass, Conditions may change, things may change where it only would have been pulling out 10. Okay. You can also make it so that on the negative correction, you know, like in this case, I'm only letting it pull 10. You can make it only pull 5. And then that way, if it's really fat, it doesn't matter. It's only pulling 5% to begin with, right? So any which way you guys want to go about it there, okay? But just remember that when you're inside these tables and you're making these changes, you are affecting the real tables out here in the cow. You're not affecting something else. Sometimes people just get, you know, mixed up by that, okay? So same thing for the ignition settings. Again, if I was over here and I was doing something with the spark, you know, this is going to ultimately change the spark map of the actual cow. If I came over here and just made this 5, okay? And again, if I look at it, okay, I got that huge area out there right now. It's going to be the same exact thing that is on this table. I'm out that 5. Okay, so same exact thing for those loggers. Does that make sense? Okay, so over here under the gear icon is where before. So if you look up here, it automatically calculated based on the 3-step dropping sometimes. Okay, that's just an auto calc. It just figures something for you based on what it saw. Okay, you don't have to do that. You can come over here, view edit time slip, and then you can put in your own values. Okay, but it fills them in for you based on what the when the 3-step released and it saw the dry shaft RPM, it can calculate over time approximately what it's supposed to be. Okay, either it's right or it's wrong. You can leave it that way, or if you got an actual pass notes, you can put your notes in there, and you can actually plug in your ET mile an hour, 1,000 foot, all that kind of stuff in here. Okay. You can also come in here. What I like doing here is this trace line style. You can have the lines really, really fat. So, you know, when you zoom in and then get really thick like that, as you have more graphs open, it doesn't make them as fat. Sometimes some guys like them nice and skinny. They'll just stay this size the whole time. Okay. So let's go over this on your G meter and gyro, which is very important. Okay. So I'm going to just turn a bunch of stuff off here. No, you got to unclick those. That's a good rec. That's actually not a bad rec. We can probably take care of that. Yeah, we can probably do something like that. Yeah. No, we can probably do that though. All right. So that's it. All right. So right here, okay. The G's went to 2.96. Car launches. Okay. Comes over here, heads up here. 2.06? No, 2.04, okay? If I don't have any smoothing on this guy, okay, if you guys don't know what smoothing is, all smoothing is basically is whatever data is coming in, you're just applying a filter to limit the highs and lows, okay? If I have no field smoothing on that, oof, right? But that's really what's actually happening. That's how much the car is actually going on the G meter back and forth, okay? It really is that precise. So the race pack, like we talked about earlier, is basically the God's end for most of these guys, right? For the actual G meter. So if I hit that field smoothing like that, I want to make it 32. You can adjust the smoothing factor to be whatever you want, okay? 32 is what you're going to make a G meter. Now, if you launch the car and this is down here going the opposite way, remember when I talked about in the very beginning? Just come over here to System, Pin Configuration, I'm sorry, Pressure Sensor. You're going to invert the accelerometer signs. It's just backwards, okay? That's it. Exactly. Just switch them. And then it'll go this way. Okay. Now, if we just look at this car here, let's get rid of the other signs that don't mean anything. Let's turn this off. Turn this off. What's that? Because they're on. See how it says on? So these turn green even if they're not chosen on the table. Okay. So what you can see here with this car, if you guys do a lot of G meter work, you can see here that this thing is getting hammered as it winds out. Okay, it's just falling off and then boom, it picks right up. Okay, so if you live and die by the G meter, this is the kind of data that you're looking for, because obviously between here to here, we don't want that thing to fall off as bad, right? We want to pick it up. Okay, so power management wise, if you're doing timing wise, a boost isn't coming at wise, whatever, that's what you're trying to fix, is that guy right there. Now, for this car, I remember this was basically the very first pass. That RPM was real choppy because it's fat. She was fat. She was no noser because it just had way too much fuel. It was one of the very first passes on the car. So G meter wise that's what you're looking for. The gyro is over here. Okay, now, okay, right there. See how this gyro is moving around? That's the car moving side to side. Okay, so this is where I could set one of my outputs to say if my gyro got to 20, that's my ass is kicking out, launch a shoot or something. Okay, that's what this is. And again, the gyro is going to inverse the same with the G meter because they work together. Okay, so when you set the G meter correctly, the gyro follows it. Yes.
Any input to set the safety like that?
Yes.
Send something across a bus and do that?
It has to be for now a dedicated input on the ECU itself. Yeah, but that's where talking back and forth to stuff. Yeah, well, the CAN right now for the most part just speaks out. When we get the data to be able to come in, that's the kind of stuff that we're talking about, right? Like for example, when you really are seeing, I loved it when you saw the actual knock. You know, send me a trigger, say, hey, I just saw knock for real. Pull a timing or just hit the ETM at 20, just rev them a little bit, you know. Then we'll set a CANs thing saying, hey, your cylinder 7 CAN just tripped. Absolutely. Yeah. Exactly. Yeah. Shut off. Yeah. Mm-hmm. Yeah. You can do anything that you want in that aspect. So, but that's how you'll see the car was definitely sashaying a little bit out there, you know, nothing bad, you know, and obviously as it wound out there, it kind of slowed down, and it's pretty amazing to see how going down track, how much it actually can sashay, you know? So, so basically, on the logger itself, when you stack everything up, the biggest key is just not going and just making the monster adjustments. You're going to want to basically just come in here and just make small fine-tune adjustments based on, you know, not overdoing it based on the data that you get there. Okay. Also, when it comes to the smoothing itself, for example, on the spark, you never smooth spark. So if I come over here and I throw in, okay, spark advance, okay, it may look ugly, but you don't want to smooth it. Okay. And the reason being is because you could lose resolution, which you don't want to lose a spark, right? If something's going on the spark advance and I come over here and I make it look pretty, let's just say I'm coming over here and I do a field smoothing. Okay. Field smoothing 2 is fine. But if I make this thing, you know, 30, now I really smooth it out. Well, I'm losing a lot of actual, you know, resolution inside there. The spark is very small, right? A tenth of a degree, a half a degree change can mean something here. So if I smooth that way too much, I'm missing what's going on. Okay. So you only want to smooth anything spark related about 2. And that'll help you out a little bit. Okay. It's just, you don't want to go too much to where, you know, that point, if you smooth it out too much would start to become a curve, right? Because you're losing the resolution by smoothing it out too much. Okay. So, exactly. Yeah. You don't want to do that. I see guys, can I come in here and they got everything smoothed out, these huge numbers. I'm like, you're missing so much inside that smoothing, right? You don't want to do that. Okay. So, let's talk about, doing that compare log, Don, like you were talking about here. So basically the way this works is, let me get rid of some of this stuff. Gyro. Yeah, so you can come over here. Preferences. Generate time slips. Let's see here. I'd have to restart the software though for those to actually go away. So we can restart those later though, Dawn, promise. Okay, so if you want to come over here, let's get rid of the G meter for now. We'll just have engine RPM up. All right, so now we just got engine RPM up here, okay? If I come up here and I do a compare log, let's go back here. Over here. Okay, so basically what we're going to do now is we've got two passes here, and you're going to have this line up here. Okay, so we want the 3-step because the 3-step's actually going to be how we know when this thing went false or true. Okay, so I can't really see with the red. Can you guys see that with the red? Can you? Yeah. Okay. So basically what you want to do here is, it's actually a good indication because it shows how it let go right there. So what we're looking to do is we're looking to line up the three.
Turned on that 3-step, it actually took both graphs and put them on.
Well, you're gonna have to line them up. And how you basically do it is you got this line over here, okay? And basically you can tell that on, let me go over here. Okay, so it lines them up and you can tell that right there. See how they both inactive, active at the same time right there? Okay, that's both the logs lined up. So you line that up and then you can compare whatever you want, okay? And then this basically shows, oh, sorry, allied. Right here. See the SR2 timer right there? That's how, sorry, I'm going the wrong way. All right, so right there, see how I got the SR2 timer lined up right there, both at 1? That's actually how you know they're actually lined up right there. See how the timer's together, okay? So that's how you line up these two to actually tell your overlays. So this was, honestly, something really bad happened there. I was hoping to talk about that somewhere else. But you can see the SR2 timer takes off, it goes, and it launches here. And then something obviously happens. It must have just broke the tire loose right there. But that is, when you come over here to that compare log, that's how you bring those two together, okay? We're working on a future revision where we can actually have up to 5. It's going to be a lot, but this way you can stack up to 5 runs. And then this way, you know, if you got 5 G meters or whatever you're looking at, okay, you can obviously see, compare that many, you know, together. So on this one, you can obviously see that this G meter was complete junk. And then this one, it took off and went really hard, right? So
Turn something on, turn them on both logs.
correct. Exactly. So that way you can compare and be like, okay, wow, you know, look at my G meter on this one, you know, compared to this one, right? So this one basically launched and then it fell on its face because it spun. This one went off and went because it obviously hooked and went, right? So that's how you can compare those two. So correct. We got the 2. But so when you bring those in, that gives you the ability to overlay both of them and say, okay, you know, what was difference between my timing graphs? You know, was it my dry shaft plot didn't catch it right? Bad track conditions, whatever that it is, gives the opportunity to say, okay, that was too hot. Let's bring everything back down. You know what I'm saying? So that's how you do it. Just open data log, and you just simply want to get that SR2 timer up and just have those suckers just right on top of each other. That's all that you do. That's it. And you'll use that little cursor right here. That little cursor right there is just used just to line everything up, get you in the raw. And then see how it says negative 2213? That's just, you're just lining up the frames right there. There is no magic number on that. Just go up or down to make the SR2 timer line up right there at the very beginning. So if I go back here,
You're doing trace and scale, right, just doing them both?
Yeah. Yeah, it's on it. Well, no, it's going to be on the very first file that you brought over. Sorry. Yeah, it's on the very first one. Correct. Yes, correct. Yep. It's just going to go over. It's going to stay with the second. You're just comparing to the other file that you brought in. That's all that is. So what we're going to bring on here right now is Russ is going to bring on some 802 individual sonar data here, which is pretty cool. So one thing too, just while we're waiting here real quick, on the Gen4 website, okay, all this stuff is listed here in the Gen4 tech section. So if you come over to tech info, tech and support, if you have a lot of time to kill, which I'm sure everybody does, but if you come over here, everything I've talked about is all here. Wiring diagrams, the freaking instruction manual is probably over 300 pages. So what we did was we broke everything out. So AFR menu, CO2, traction control, like it's all broken down to those different sections that you want to learn. Okay. So obviously nobody expects you to read a manual that long, but that's how we broke it out to get into that area that you want to get into. Okay. It's amazing how much it sweeps around though, isn't it, Russ? How much it just sweeps around though. But I mean, that's only like 3%.
Basically, I think I only had like 5%. That's usually what I stick around, correct?
Right. Yeah, no, that's awesome.
Really, the whole day I didn't really touch it. I just kind of left it alone.
Right.
Because we were changing stuff the whole day, so
Right.
to go and try to find it probably wasn't advantageous.
Right. I'm just trying to see which is the G meter for you. Oh, there it is. X. There it is. Yeah, beautiful. Yeah, that thing pulls the wheels up pretty good. Pulls the wheels really good. Yeah. A lot of G's real quick, getting after it. Yeah, I mean, if you wind out, so as you're winding out, if we just take the back, the top of high gear, I mean, you're really not averaging that much at all. It's pretty good, right? Yeah, that's pretty tight.
You pull up the readings as well.
Yeah. So
Although it looks like the correction is kind of wavy, but what's actually being produced in air fuels is, it's pretty tightly grouped.
right. Oh, I got too much on that. Okay, hold on. I'm gonna send those to graph 2. Send the graph 2. Send the graph 2. Send the graph 2. 2. Row 1. Purple. Yeah, yeah, right. Yeah, that's pretty cool. That's just ridiculous. It's okay. Yeah, it's about a half hour. Yeah, at the most. We'll just stay and talk and bullshit just however long, but another half hour at the most.
So, does the air fuel target, does it pull that up for the calibration I have, or is it?
Yeah, it's right there, 13.2 AFR target.
It should.
Oh yeah, so there's 13.1, 13.3, 13.2.
Just can't see.
It's probably at some like auto. Yeah, it's on the top. Yeah, what I'll do is I'll throw the target down on the other one. So send this to number 2.
Even though it's not like drastically different, you can still be able to see it.
Yeah, it's hidden in there, but let me do this here. So field limits editor. see if we can make this like max of 10 and 20 maybe. Yeah, we can see a little bit better down there. Let me change the color. Can't really see it. There we go. Now we can actually see it. Yeah, so you launch, you dump it, right? Lean out a little bit, then go back down in high gear, right?
It's not much, and really it's probably that we've tried bigger swings and
Right. Sure. But still, it obviously helps out a little bit though, I would imagine. Keep her safe, get after a little bit more in second, right? Because you can a little bit, you know? No, that's awesome. I mean, again, if you look at the average out there in high gear, I mean, your target's 13 too. Look at the averages of all of them. It's just it's insane. I mean, yeah, that is just ridiculous. So, yeah, that is just pretty amazing. I mean, that's obviously you got some calibration time there on that bad boy, you know?
like if we're running a restrictor plate versus not,
Right.
like the cylinder to cylinder really isn't all that different.
Mhm.
But again, it's all automatically correcting, so
Right.
even if it's a little off, it's still just doing its own thing.
Right. Exactly.
So I really don't change a lot. Like I really haven't.
Right. Because it does it for you. But you're also only going less than 5% also. So it's so minute, right? Exactly.
Something like that happened, like, yeah, something,
Right.
something about the brake or something.
Right. Exactly. Yeah. So you can't do that on the methanol side. I actually get asked quite a bit. Well, can I do 8 of the methanol sensors? And no, you can't do that. It's just so you know for how yours is set up, when you actually send it in, we actually install a separate microprocessor for that NTK sensor. That's why it's so expensive, because we actually have to install basically another microprocessor board to work with that alcohol-based sensor. That's how that works. So
I don't even know if I know mine's a Gen4. I don't know what.
if you're reading AFRs that low, you've got the methanol one. You have to, you know.
The guy knows nothing about it, so I'm just trying to figure.
Yeah. If you're reading that low, and if you look on the bottom of it, it'll say NTK option on it as well. Yeah, it'll say it. So
An option as well.
what's that? This here? So this is canned for certain things. In this application, it's a race pack. It can be for EGT or a J1939 data. That's what that is. So on your, the connection where your dash is plugged into, that's the open can. That's where you can send anything onto anything. That's what that is.
Obviously, you have to install that and stuff.
This we have to. For what you're doing for the dash, that's just on the COM port. That's just already there.
I was just curious because I saw that. I was like, I haven't seen that.
Yeah. So for guys that want race pack data, or if they want the CAN EGT module, or if they want Dakota Digital, we have to install that whip. That way they can get that.
It's got a million race pack sensors.
Really?
Race pack dash.
Oh, so you have race pack on the car. Right. So just so you know, there's another race pack. Race pack's awesome, but because this basically does everything, it's all connected to this. So what most guys do is they'll actually take the race pack out, sell it to a guy that needs all the race pack stuff, get a touchscreen dash like he has. Now you can actually tell the ECU what to do. The race pack just reads stuff, can't do anything with it. And then any data sensors, any sensors you have on the race pack, you can just bring into the big stuff, solid stuff off. It's just in universal 0 to 5s. Yeah. Well, you can't take the race pack directly to the ECU. You'd have to sell the race pack because they got the race pack can, all kind of stuff, for everything that they do. You'd sell all that out, and then you just get the universal 0 to 5 will sensor, so whatever you want to do on that, but then just bring it in here. You know what I'm saying? And that way it's just this. Yeah.
It's like a big, an SD card for the racing.
Right. Right. I mean, for them, you only have a 4 and a switch panel. That's all you have in your car, right? Yeah, that's all they got. Yeah. And again, the G meter's built in. So, and like I said, that's what everybody compares to the race pack, right? So we got to just do it here and this way now you can overlay the G meter plus your actual power management stuff, and
it's all right there.
Yeah.
See, I feel like the difference, like because I'm playing around with some poly stuff and I see all these other companies, like, you have to open up all these windows, like try to overlay all the windows together and try to look at your trace and all that stuff. And this, you're just looking at it all at the same time.
Yeah, it's
I
grouped
just find
together
that
pretty
so
well.
much nicer.
Yeah, it's grouped together pretty well, you know, so.
As far as the CAN connection and connecting to the dashboard,
Mhm.
it's like, what are the advantages of doing that?
Over what?
Just over the comport connection.
Well, that is it. Your touchscreen dash connects over the COM port.
Okay, you're not.
Yeah,
okay, I
this
didn't-
is only if they need something specific, like a race pack dash, race pack EGTs, CAN EGT, Dakota Digital.
Got it.
Yeah, you're the all touch.
Probably why you can't-
Well, yeah, he
you
wanted
guys
the
do
race
that.
pack information. See, we only send race pack information out. So your V300 is taking the big stuff data and bringing it into it. That's how that works.
And I should be reading that data off of the SD card that's coming out of the race pack.
Yes.
That's cool.
That's probably all still there. I don't know how it's being activated and
I don't
triggered.
need that, I gotta figure
Yeah. But that's what I'm saying. That's what most guys do. And it just declutters everything.
Right.
And now you just, yeah, exactly. And basically we
it out.
said,
Stack of those
exactly,
literally that big.
exactly. Yeah. I mean, like those Rife sensor blocks are really nice.
Yeah.
You just get a couple of those, plug your sensors in there, run those wires into us, and you're pretty much done, you know? So, and again, why I like the dash over the race pack dash is because now you can actually lanes or do something with it. Exactly. And there again, there's nothing wrong with the race pack dash, but you just can't send stuff back into us. You can't make a tune-up change or change your power management. You can't do anything. Like on the dash, you have an offset to your gear curve. So like your first gear curve, right? Let's just say you've got some plotted in there. Well, like, damn, this track's really good. I'm going to add 2 degrees to the whole thing. You can have 2-degree offset. Boom. Now you just made that gear curve what it was. You added 2 to it, or you can change whichever one you want to run, you know, versus right now you're just, you got to do everything that, which is nothing wrong with the laptop. It's just not as convenient. That's all, right? Yeah. So Bob and Don, they got kind of a similar combo for factory stock. And this is kind of what you guys should want to do right here, guys. When you're going down track, this is what Kim's looking for to do. So this is, what is this? It's a 350 Chevy, right?
Yes, it's basically, it's a 4th gen Camaro, so it's just the LT1 combo. So it's a super stock car. So really, it's just, the only thing LT about is the cylinder heads, everything else is, you know, aftermarket, bow tie block, Edelbrock intake, you know, we got our own stock throttle body, which, you know, similar to you guys probably, but I mean, this has been it, right? It's been.
Yes. So you can see at the very top right there where per cylinder what it's doing, right? So just that wherever I'm at, like number 1's pulling 2%, but number 2's adding 2%, right? Number 3's adding 2, number 4's pulling 1. So you can see as it's moving around, but look at what the averages of all the cylinders are. His target's 13.2.
Oh, it's funny. Like, this may sound like out of control, but do you see that little spike right there?
Yeah.
That blue line?
Yeah.
So we haven't put plugs in this engine. Like, we went to Pennsylvania, ran 2 of those races, then we came back for a test session. Like, I'm going down the track yesterday at Rockingham, but I kind of hear a little pop every now and again. I'm like, oh, maybe this thing needs plugs. So I'm looking at the data, and I see on a few of the runs, I see that little spike there. I'm like, it's actually reading. You know, it like it's
Oh, on the O2.
yeah, like it's actually reading. Okay, yeah, we're gonna put plugs in it.
So, oh, do you know which cylinder that was?
You can tell that blue.
Yeah, let's see here. Which cylinder was that? Yeah, number 8. Yeah, it went 14.4.
I just thought that was kind of fun.
That is funny. Yeah, right? Yeah, I caught the miss right there. But you can see here though, like for you guys, Bob and Don, when he launches, he dumps the air fuel ratio target, right? And then in second gear, he brings it back up, right? And then when he goes back into high gear, he brings it back down. So, yep. Yeah, so that's map by gear. They do map by gear too. Yeah.
I don't think I changed this. Or Actually, yeah, I do it from first to second to third gear. I do change spark.
Well, yeah, we can.
So.
So let's send that to graph number 2, so you can see how the spark is changing, right, per cylinder. So you launched 37 in first gear. Second, you got 35. And then looks like you're out 35 the whole way. So you just in first gear, you give it that 2, the extra 2.
When I'm on the trans brake, I keep the timing down a little bit.
Right.
Because I've noticed, like in the car, also with the fuel trim, when I'm on the trans brake, if I get too carried away with making those changes, or I put too much timing in it, or I take too much fuel out of it, it'll pop. When I'm on the trans brake.
Really? On the MSD, huh? Wow.
So I kind of try to balance it out.
Sometimes even when you let go out here, pop.
Okay. Huh. But that's just fuel loading up, I would imagine, right? Just lighting off in the pipe.
Yeah. It's kind of what I was asking earlier about the reason why I thought about the burnout map.
Yeah.
Because I don't want to mess up what the engine's doing while it's on weird.
Right. Right.
Right.
Right.
I feel like it's in an area of the map though, when I'm trying to do a burnout or whatever.
Right.
It's probably too lean.
Right.
But
Right.
it's too rich.
Have you data log where it is in that section of the map during a burnout? Okay, so we haven't done that yet? Okay, 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 got it.
And I should have done it yesterday.
But I mean, you're pretty much what, around 6,000 RPM and about 80 kPa, somewhere around there. You got to be pretty close to watt, I would imagine, somewhere around there. So you can guesstimate where you're at, right? So, but we can make a table so that when you turn a switch on or something, it then activates a secondary table.
Think about like the 2D tape.
Yeah, no, use them all the time. Yeah, absolutely. Yeah, absolutely. Yeah.
Like you said, yeah, like where you think the burnout's going to be, like put the fuel there.
Yes.
But you only got the map on when like the line locks on. Oh, great, more or less.
No, this is actually all software. Well, you'd want to have an input to do like a burnout, because that you only want to enable that table on the burnout though.
Right, that's it. Like line lock.
Oh, I see. We're not line lock. Oh, yeah, yeah. So yeah, does that input come into here right now? Do we know? Okay, so you'd have to put a relay. Yeah. Yeah. So we need a relay to have that come in. If you're on the line lock, then we can activate that table. Yeah, I'll show you how to do that. Yeah, that's easy. So actually here, let me just show you right now while they're bullshitting. So if you come over here, Russ. So come over here to pin configuration. So you would pick one of these inputs here, okay? So we're gonna enable a table based off of his input, okay? So you're gonna come over here. Let's just say spare AD1, okay? This is a low side input, okay? So on header 2 H2, okay, we're going to come in here. We're going to say, we're going to do something with this guy. Okay, so NOS digit set 4. Actually, no, we'll just do number 1. Just do NOS digit set 1. Okay.
Anything nitrous related.
It doesn't really matter. Yeah, it doesn't really matter because we're just doing that here. Okay, so NOS digit set 1. So I'm going to go okay, and then let's see here. So you want to have a 2D table. We're going to do it off of fuel. Okay, so I'm going to come over here. So we'll do it RPM TPS. We'll do a multiplier. Okay, so this is the table that you're gonna work with. Okay, so now we got to turn it on somehow though. Okay, just because it's here. Okay, now I'm going to close this out just because it's here. Okay, now see how it's open. It's here, but it's not turned on yet.
Okay.
Okay, so what you got to do here is it's based on TPS. So we'll go 100 and let's just say maybe 25 or something, right? Interpolate that here. Okay, and then we're going to come 2,000 and 7,000 here. We'll interpolate there. Interpolate. Okay, so I'll make all this just 0 for now. Equals 0. Okay, so now we're thinking maybe up here while you're watt and you're up in this area, we're going to add 25% or something. Okay, we'll just use a number. Okay, and if you kind of want to, interpolate into it a little bit, do something like that. If you want to interpolate into it here a little bit, something like that. And we'll just carry it out to here, 25 and 12.5. Okay. So now when you floor it and you start going up this way, you're going to start pouring the fuel into it.
Yep.
Okay. So what you do is now this table's built. Come over here. Generic section. System, generic section. Okay, so
That's where you turn it on.
so now I'm gonna come over here, okay, on. So now I'm coming over here and I'm looking for that Digiset filter 1. So when that is equal to 1 with no additional condition, that table is gonna go hot. Okay, but I'm not gonna,
Means that the pin has.
it's grounded.
It's grounded.
Mhm. So
When it grounds that pin, then
yes,
it knows to turn on that.
exactly. And if you, but it has to get, if you're down here, I'm not doing anything.
Okay.
So anytime, let's just say the
So it
light,
has to be about 25% TPS and RPM.
exactly.
Yeah, okay.
Now, again, this is just based on, you could have it based on volumetric efficiency and. Exactly. Exactly. That table's hot. So now that table's on. And that way, now when the table's on, he can add, you subtract, he can do whatever you want to do.
Yep.
But,
But you said it's still based off of table number 1.
it's based off of this.
Oh,
So whenever you put that line lock on,
doesn't look at anything else.
it looks at your fuel table 1.
That's what
Yes,
that's
and
what
then
I'm
it
asking.
adds based off of
So-
whatever you have there.
Okay, so here's my other question. So like if I'm in the burnout box and obviously I start in first gear, I start in second gear, but it's looking at table 1
Mm-hmm,
at idle.
mm-hmm,
So let's say it usually does this. I know it does this. It hits the next table
Mhm.
just because you're floating RPM.
mm-hmm, mm-hmm.
Is it still looking at table 1 even though the FSL map is changing?
No, it's not.
It's still only looking at 1.
Yeah, no, no,
Okay.
but this only stays with table 1. So
Okay.
we'd have to make it so that, so come over here, right? So come over here to the generic section. Okay. Go to, where's my table? Right here, okay. Okay, or, okay, if I go to FSL index, okay?
Yeah.
If that is greater than 1. So now as that FSL index changes, it's still gonna work fine.
It'll still stick with table 1. Is
Yeah,
that what
sorry.
you're saying?
And, okay, so when the input is true on the line lock,
Yep.
and FSL index is, let's see here, if it's equal to 1 or it's greater than 1. Because as you're switching through gears, we want to keep this thing on, right?
Okay, yeah.
Or greater than 1. So this way now, input's true and index is equal to 1 or greater than 1. So as you go up an FSL index with those maps, because you're shifting,
Yeah.
it's still going to stay true because the switch is on and these are satisfied.
Okay,
Because you're going to switch from number 1 to number 2 on the burnout, right?
that's what I'm saying.
So it's going to go greater than 1. We're still going to be good.
So even though the map changes, it'll still be.
The FSL index
It's-
is what
it's still
changes. So
changing.
here, so watch. So let me get out of
But
this.
your fuel modifier is still gonna change. It's still gonna be there.
It's still going to be true. So FSL table index, okay? See right there how you went to 2?
Yep.
Okay, and you went to 3. So as that FSL table index changes, as that FSL index changes, the logic's going to keep that table hot.
Yep.
Because the programming is set for, okay, when that input is true from your line lock, from your relay,
Yep.
if I'm equal to 1, which you always start with,
Yep.
you're going to burn out, go to your next table, then you're going to be greater than 1 on the FSL index.
Gotcha. Yeah.
So it's going to keep that table hot.
Okay. Yeah. That's perfect.
That's it.
That's exactly what I was saying.
Yeah. And then when you get off the line lock, that shuts off.
Regardless, it'll drop below the RPM, go back to FSL 1.
Exactly.
Good.
It's really the line lock is the key to all this.
Yeah.
Right. So if the line
And
lock,
even, I mean, really, is the rest of that logic even necessary though?
which one?
Like the last.
Well,
two.
because see, I want to make sure it's on. If I do greater than 1, that means that it's not going to be on for the first table.
Okay.
Right. So I have to say whether I'm equal to 1 or I'm
Oh,
greater
okay.
than 1.
Gotcha, 'cause it has to know.
Because you're going to shift gears and go to FSL index number 2. Well, that logic wouldn't be correct if I'm only equal to 1 or only greater than 1. You know, it won't, if I only have greater than 1, it won't be true until you shift into the FSL second gear. But I want it hot in the first gear too.
Yeah, you want it hot all the time.
Yeah, that's why I have an and statement here. I got to be the line lock and one or both, either one of those have to be true.
Okay, okay.
And then what you'll do is you'll actually see that if I come here to the generic, so you got these G's here. So if I come over here to the generic fuel multiplier, you'll see that adding 25%.
Gotcha.
That's what that's what that gen stands for. So if you're stacking up fuel multipliers in the background, you'll see the total of it right there.
Even though, so like, I know because there's table 1 and table 2, right?
It's just going to just tell you
It's
what
gonna
the
say
total
no matter
multiplier is running.
Okay,
And because you're in on the line lock, you're in table 1 or 2 or 3. Exactly. So whatever you have, you know, again, in this case, we have that 25% going out. If you're out here, it'll be 0. But if you're out here, you're going to show 25% in that fuel multiplier.
got it.
Now, if you have
You know,
exactly,
so I need to really, the data log and burnout's easy. I just haven't thought about it. If I just turn the ignition on,
yep,
hit the trans brake and floor, whatever,
exactly,
just get it to turn on and I can fire the car, do everything.
exactly,
Yeah.
yep, exactly. You could
So,
also,
like, I haven't thought about it until now, just because I'm kind of getting to a point where I can refine some of this stuff, and not be too worried about, you know, screwing something up.
yeah, I mean, you're not, I mean, I don't think you are, you know, so, but yeah, that's an easy thing to program. Yeah, I mean, it's really not, it's not hard to do once you actually see it, you know what I'm saying? But yeah, the gear by map is definitely freaking awesome.
100%.
Yeah, I mean, like I said, I've seen cars out here pick up the front tires again on the 2-3 shift. They figure, you know what I'm saying? Because it's just making power, you know? But then again, you start pouring it down as you wind out to keep it cool, keep it rich, keep it happy, you know?
Really, I mean, yesterday was, again, kind of like an all-out, we're trying to get everything
Right.
out of it, but when we
Right.
go bracket racing, I mean, it's got to be as consistent as possible.
Exactly.
And it has been.
Yes,
So
exactly, exactly.
That's the great part about it. And everyone's like, it's so funny because everybody that we go to, I don't want to take up too much time, but
Right.
everybody's talking about, you go to these races, like for us, you know, stock, super stock, whatever, all this whole argument about open and closed loop and like all this, it's like, you see that? Why would you not?
Exactly.
Why would you not be close?
I know.
That's always my argument.
I
But like
know.
for them, they're only looking at 102.
Right, they don't know.
So they don't. It's
Mm-hmm.
knowledge and data that they don't have.
Until you see it, you really don't believe it.
Exactly.
Right. That's the crazy part. I mean, that thing is holding 13.2 almost ridiculously perfect, you know? Yeah, that is just sick. That is awesome. Yeah, no problem.
That's something that Ben and I have talked about a little bit. I don't know, like, I do know we struggle with that with the customer.
Hey guys, you still with us online out there?
Yep.
Thanks for
If you have a
hanging in
half a
here,
se-
guys. We're almost wrapped up here. You guys have any questions out there? You guys have anything you wanna ask me by any chance?
A quick question. I went through and actually reset my my run log, you know, the times. And when you go for the SR2 to, you know, basically when it hits 01 is kind of when you reset your 0 for the run. The 60 foot in that first yellow like vertical line is not lining up. Shouldn't it line up or no?
Have you actually edited the time slip to show what it actually is? Because it's just generating lines on its own.
Yeah, I did. I went in and I put the time slip in and hit apply.
Yeah, you're gonna, so the next time you restart the software, it should move those lines for you.
Oh, okay.
Yeah, you'll have to, because those lines are generated, they got to be generated again, you know, based on your actual values. They won't update in real time.
Okay.
So that's how that works. But see, Chip, if you had like on this data right here, you could well, yeah, you're on gas. You could theoretically throw an O2 per cylinder and do this kind of stuff.
Now I'm looking at it. It's definitely slick. I mean, it's tight. I mean,
But it's still pretty cool though, because, you know, again, if you're actually looking at the correction factors going out, you can see them changing up here.
Yeah. Oh yeah.
And you can see them actually moving around, but they've got this motor so tight, it's taking very small swings to actually get out there and stay there, right?
Yep.
So, you know, again, if we averaged it out, the target's 13.2. Look at each one going out.
Yeah.
So that's pretty ridiculous, huh?
It is.
Yeah.
It really is. Now, when it's correcting the 2 to 3% like that, where it's kind of flopping around, is it worth even trying to do anything on a map, or you just let it do what it's doing?
You know, it's up to the user. If they want to have a safety in there, he's probably only giving it plus or minus 5%, you know? But again, it's pretty freaking flat. You know what I'm saying? I mean, all these guys care about, especially because they're super stock, repeat, 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 you know? So
Right.
they're doing everything they can to keep it at 13.2. So if they left it in open loop and there wasn't any correction going on, it would be wavering a little bit, obviously, per cylinder. So will that slow them down? Will that make their car not repeatable? So obviously the tighter you can keep that air fuel ratio of what you're trying to do, the more you're going to be repeat and just repeat. Like they just got a Wally last week again because the damn car is so repeatable. You know what I'm saying?
Right. Yeah, no, that's definitely slick.
Yeah.
We
so
were
they-
out we were out Wednesday, lost in the semifinal again, by 38/10,000. So it was 0.003.
Oh,
So it's, you know, qualified third. So they kind of rewrote the rules for the class because there was just too much sandbagging going on. So now it's like a lot more legit. So obviously, I mean, stuff is tight. You know what I mean? If you're losing by 003, it's funny. I lost by 003.
oh.
The guy who beat me in the semis lost by 003 in the final to the other guy. So it's like,
Yeah,
it's karma.
That's crazy, man. I mean, that's brutal right there. Wow.
Yeah.
Do you guys have any questions at all? Dan, Rob, you guys cool? You guys are quiet out there. You guys good? You have any questions at all? You guys just listen on? If you have anything at all, if you guys don't, if you remember something at all, you can always call me or email me later on also, whatever you guys need.
Yeah, Ben, you're recording this. Can we get a copy of that?
Yeah, it's going to go up on YouTube. So
Yeah.
it'll go up on
Cool.
YouTube and it'll just be up there. We'll put a link out on like Facebook, Instagram when it's actually published and actually ready to go. So, but yeah, we know it's a lot. That's why we always try to record these so people can go back and review these at a later time, you know, and then just, you know, try to listen to my ugly voice over and over again until it actually gets through. You know what I'm saying? So. Craig, was that you that was just talking?
What's that?
Who was that just talking with the Australian accent?
Craig
Oh,
Davis.
Craig, where are you from?
Australia, from
Yeah,
Darwin.
nice. Okay, awesome. You know
So
a guy
it's
named Rob Campese by any chance?
yes, I do. Yes.
Okay, yeah, he's running our stuff for a long time, so
Yeah.
he's pretty quick, right?
Yes, definitely.
What's your combo? What do you have?
It's just probably equivalent to a probably like a top sportsman car. Well,
Yeah.
we would call it top sportsman. Like
Okay.
what do you have over there? Yeah, well, it is top sportsman over there, isn't it?
Yeah, what's the engine combo though? Is it what is it?
It's a 706 cubic inch big block Ford.
Okay,
Yep. And it's a nitrous engine.
nice. Okay, good.
So we've still got a lot of stuff to sort out, but it's got a BigStuff 3 Gen 3 in it.
Okay. Yep, no problem. I know we're obviously
Yeah.
covering a lot of stuff the 4 has here, but the 3, a lot of it still applies. It's very similar. You know, again, the
Yep.
3 just has her hands tied in a lot of ways compared to the 4, right? So
Yeah.
it's just
Yep.
one of those things where until you can get into this box, the world opens up to you, but you can still accomplish a ton with the 3. Like a lot of the guys that were earlier today, they actually had to leave, but they still got 3s in their cars just because the damn thing just works so good. So, you know, it's just one of those things. So,
Yeah. I've always run with the O2s open loop. I've never run them closed loop.
right.
But looking at this looks nice, eh?
Yeah, so when we have guys that run this, so everybody can run this basically except turbocharged or supercharged methanol deals, but anybody can run this. So yeah, when you're doing this, it's just the world is just open and your eyes open. And again, the very first time you do it, I mean, these guys have so many runs on this engine, that's why it's so close. But when you have an engine you first start off with, you may have 20% swings either way, you know, in the actual O2 correction per cylinder to get there. And then what you'll do is you'll come in here per gear and then dial in the fuel per gear so that you are reducing that correction, right? So
Yeah.
the whole goal is to take that O2 correction per cylinder, get that down next to nothing. Well, you can only do that because individual cylinder fuel wise, you're programming that table, right, to get there.
Yep.
So, but yeah, it's pretty remarkable of what it shows. And with our guys that are doing manufacturing or R&D, when they first make a whack on something and they change a camshaft or they change intake manifold, whatever, and they see the O2 correction just go nuts per cylinder, they instantly know, you know, what cylinders got hit the hardest, right? With that single change that they did.
Yep.
So that's why it's so interesting with Dan. I hope you guys got some stuff out of the in-cylinder pressure stuff because, you know, Dan obviously actually watches the actual in-cylinder pressure itself per cylinder, and that's remarkable. I mean, it's incredible when you see that actual the pressure pulses and everything else you're working with, but it's pretty cool how the O2 itself works in conjunction with that very well. So that's why we're in development with him. We're going to get his CAN data pushed out over to us. So not only will you have O2s per cylinder, but you're actually going to have the in-cylinder pressure compensation per cylinder as well. So it's going to be pretty ridiculous when that's all set up and done. So, you know, to be able to actually have knock per cylinder and it's real knock, right?
Yeah.
So, yeah, it should be cool.
But he was saying that was around 30 grand. Is that right?
Yeah, it's around 30, and you know, ultimately the price has come down, but the big thing that they're doing with his system, or I should just I believe it's Plex is what he sells. I don't know if you guys actually saw the size of it, but hold on, do you guys actually see the unit by any chance or no? Do you guys see it?
Physically, just from the pictures in the
Yeah, hold on 1 second, hold on. Hey, all right, can you guys see this? That's it right there.
Yep.
So, okay, here's an iPhone.
Yep.
So that's it. I mean, that's to go from the guys have seen the AVL stuff at all, to go from that to this that goes in a race car, sits on an engine dyno that basically does everything you need to do. That's pretty remarkable, right?
Yeah.
So we're really excited about getting development with this guy to be able to do the in-cylinder pressure stuff, because the in-cylinder pressure stuff works with anything. It doesn't matter whether it's, you know, factory stock or, you know, super stock like this setup is right here, or NHRA Pro Mod. I mean, obviously you can't use it for NHRA Pro Mod, which is totally fine. I'm just saying for those type of engines, you know what I'm saying? It don't matter. Pressure's pressure, right? So we definitely want to get more into this as well. So it's pretty neat to have that setup that it was to only have to go to this now, you know? So, but yeah, and again, if you guys have any questions too about the software, you know, time just flies by today, and we never even got really into the high-speed logger section. It just flies by so fast now to actually do the crank and cam positions. But ultimately, it's tough to get the attention span all day long. You know what I'm saying? I wish I could make this thing like 3 days long. You know what I'm saying? But Chip knows the high-speed logger pretty well. When we first got your car going with the crank and cam signals, right, Chip?
Yeah.
So, yeah, it's all part of the fun. But once you get those things dialed in, for the most part, it pretty much just stays there. And again, it's all just part of the original setup, you know? So,
Yeah, it makes things really easy starting. I mean, you set it up and you can look at it before you even crank the key. So,
yeah, exactly. But, yeah, to basically have a built-in oscilloscope, I'll take that. Know what I mean?
Yeah, exactly.
Oh,
Hey, I
yeah.
was messing with that XY, kind of trying to rescale it. But on
Yeah.
my, when I was looking at your computer earlier and looking at what mine's saying,
Mhm.
mine says set Y-axis minimum, set Y-axis maximum. But I don't, yours didn't say that, did it?
Yeah, so here, let's come over here. So I'm gonna go to like the desired dry shaft curves here for SR2. So we'll go back to this window, right? So you got your 3 dots here. So you're gonna set your Y-axis maximum and your X-axis maximum. That's what you're gonna set.
Recording in progress.
So do you not see those in those 3 dots?
Let's see. I see the 3 dots.
So you want to set Y-axis maximum and set X-axis maximum. You should already be at your zeros, 0, 0 on both the start of both of them.
Yeah, I think it was like 10,000 is what it was.
Right, exactly. So that's what we did, right? I drilled in tighter, so you got to make it smaller. So I made the X-axis maximum 3,000 for Y, and the X-axis maximum only 3 for 3 seconds.
Okay.
So that's why it's so blown up now on this table, is because I'm only going to 3,000 RPM and 3 seconds.
Okay, so that's what that is. That's the actual RPM.
Yes.
Okay.
Yeah. So this log I'm pulling up, there's no dry shaft sensor because they don't actually have one on their vehicle.
Okay.
I loaded in their cal from their super stalker, which they can't have a dry shaft sensor. So this is their O2 data that we populated to show. But the RPM toss down here, see this guy here? There is no dry shaft data for this run. But if I go back to that table, if I go to the dry shaft curves, and instead of RPM toss, I do RPM engine and show XY data log plot.
Yep.
There she blows right there.
Yeah, I just changed mine, and it's beautiful now. Basically, it shows you up to the shift point.
Right.
The first. Yeah.
Yeah, and you can change it obviously however you want it to be, right?
Oh yeah, yeah. I just made it to like what you had it set to.
Right. Exactly.
Yeah, but it's that honestly, I just feel like it's much easier to set your curve.
Yeah, I got it. Oh, I should let him sweat a little longer. Shoot. Who walked out with that? Dan was freaking out. He couldn't find this box over there. He was sweating a little bit there. So
I don't blame him.
yeah, right. Right.
Yeah, when he's going through all that stuff, I mean, it literally is mind blowing.
Yeah, that's why I really wanted to have him over here, because it's just, you just can't, again, once I saw for real too, and he was local for where we're doing this, I was like, man, if you want to come on down and talk about this, you got to do that, so.
Yeah, I mean, Pro Stock is definitely the top for drag racers too, because they were just trying to find any 2 horsepower. Like they trying to find everything.
Right. Exactly. Yep. So. Okay, guys. Well, I think we're going to start wrapping this up over here. If you guys have any questions at all, please feel free to reach out to me. We're probably going to, this will be up on YouTube in the next, couple days or so. But if you guys have anything for me at all, I'd be happy to keep going with you guys. But I totally appreciate you guys hanging out for the day, and hopefully trying to pick up on some more. If you guys got a couple things out of it, that's hopefully all that I ask for, is you guys get a little bit more every time you guys look at it, so, but hopefully if you guys have any more questions, or not, hopefully if you guys have no questions at all, you can always reach out to me, just give me a call, or it's support at BigStuff3EFI.com. So, but pretty sure you guys got my number. So if you guys need anything at all. Okay, guys, I'm gonna shut this one down. You guys have any other questions at all?
Nothing for me, bud. Thank you.
All right, guys.
All right, see you.
Thanks, Chip. Thanks, Brian. Thanks, Dan. Thanks, Rob. I appreciate you guys coming on here, all right?